Why do so many different types of companies hire data analysts? Unlike programmers, data analysts aren't only or even primarily hired by software companies. Data analysts are the people who dig into the company's internal data, either manually or with Excel, or for the more sophisticated analysts, by writing Python scripts, automations, and using SQL queries. And even medium-sized companies have a lot of data. Sales data, marketing data, survey data, and their executives do not have the time, skills, or even want to spend the time figuring out what all of that data means. All they know is they want to be data-driven, and they want an analyst to just give them those answers from the data. And the way analysts do that is through visualization, which is exactly where Power BI comes in. Unfortunately, most analysts' dashboards kind of suck. Not because the data is fake, and not because the business is asking bad questions, although that does happen. Usually it's because the person building the dashboard never learned how to clean the data, model the relationships, or choose the right visual in Power BI in the first place. And that's exactly why this course matters for you. Power BI might not be the sexiest tool in the world. We all know that's COBOL. And yes, it means we're firing up Windows for this one. But if you want to work in data, analytics, finance, operations, or really any business environment, you need to know how this stuff works. Power BI is one of, if not the most, widely used business intelligence tool on the planet. And Alex the Analyst designed this course to teach you the real skills that make dashboards useful. But before I throw you straight into report view and have you dragging fields around, let me give you a quick explanation of what's actually in here and how it will help you get the skills that you need to succeed in a career as a data analyst. In this course, you're going to build reports, and you'll actually do it on your machine for a fictional e-commerce company we've called eShop. We'll start simple. We'll import data, get comfortable with Power BI interface, and you'll build your actual first visualization so you can see how raw tables become something that people can understand at a glance. Then we get into the part that actually makes or breaks most dashboards, data preparation. Alex is going to walk you through Power Query, ETL, cleaning up messy data, removing duplicates, basically everything you need to do before you can have the confidence to send a data set to your boss. If the data going in is a mess, the dashboard coming out is going to be an even hotter mess. After that, we'll get into data modeling. And this is where a lot of people who know Power BI actually start to fall apart. It's surprising how many professional data analysts don't know how to make sure all their data relates cleanly. Here you'll learn about star schemas, relationships, and cardinality. In other words, how to build a data model that actually answers business questions. Then Alex will get to DAX. Not the one with the gold chains working on open code, but if you've heard people talk about DAX like it's some sort of dark art, don't worry. Alex is going to make it super practical. You'll learn how calculations really work in Power BI, including conditional logic, time functions, aggregations, iterators, all that good stuff. It's the things you need to know how to do if you don't want to be knocking on a developer's door when you need an answer that can be computed from the data, when the raw data isn't quite enough. From there, we'll expand your visual toolkit. You'll build the bread and butter charts like bar charts, lines, cards, and then branch out into more complex things like pie, donuts, scatter plots, combo charts, hierarchies, all the good stuff. But the point isn't to use fancy visuals just because they exist. One thing I really like about Alex's teaching style is that he keeps coming back to the same principle. Simple charts get used and needlessly complicated charts get ignored.
KISS, keep it simple, stupid. I live by that.
And finally, we pull it all together into a dashboard that actually communicates something. You'll learn design principles like visual hierarchy, formatting, filtering, and interactivity, and how to tell an actual story with the data. Sometimes your boss doesn't even really want the dashboard necessarily, so much as he wants your interpretation of the dashboard. Now, I do not recommend watching this whole course passively in one sitting. Open up Power BI, click around, break stuff, unbreak stuff, build the reports yourself before Alex walks you through his version of the solution. That's how you'll actually pick up the skills you'll need on the job. And as always, all of the content in this video and all of the course content on Boot.dev is totally free. So go to Boot.dev and make an account. The interactive features, however, are paid. So if you want to submit assignments, track your progress, chat with Boots, and earn a certificate of completion, you'll need a membership for that. Luckily, you can use Alex's code, AlexTheAnalyst, for 25% off your next year on an annual plan. That helps support us as well as him and his content. And one last thing, these long-form courses take a ton of work to make. So if you appreciate all of this being available for free, please like the video and subscribe to the channel. A million thanks in advance for doing that. Now, let's build some dashboards with Alex.
Hello everybody, my name is Alex Freeberg, better known as Alex the Analyst on YouTube, and today we are going to be going through the entire Learn Data Visualization with Power BI course on Boot.dev. I have it pulled up on my screen. I am right here in the left-hand side. I am the author. I got to work with awesome people over at Boot.dev, and we're going to be going through this entire course with you guys. All we have to do is start this course. I will have links to everything that you see up here because I'll go and show that to you. But I'll have links to the course, to some documentation that you need, as well as some things that we need to install in order to actually take this course. Now let's click on Start the Course. Now this is just the introduction, a little bit of setup so that we can actually get into it. So we have the data visualization with Power BI. Learn data visualization with Power BI, and in this course, you'll get hands-on experience with building visualizations, reports, and dashboards in Power BI. Now, this is an important note. This is in Windows and PowerShell. Now, we could have used open source tools, and Lane talks about this a little bit right here. We could have used open source tools so any operating system can run this, but Power BI is by far the most popular business intelligence tool in the world. And so that's why we went with it. We went back and forth on which one we wanted to do. We looked at other options, but in the end, Power BI really is just the most popular. If you don't have a Microsoft machine, you can still use something like Linux, or you can use Mac. You just need to use a virtual machine in order to run the Microsoft operating system in that virtual machine. Let's come down here. We are gonna be working with this eShop, and this is basically like our fake e-commerce data that we're gonna be working with throughout this entire course. And in order to submit things and run things within the course, we need to do a few things. One, we have to ensure we're on Windows. That's a check, we're in Windows. Next, we have to open up PowerShell. So let's come right in here. I'm gonna say PowerShell, and there's our Windows PowerShell. And we are good to go. And I'm going to just put this on my right-hand side for just a little bit. We also need to install Golang and the Boot.dev CLI on Windows. Now, I've already done those things because I just want to make sure that I was set up, but it's very easy. All you have to do is come to this documentation, and this is within this link, and I will, again, we'll have that in the description. But all you have to do for installing Go is if you are on Linux, WSL, or Mac OS, you just come to this Webby installer, or you run this right here. Or you can come, if you are on Windows already, you can just use the official Golang installation instructions, which are right here. And you just click on Microsoft Windows, you get the file, it pops right in here, you download it, it's easy to go. The next thing that we have to do is we have to install the Boot.dev CLI. That is again, right in here. Let's come down. So we have to install the Boot.dev CLI. You're just going to run this in PowerShell. So you're gonna take it right here and put it in here. I have already done that, so I'm just gonna say boot dev -- version and run that. And I'm running on the v1.26.0, which I believe is the latest one. So I have everything set up. One thing I did have to do as well is log in, and you just say boot dev login. You're gonna come to this page, you're gonna get this authentication, and you're going to copy this code, and you'll come back down to your PowerShell, and you'll place the code in here. I'm gonna copy my code. I am already signed in, but that's okay. I'm going to paste it in here, and it says I am logged in successfully. So I'm logged in, I have everything ready to go. I'm gonna check these off just so we are good to go. And there we go. And since once you have installed the Boot.dev CLI and logged in, copy and paste the submit command from the right into your terminal and execute it. Now I have not done this, so let's do this together. So we're gonna have our submit, and we should need to copy and paste this. So I'm going to copy this, and I'm gonna come right down here, and I'm going to paste this in. And let's go ahead and run this. And it says, we did it perfectly, and we even gained some experience. Super happy about that, but we did everything properly, and we should be able to kind of validate that we're getting the expected output, which we can right here. We can see all of our text, which is looking like ran perfectly. This next lesson is what is data visualization, and let's read through this, and then we have a little video, and we also need to answer this question. And I think we'll get it right after going through this lesson. What is data visualization? Data visualization is exactly what it sounds like. It's the process of representing data in visual formats like charts, graphs, and dashboards. It makes the information easier to understand and analyze, especially for busy executives who can't be bothered by tricky things like numbers and math. I wrote that. I do feel bad, although it's true. I do feel bad if there's an executive who's reading this now. Instead of your eyes glazing over, staring at numbers in a table, let me actually go back up. A good visualization will help you to see patterns, trends, and outliers at a glance. It's really about turning data into insights. A well-designed visual can communicate complex data quickly and clearly, helping decision makers understand what's happening and why. You as the data analyst create visuals, but who uses them? Most often, these visualizations focus on key performance indicators, also called KPIs, which help different audiences understand how things are going. So we have 3 different areas. One is like executive, C-suite, managers, higher ups. This helps them kind of monitor the company performance and make strategic decisions. Then you should have your classic business teams like sales, marketing, finance, HR that you'll have in most companies. They can track key metrics, campaign results, or budgets in real time. And clients and stakeholders, they can understand reports and insights without needing to dig into the raw data. Now let's come down here and let's watch this video. What would you do if your boss asked you for last year's sales numbers? He wants it broken out by month and by region. Now, most people would just take that data, they'd put it into an Excel file and they just email it over. Personally, this is not what I would do at all. He's gonna have to dig into that data. He's gonna have to create his own visualizations. He's gonna have to look at this raw data. It's not easy to understand just by looking at it. And so what I would do is I would start building out a visualization where he can just look at this. He'll be able to look at the charts and the graphs and the trend lines and the visualization very quickly and spend just a few minutes on it instead of spending hours digging into the raw data. That's what data visualization is. It's taking raw data and it's transforming it into graphs and visualizations and dashboards. The goal of this is to make the information easier to understand. So you're not just looking at the raw data, you're looking at something that you can actually take away and make decisions based off of. Visualizations help you understand what's happening without having to do all the math in your head. Now, who actually uses data visualization? Now, I'm huge into coding myself. I code in a lot of different languages, but not every company uses every coding language. Sometimes they just use SQL, or maybe they don't even use a coding language. They just use Excel. But data visualization is kind of ubiquitous. It's used in all companies and it's used in almost every department within companies. And it's a way for especially upper management to really understand what's going on in the business so that they can make better decisions. They also have specific KPIs that they want to track. Business teams like sales and HR and marketing and all these other teams are going to use visualizations as well in order to track things like their marketing or their budget or their sales or all these other metrics and KPIs that are really important for a business to function well. All of these things are really relevant and useful within data visualization. Even your clients and external stakeholders are going to use data visualization because most of the time they do not want to dig into the raw data. They just want to be able to look at a high level view of what's going on with their business or their data. Now, data by itself is just data. It doesn't actually tell a story. And so once you start interpreting it and understanding what it actually means, that's where you get the insights. For example, knowing that sales dropped by 10% is just data. We understand that sales dropped a certain percentage, but understanding why and how that happened and what actions we can take from it, that's where data visualization actually happens. And that's where you can get insights and actually make them useful. Data visualization helps bridge that gap by making patterns and problems a lot easier to spot. As a data analyst, our job is not just to deliver data, it's to transform the data, it's to make the data useful so we can find insights for our customers, our clients, or our business. Now, we're gonna be using Power BI. And Power BI is one of the most popular data visualization tools in the world. Power BI is also called Microsoft Power BI because Microsoft owns it. So it's going to be in Microsoft's ecosystem. You are going to be able to do so much within Power BI. We're going to learn all about transforming the data, about modeling the data, about building visualizations and creating entire dashboards. If there was one BI tool that I could tell you to put on your resume, it'd probably be Power BI. If you want to work in data visualization, Power BI is probably the best one to have on your resume. I like that video, but boy, do I need a tan. That is my real skin tone though. I actually may be even more pale. The real job of data visualization is to blank. It says, make the CEO feel like the smartest person in the room, create pretty graphs, call attention to real business insights, aggregate data from multiple sources. I'm gonna give you just a second to decide what you think is the answer, and then I'll solve it. All right, that's enough time. We're gonna go right down here to call attention to real business insights. Let's go ahead and run this. And we got that correct. The next lesson is what is Power BI? And this is important because we're about to dive into Power BI and do a lot of different things. So it is important to know what Power BI is. Power BI is a data visualization and business intelligence tool from Microsoft, first released in 2015, and it makes data analysis and reporting easy for everyone, not just technical experts. That's true. I once was not a technical expert, but I can still use Power BI. We're using Power BI for this data visualization course because as of 2025 and still in 2026, it is the most popular BI tool in the world. And right here, you can see it takes about 36% market share. That is a lot because there's a lot of different tools, and I've used most of these. It's a very popular tool, but it does mean, and this is Lane talking, it does mean that we need to use Windows, Shutter. I like Windows. I have no problem with Windows. I've been using Windows for like 10 years, so Windows is fine for me. But I do understand I just now started using a Mac. I totally get it. But Windows is huge in the business intelligence, accounting, and finance world, so it makes sense that Power BI is too. It's all just under the Microsoft ecosystem. With Power BI, you can connect to data from many different sources, transform it, and create dashboards and reports, and help you understand your data quickly. Power BI is best known for interactive dashboards, ease of use, integration with the rest of the Microsoft ecosystem, data connectivity, sharing and collaboration, and automation. And those are all facts. It gives you the tools to explore, understand, and share information confidently, all in one seamless interactive platform. In our opinion, it's the best tool for learning real-world data visualization skills. Let's install Power BI on your machine. Now, again, installing Microsoft Power BI is super simple. I already have it on my computer, but it's like installing anything. We're gonna open up this Microsoft Store. Let's go ahead and do that now. I'm just gonna show it to you, but I already have this. So here you can get the Power BI desktop. That is what we need. So go ahead and just download and install that. Then we just need to search for Power BI desktop, click install, and let it download automatically. And so this is what you should be getting. Now I can come down here. I can still do this. I'm gonna say Power BI. And there's our Power BI desktop app in Windows. And so we should be good to go. Let's keep going down a little bit. If you want to download it from the Microsoft website, you can also do that, or go to this download link. But you can come here and you can also download it from the actual Microsoft website as well. And then we just need to download that and run it as the executable file. So you can do it either way. I think the app is perfectly fine. Once Power BI is installed and you've verified that you can open the program, submit the CLI test. So we're gonna basically test to make sure that everything is working well. So let's get this right here. We're going to copy it. We're gonna go down. We're going to run this in our PowerShell, and let's run this. And woohoo, we did it perfect. We have everything installed. We got our points, and we got the exact output that we were looking for. So we're good to go. All right, so let's get into lesson number 4, which is the UI walkthrough. It says, before we start mucking around in earnest, it's important to understand the Power BI desktop interface. Knowing where things are at a high level will make everything smoother down the line. Power BI desktop is made up of a few key areas: the ribbon, report view, data view, and the model view. And let's open this up. So here's what we need to do. We need to come right down here. We need to search for Power BI. Let's open up our Power BI on our Windows machine, if you have a Windows machine, or on your virtual machine, and we are good to go. Now I'm gonna open up just a blank report. I'm sure if this is the first time you've ever used Power BI, you're gonna get this too. Yeah, I don't know why those icons aren't showing, but that's okay. So let's get rid of this. The first thing that we need to look at is this ribbon. This contains most of your primary tools organized into home, insert, modeling, and view. So let's go into just look at our ribbon. So this is our ribbon up here. This is where, there's a lot of things that we can do in here. It just depends on kind of what we're working with and what we're trying to do. But yeah, this is our ribbon right up here. Now let's go down. We have our report view. Now the report view is where you'll build and design your visualizations, the large canvas area. In the center is where you drag and drop visuals to create reports, and the small icons on the very left under the ribbon allow you to switch between views. The top one with a report icon is the report view. And this is me. This is where the magic happens. You'll spend most of your time creating charts, visuals, and dashboards here. So let's make sure we know where we're going. We are already in the report view. We have some, to get started options, right? Just get started with importing data from a, place. We also have our visualizations over here. This is where we'll be able to see our data once we start importing it and getting it all ready. And then right over here, this is the different types that we can choose from. If we want a funnel, if we want a 100% stacked area chart, we'll cover basically most of these in this course. And so this is where we do a lot of the work of actually building the visualizations. Let's go down. Next, we have the data view. Directly below the report icon is the data view, or depending on the version of Power BI, the table view. Two names for the exact same thing. Hey, here you can look directly at your data set similar to a spreadsheet. You can inspect the rows and columns of your data, verify transformations, and rename and reformat fields. And I say, this view helps you double check that your raw data is actually what you expect before you try to visualize it. Now, we don't have any raw data in here just yet, but in this table view, this is where our data will be. And is 100, once we get into it, you'll see this is where we can really make sure we have the right data types, which are really important because certain visualizations you can only use certain data types for, which makes a lot of sense. And so we'll cover all that once we get into there. Let's scroll down a little bit more. We have the model view. Now the model view is the bottom icon on the left. This is where you manage relationships between tables. You'll see the datasets as boxes connected by lines. Here you can create relationships, edit existing relationships, and see how your data models interact. Let's go into our Power BI and let's go to our model view. And it will kind of look like this actually. This is pretty similar. Once we actually start getting data in here and we start, looking at the relationships, seeing, cardinality and, the way that the data flows and one-to-many relationships and all those things, this will be right here, and it's not as difficult as it sounds, especially once I explain it, you'll get it pretty quickly. It's not anything too intimidating. Let's go right here, and that's all we got for the actual lesson, but it says blank is where our pretty charts will go, while blank is where we can see the data behind those charts. Go ahead, make sure you can get this. It says the view starring Whoopi Goldberg, the view starring Joy Bayer, I don't know if I said that right. The ribbon view, the data view, the report view, the data view, and the data view, the report view. Now, the blank is where our pretty charts go. We know that that's the report view. And so we have the report view right here. And then blank is where we can see the data. And that's the data view. So it's going to be this one right here. Let's go ahead and try it. And there we go. And I even got a little achievement award. I'm doing good. All right, now we're going to be moving on to the next lesson, which is creating a report. It says, now that you're familiar with the UI, let's create and save a new blank report in Power BI. This will be the report that we work on for the remainder of the course. We won't load any data just yet, but it's important to make sure things are set up correctly. So basically what we're gonna be doing is saving a blank file. And that's all we're gonna be doing. So we're gonna make a new directory somewhere on our computer. We're gonna put it in this DataViz project folder. So that's what we need to do first. So let's come in here. Now, if we actually go into our PowerShell, here is our current directory. And so what we're gonna be doing is we're gonna be basically creating a new directory so that when we run stuff in our CLI, it's gonna hit off of our new directory. So let's come over here and I'm just gonna place it. I'm in my AlexF folder right here. So this is our current path, C users AlexF. And I'm gonna basically just create a new folder. So I'm gonna say new, do a new folder, and we'll call this DataViz-project. And so now we have this new folder. I'm gonna open it up. And now we have this new path right here. So I'm gonna go CD, and then in quotes, I'm going to change this just so we have our new directory. I'm not 100% if we have to do that, but that just makes the most sense in my opinion. So next thing we're gonna do is we're gonna open up Power BI and we need to check some settings first. So let's open up Power BI and I'm gonna actually bring this right over here real quick. Because all we're doing is going to options and settings. We're going to options. And now we need to go to preview features under global and we have to make sure that these three are checked. So those are really important. The next thing we're gonna have to do is if we come right down here, we do need to do one more thing in here. So I'm just gonna do it now, which is under regional settings, we have to make sure that this is English United States. It's just a double check. This is just important for when we save things and we check things through the CLI. Now what we need to do is create a blank report and we're already within this blank report, so that's perfect. And then we need to save this as eshop.pbip, not the .pbix, which is the default. So we're gonna come up here, we're gonna say save as, and now we need to actually go to this folder that we created. So let's come up here, let's go to AlexF. We have our DataViz project right here, and now we save it as eshop, but we're not saving it as the PBIX file, we're saving it as the PBIP file. Very important difference. Let's go ahead and save this. And so that is now saved. What we now need to do is we have to run this to check to make sure that it actually is working well. So let's copy that. Let's go to our PowerShell right here and let's paste this in and let's go ahead and run this. And it looks like Boot.dev is just putting out new stuff. Let's go ahead and say Boot.dev upgrade real quick. We'll upgrade this and then we'll run the exact same thing. All right, looks like we are good. Let's go ahead and paste this and run this. And it looks like it worked perfectly. And there we go. All right, let's move on to the next lesson, which is importing data. Now, before we can start visualizing data, we need to get our hands on some data. CSV files are simple text files that store data in a structured format, making them easy to read and write, and very common for exporting rows and columns of data from databases or spreadsheets. Let's download the CSVs we'll be using throughout the course and import the first ones into our Power BI project. Yeah, CSV files, use them all the time. I'm sure if you work with computers at all, you're very familiar with CSV files. Now here is our assignment. We need to download the bundle of CSV files in a zip archive and extract its contents into the folder that you made for this course. Make sure you have all 7 CSV files at the root of the same directory where you saved the eshop.pbip. So let's go ahead and open this up. It's gonna prompt us. What I'm actually gonna do is I'm going to pin this to the quick access. So it's right here, just so I can click on this and we are in it. Now I'm gonna save this so that we have this zip folder right there. Now that we have it zipped, let's just go to the location and we have all these files. All we have to do is you can either unzip it or you can copy and paste like I'm going to do. Either one is perfectly fine. I don't think we need this zip folder anymore. At least I hope not. We will see. Now, let's move on to the next part because now we have those saved. It says in Power BI, with the eShop report open, go to Home, Get Data, and Text CSV. And then we're gonna select our customers.csv so that we can preview it and load it. So let's go ahead and do that first. Let's come in here. We're gonna go to Home, Get Data, and then we come down here to a Text CSV. Now the one that we want is our customer CSV. So let's go ahead and click on this and open it. And we should get a preview of our data. And there we go. So we have our preview of our data and this looks great. Let's go ahead and load this data. So now really quickly, a few things have changed. One, in our data tab right over here, now we have information in our data. And so we have this, and as well as this hierarchy within our date column, but we have all of this data in here. And if we come over here, we can now go to our table view. We can see that we have data in here. So this looks really good. Let's come back. And it says before creating a visual, click on the table view, which we just did. We see we have the data there. But now to make sure that it saves the metadata in the format that we expect, go into the model view on the left sidebar and click on the header of the new customers table and just drag it to a new position. We're just changing the position of this tab right here. So we're just gonna grab this and I'm gonna bring it over here. It's really simple, but it is gonna change some of the metadata. And now all we're gonna do is, I'm pretty sure we're just gonna save it. Let's confirm. It says save the project, then from the root of your course directory, submit the CLI tests. Right, so that's why I saved it at this root, by the way, for the data viz dash project, was just so that's our, our directory that we're actually using. So let's go ahead and save this. So I'm gonna come up here, I'm gonna do file, and I'm just gonna say save. That's all we have to do. So it's gonna save it in the same place that it was saved before, which is in that file path in that directory. So now that that is done, let's come over here and we're going to go ahead and submit this. So we're gonna come right here and we're gonna paste this in and let's go ahead and run it. All right, looked like everything worked perfectly. We got all of this going and we are good to go. All right, let's get started on our first visualization. We already have our customers' data imported into Power BI. So now we're going to actually build something in our report view. So it says in the visualizations pane on the right-hand side of the report, click the clustered bar chart icon and resize the resulting chart to take up the full canvas. So we're doing a clustered bar chart. So let's come over here and it should look like this. That's a clustered column chart. Here's our clustered bar chart. And they want us to, when I say they, it's me. I want you to resize it to this size so it's filling up the entire screen, or at least the entire part where we can build. So that looks good. It says in the data pane, all the way to the right, expand customers and then drag the customer payment type field to the y-axis under the visualization pane. So we have our customer payment type. Let's come right over here to our Power BI and let's find the right column. Now let me scooch this over just a little bit. So here's our customer payment type and we're supposed to drag this over to the y-axis. You can drag it. You can also just click on it, right? If I click this little tab right here, it says boom, it'll put it into the y-axis. If you want it into something other than the top one or the one that makes the most sense for that visualization, you do drag it. So it depends on what visualization you're using, but it'll often try to understand where you're supposed to put it, whether it's a value or a legend or something like that. So now we have our customer payment type in there. Let's go ahead and take a look at what we do next. So it says, drag the customer ID field to the x-axis. Let's see what I say. It says you can also click the checkbox next to the correct field / column in the data pane, but I prefer to drag it over. That is true. I don't like things being just done by default. I like to explicitly do them. I don't like when Power BI just does things for me. I like to make sure I'm doing it myself. So customer ID to the x-axis. So let's come over here to customer ID. Let's drag this down to the x-axis. And now we have this bar chart. Now we can zoom in, we can zoom out, we can, do a lot of different things with this. We also have some formatting options down here where we can go to next pages, or we can look at it like on a mobile or a computer, and we can zoom in. So if we want to zoom in a little bit more or zoom out a lot more, we can do that. As long as it's, you can see it, you should be good to go. Now, it says when you drag a field into the visualization, Power BI chooses an aggregation function automatically. And we can see that right here. So let's come over here. If we look at this, it automatically took the sum of the customer ID. Now I'm guessing, because I know myself, we're gonna come in here and we are able to select different aggregations, right? It's grouping the data and then it's performing this aggregation. So we can change it to a lot of different things. Let's go see what I asked it to do, just so we know. But what we actually want is the count distinct. This is what we want on the x-axis, to show the number of distinct customer IDs for each payment type. In order to change the aggregation, click on the drop-down menu of the customer ID in the x-axis box and select count distinct. All right, let's go ahead and do that. So we're gonna come over here. So instead of sum, we're gonna do count distinct. Now count would mean if somebody used a card multiple times and their ID kept popping up 3, 5, 10, 100 times, we're gonna count each one of those rows. But if we want to do count distinct and just look at the unique customers, we use that count distinct. So let's change this. And this looks really good. Now, there's a lot more that we're going to do with these visualizations in future lessons, of course, but this is like the simplest version. And if you hover over this, you can see count of customer ID 89, 34, and 7. I think this is looking good. Let's come back. It says everything is working and Power BI should now have the customer count for each payment type. Save the project, and from the course directory, submit our CLI. So let's go ahead and save this first. So let's come up here. We're gonna hit save. Let's come over here and grab what we need. We'll go to our PowerShell. Let's paste that and let's run it. And we got it right. We're doing great. We are doing really, really well. All right, let's move on to the next lesson, which is updating the title. It says, our first visualization is neat and all, but the title looks a bit off for professional data analyst like yourself. Let's take a look at our assignment. So we need to change the title and its position. So we're gonna select our chart and click the format your visual in the visualizations pane on the right-hand side. So let's come back in here. We have our visualization. If we don't have it selected, we don't have these options. So we need to select it, and then we have this format your visual. Now, let's go back. I know what we're supposed to do next, but I want to follow along. Next, we're going to click on general, and here's how we customize the text, size, position. There's actually a ton of things you can customize. Basically, everything you could imagine, you can customize in these two panes right here, whether it's the visual or the general. And we're going to change this to customers. I'm going to copy this because I'm very smart. And then we want the font size to be 24. So we're changing our titles text to be a different size. So let's come in here. We're gonna go to title. We're gonna change this to customers by payment type. Then we're also gonna come in here and change this to 24. You can also select into it and select 24. So we have customers by payment type right here, and that looks really good. Now, let's come over here, and it says, and the horizontal alignment to the center. And I usually do this, depends on the visual, but I usually do this. What that is right here. That's our horizontal alignment. If we hit center, we have it centered on our visual. It just looks better, right? It doesn't change anything other than where it's actually located. I think that looks great. Let's come down, save the project, and we are going to submit this. So let's go ahead and we're going to save this. And just like we've been doing before, after that is saved, let's come down here. We're going to take this and we're going to paste this in here. Let's go ahead and run this. And there we go. All right, let's move on to the last lesson in this first chapter. It says saving reports. For most of this course, we'll be using the .pbip, or the text-based file format, because it's easier for the Boot.dev CLI to check. However, the .pbix, or the Power BI report file format, is the standard for Power BI reports and generally speaking is the better choice for data analysts working in GUI, graphical user interface environments. And this is 100% true. I don't think I've used the .pbip file much outside of this exact use case. Most of the time I'm handing this off to another analyst, or I'm passing this off to a team, or something like that. It's almost always a .pbix file. Next, it says the .pbip is a newer file format introduced in 2023. It's mainly used by developers who want to store Power BI reports as text files so they're easy to track in version control like Git. It's important to note that the data files themselves, in our case the .csv files, are not stored in the .pbip file. The .pbip file contains metadata about the data sources, transformations, and visualizations, but for your report to work, you also need the original data files. So if you save the .pbip file, you're not saving the underlying data for your visualizations. You're just kind of saving how you transformed it, how you made those changes. If you want to actually share your visualizations with the data, you have to do the .pbix file. Now, let's do our interview with Boots. When might you use the .pbip and when might you use the .pbix? Well, as we just discussed, the .pbip file is great when working with developers or for version control in Git. And the .pbix file is great for showing your work with other analysts or clients. Let's see what Boots thinks about that one. Well done, and we got our points. There we go. All right, so let's move on to chapter number 2. We are taking a look at data types. Now, before we build more charts in Power BI, we need to understand data types. Data types tell Power BI what kind of information each column contains: numbers, text, dates. You get the idea. And that is very true. Data types are super important, just in general, but especially when you're building visualizations. Only certain data types work with certain visualizations. It says, see, the type of data determines the kind of visualizations you're allowed to create. Oh, I was just saying that. If Power BI doesn't know whether a value is a text or a number, it can't decide how to group, sum, or compare it. Let's go over the most common data types, and let's go ahead and watch this video. One of the biggest mistakes that new data analysts make is not understanding that data types impact basically everything you do in Power BI. And it seems like a really small thing, but as you start building out your projects and as you start building out dashboards and all these visualizations, if you don't do this at the beginning of your project and get your data types right, it can cost a lot of time later on. Every column in Power BI has a data type, and it just tells Power BI how the values in that column are supposed to be treated. Some of the most common data types that you're going to work with are things like text, whole numbers, decimals, dates, and booleans. The data types affect the visualizations a lot. So if you have something stored as text, you cannot sum it. You can't aggregate it and then see, hey, how much do all these add up to? So you can't do that with text. And if you have date values stored as text, you can't use it for time series analysis. These data types have to be stored in the proper way. Otherwise, you can't use them for a lot of different data visualizations and charts and graphs within Power BI. So how do you change data within Power BI? Well, there are two main ways. The first one is in Power Query. You can just go and select a column and you can specify the data type that you'd like during the data cleaning stage. You can also change data types directly in the Power BI model view or table view, but I will say I almost always do it in Power Query because Power Query is kind of the ingestion process. And so if you do it there, later on down the road, you shouldn't have to do it. And especially if you start making automations, it is better to do it at that stage because it automatically makes those data changes if you refresh your data. And that is a very good thing to do. As I mentioned earlier, it can also affect your charts. For example, if you're creating a bar chart, you want to have text or string as your category, but then for the values, you most likely want them to be numeric or a decimal point. Power BI needs to know that that is a numeric column, but if it's being stored as text, it's not going to be able to be used in a bar chart. And of course, that is going to cause issues. If you try to create a line chart and you have a date stored as a text, you won't be able to create that date and put it on the x-axis. It's just going to error out and it's not going to work at all. Boolean values are often used as filters, like showing active versus not active records. If they are stored as text, Power BI is not going to read them in as true or false, and so it might mess up that filter. As you can see, data types are really important, and they're important to get right early on. So anytime you're importing data, make sure that you have the right data types. All right, so that kind of sums up what data types are and how they work in general, but we have specific types of data types that you're gonna see within Power BI. One is just text or strings, and these are used just for any free text thing that you could think of. So that's country, email, product name, user review. It could be anything. You'll usually use these text fields as categories or labels on your visuals, like the y-axis of a bar chart or slices of a pie chart. Text data is great for labeling visuals, but don't expect to run any math on it. That is true. You're not going to use this for any type of aggregation, any type of summing of that data. That's why we have these other data types like whole numbers and decimal numbers. We have whole numbers are used for numbers without decimals. So it's just like 1, 2, 3, 4, just a whole number. This is a population, a quantity sold, a number of orders. You can't have a population of 75.6 people. That's just not gonna happen. Then we have decimals, and decimals are much more granular, much more specific for certain use cases, like the sale quantity, the product list price, which could be $10.72, and a sale discount. And so you'll often visualize decimals with bar charts, line graphs, or area charts to show amounts or trends. Next, we have date, time, and Boolean. Now, all of these data types are just you have to know how to use them and you have to understand them. Date formats are usually sometimes the trickiest to work with, just because you have to format them right. They have to be read in properly by Power BI. So this one is really important, but it's used for anything that tracks time or dates, for example, order date, year, and a timestamp. Perfect for line charts and time series analysis where you want to see how things change over time, like a line chart, like we'll get into in future lessons. Next, we have Boolean. Now, this is our last data type. It's used for yes, no. It's basically a true or false. It either is one or the other. It can't be both. And so we have, is this member active? Are they even a member? Did they pass? It's just a true or false. And we store it like that instead of using free text, because if you have free text, then it could be other options. Other options could get in there. And if you just want to have this binary yes or no, this is the data type for you. Let's go over here and let's look at this question. It says, which of the following is not the same data type as the others? We have 69, 420, 1337, then we have this decimal right here. So these are all whole numbers, and then we have this decimal. So I am confident that is this decimal. Let's go ahead and click on it. And there we go. Now let's get into the next lesson, which is changing data types. It says from the data table view, you can manually change the data type of a column if Power BI misinterpreted it during the import process. This happens all the time with things like dates and numbers, and you always want the most accurate data type for each column. To change a type, use the drop-down menu as shown below. So we have right up here in our column tools, when we're looking at our data view, we can come up here and we have this data type, and then we can just specify what data type it actually is. So that's pretty straightforward. What we're gonna do is we're gonna import the website sessions.csv. So we're gonna import that using home, get data, and text CSV. And then we're gonna go to the data view. So let's do that first. Let's come over here and let's go back, or we can go to get data and we'll go down to text.csv and let's import this website sessions. So let's bring this in. We should get our preview right here. And now let's load our data. Now you can see on this right-hand side, we have our website sessions, and we can also open it up right here in our table view. Let's click on website sessions, and there we go. So now let's go back, because we've done those first two. It says in the data pane on the right, notice that you can now switch between customers and website sessions. That's just what we did. Click on website sessions to select that table. Power BI should have properly detected the session purchase made column that it contains Boolean true or false. But for practice, change it to a text column. So let's go back to our Power BI, and right here we have session purchase made. Now, if we click on this, we do have the data type as true or false. So it worked perfectly, it read it in properly, but we're gonna change this to text. And now that we've changed it to text, now it looks like this, looks a little bit different. And now we are going to save this. Actually, I wanna confirm we need to do that. It says save the project and run the course directory submit from the CLI tests. Okay, so let's go ahead and save this. So we're gonna hit save. And now that's saved, let's come back down and we're gonna take this and we're gonna go back down to our PowerShell and let's paste it in here. Oops. And let's go ahead and run this. And there we go, we nailed it. All right, let's move on to the next lesson. This one is just changing it back. So it's going to be pretty straightforward. It says, okay, you get it. We can convert data types in Power BI, assuming the values are amenable to both types. However, a Boolean true/false value is more specific than a text string, so that's probably the type we want for the purchase made column. The assignment, change the session purchase made back to true/false type, and then we're going to save it and submit our test. So we just literally have to change it back, and that's right there. So now we're going to change this data type. We're going to say continue. And now we've changed it back to the true false or the Boolean value. Let's go ahead and save this. There we go. And let's come in here. Let's grab our test and let's go submit it. And there we go. We nailed it. All right, let's move on to our next lesson, and this is bar and column charts. It says, let's dig into some data. All right, so let's move on to the next lesson, which is bar and column charts. It says, let's dig into some different types of charts. Starting, of course, with bar charts. Those are classic. You'll see them everywhere. They're probably the simplest form of chart out there. It says a bar chart displays data using horizontal bars. Each bar represents a category, and the length of the bar represents its value. Here's an example from a different data set. And so it's pretty easy. We have our y-axis, we have our x-axis. This is basically what we built earlier on. So it's really straightforward. What are bar charts good for? They're good at comparing total values between categories like sales by region, revenue by product and category, highlighting differences across groups, and showing rankings or proportions. It says right here, bar and column charts are great when you have a category like region or product category on one axis and a numeric value like sale quantity on another axis. That is very true. Next, we have vertical versus horizontal. I'm going to give you a spoiler. They're almost the same thing. A column chart is just a bar chart with a vertical bars instead of horizontal ones. Hopefully that's obvious. Yes, I hope that is. I prefer bar charts, which are horizontal, when I have long category names or many types to compare. I prefer column charts or vertical when I have fewer categories and want to emphasize height rather than the length. And that is true just because if you put long names right here, they start running into each other and it looks really weird. Whereas the long ones just will have more room here. And so that is why I would use one versus the other. Now, we have to click the plus sign at the bottom of the page on the report view to open a new page. And we're gonna rename it to customers for page 1 and sessions for page 2. Customers and sessions, I need to remember that. All right, so we're gonna come down here. We're gonna go to our report view and we're gonna create a new one. Now we need to, I'm gonna right click and click rename. That's gonna be customers and, oh boy. I guess I didn't need to right click. I can just double click into it. And this one I think was sessions. Is that correct? Oh, see, I need to get rid of that first. Sessions. Let's go make sure I did that right. All right, customers and sessions. We nailed it. You can rename a page by double clicking its tab at the bottom of the screen, or you can right click and click rename. Either one's perfectly fine. Now, in the visualizations pane on the right, click the clustered column chart icon to add a new chart. And then we're gonna resize it to take up the top half of the canvas. Okay, so let's come over here. We have the clustered column chart. I'm pretty sure that's what it was. And then we're gonna snap it to the top half, just like that. So we have, oops, let me go back. We have it doing the whole top half. And it should snap into both. Let's go back. So we resized the top half of the canvas. Notice that you can snap the bottom of the chart to the halfway point. From the website sessions data in the data pane, drag device type to the x-axis. So let's go get device type, which is right here. And we need to click into our visual first. So we have our device type and we're doing that on the x-axis. There we go. And next, we're doing the session pages visited on the y-axis. So let's get session pages visited on the y-axis. This is looking really good. Now, there was one last thing. It says, title the new chart, pages visited by device. That's it. Page, actually, I'm gonna copy that because I don't know how to spell. All right, let me Control C here. Let's go into this. Let's go to our format, general title, and pages visited by device. So this looks good to me. I think we followed everything exactly how we need it. Let's save it and submit our test. I'm gonna copy this while we're here because I'm feeling audacious. Let's go ahead and save this. And we can just pull up our PowerShell from here. And actually, I wanna see the fireworks when they go. So I apologize, I lied. All right, let's see if this works. And there we go. All right, let's move on to the next lesson, which is line charts. This is what we were talking about previously. Line charts are really great with dates, right? So in this one, we'll be looking at dates, I'm sure. It says a line chart connects data points in a continuous line, perfect for showing chronological trends. And here we have, I didn't put this in there. Lane absolutely took this over for some, Lane absolutely took this over and put this in, but it says, I know the example above is not Power BI, it's Google Trends, but let me have my fun. All right, guys, let's let him have his fun. What are line charts good for? It's good for showing trends and patterns over time, comparing multiple time-based series, or highlighting increases, decreases, or steady trends. Line charts are perfect for when you have time-based x-axis like date, date month, or date week, and a numeric y-axis like sale quantity or product list price. So let's look at our assignment. While we're still on the same sessions page, and so this is what we're gonna be building out here. While we're still on the same sessions page, we're gonna click the line chart icon in the visualizations page, and this should add a line chart below our column chart and have it take up the last half of the page. So let's click on our line chart. So we're gonna come right here. Let's click out of this, and let's get our line chart, which is this one. And it looks like it took up the bottom half, so we're good to go. Next, drag session date to the x-axis and drag session pages visited to the y-axis. All right, so we have session date to the x and session pages visited to the y. All right, that doesn't look very good, and that's okay. That's kind of the default, and we'll see why it looks like that in just a second. So now you'll likely see all the data on a single point, which is not ideal. Click on the dropdown next to session date in the x-axis and change it from date hierarchy to session date. This should expand the date to show day by day. So let's go ahead and do this. We're gonna come right here, and if you drop down like this, instead of doing the date hierarchy, we're gonna do session date. And there we go. So now we have this trend, or not necessarily a trend, but we have this chart which shows the sum of session pages visited per day. So this is really useful. Let's come back, and we need to title the chart Pages Visited by Date. And let's copy this. I just worry about my spelling. That is my genuine concern. I will mess something up. And let's change that right here. And this looks good. Now, just to confirm, I'm pretty sure we're just gonna save this and submit our test. Good. Let's save that, or copy that at least. Let's come up here and save it, and there we go. So now let's run our test to make sure that we did everything properly. Perfect. All right, let's move on to our next one, which is multi-line charts, which are very similar to line charts, except now we're tracking multiple things broken out. And so let's see how we can do this. If you have multiple categories in your data, you can draw different lines, one per category. Here's an example of an unrelated data set. And we have this, and you can just see there are multiple different lines. So you can kind of see broken out by a category or something like a product. We can see how it trends over time. And here's our assignment. On your same pages visited by date chart, drag the device type column into the legend field in the visualizations pane to create one line per device type. And then we'll save and submit it. So all we're gonna do is we're gonna drag our device type, and let's click on this first. Let's drag our device type down here to the legend. And as you can see, now it's broken up by this device type right here. So we have our device type desktop, mobile, and tablet. Desktop is obviously just kind of more popular in general for how people are accessing this website. But recently, looks like it's pretty similar across all of them. I mean, it's not that much different. So this is really interesting. We used to have mostly desktop, and now that's kind of trended down a little bit. Just interesting to look at. All right, let's come in here. Let's grab our test. Let's go to our PowerShell and submit it. And I failed because I just realized I didn't save it. This is an amateur mistake. Don't be like me. Save your stuff. All right, let's try this again. And there we go. And I got a bunch of other stuff. This is great. I'm doing really good. All right, let's move on to the last lesson in this chapter, which is best practices. It says, while many charts technically work, the best kind of work for a given data set, that doesn't mean all charts are a good fit. Bar and column charts compare categories. Line charts show change over time. Pie and donut charts show proportions and percentages. Maps visualize location-based data, and tables display precise values when needed. And this is 100% accurate. You can actually do a lot of different types of visualizations with specific data, but that doesn't mean you should do it. For example, I've given a lot of stuff to like C-level execs, and when I give it to them and it's a little bit too complicated, it's like a ribbon chart or something, sometimes they don't understand it. And this just because they're not data people. They need something more simple, right? They're maybe, economists, or they have an MBA, or they're just not used to that type of visualization. So you have to kind of, I would say, dumb it down a little bit in some cases, or just choose the one that makes the most sense. But don't worry, we will also cover things like pie, donut, map, and table charts later. And that is absolutely true in the next module. Now, here's some rules of thumbs for the right charts and organizing these reports. Now, this first one is the most important one out of all three. If there was only one you could take away, it's this one. It's simplicity. Use only the visuals you need to tell the story. Avoid unnecessary effects like 3D charts and shadows, looking at you, word art. Don't overload a single page with too many visuals. Use multiple tabs if needed. Focus on one key message per chart. And if your audience can't understand the chart in 10 seconds, it's probably too complicated. Now, I've been in this industry a long time. I've seen really complex dashboards that are not easy to understand and read. And it makes it pretty useless, right? Unless you really know your stuff and you can do it. But if possible, you want to kind of simplify it for the everyday person, just so that everyone can understand things and they don't get confused. So simplicity is 100% the most important one to do. Next, the best practice of consistency is keep font sizes, titles, and layouts uniform. Use the same capitalization and terminology across charts. Use consistent data formatting, all percentages or all currency. Don't mix unrelated chart types on the same report page. Now, this actually is really easy at most companies. I know many of the companies that I've worked at or I've consulted for, they just have standardized formats for their dashboards. So you don't usually have to think about this too much. But if you're building something just for like a personal project and there's no standardized formats, then this is something to take into consideration. Lastly, we have readability. Ensure there's enough contrast between text and background. Avoid overlapping labels or tiny fonts. And then lastly, keep spacing clean and even. So these are all just really important kind of things that I've learned over the years, building visualizations for, people on my team, for external teams, for managers, for C-level. These are things that, you kind of learn. Now, let's go through our interview with Boots. We want to make sure we have to keep chatting until Boots is satisfied with our response, and he will be. Let's try this out. Your client wants to know how many sales happened in August, broken down by country. You ask them what they're trying to figure out, and they want to know which individual companies, if any, are responsible for over 20% of total sales. Which chart type of the ones listed in the lesson over here would you choose and why? There are a few that you could use here, right? We could use tables and it could just display the data. We could use a pie and donut chart. We could use a bar chart, but specifically for percentages, which it says right here, that's when I would use something like a pie and donut chart. And there's a ton of memes online about nobody liking or using them, but they do get used, and this kind of is their use case. So let's write out here, let's say I would use the pie chart or donut chart because it displays percentages well and would be the best choice. Let's go ahead and type this out. It says a solid start. You've correctly identified this. But there's a little bit more information. So it says there's a little bit of difference between these. Let me press you a bit further. The lesson also mentions bar and column charts. Why wouldn't those be a better choice here? I would say they wouldn't be a better choice because you'd have to convert the numeric into percentages, and it would be harder to see percentages in a bar chart. Let's go ahead and see what Boots says on this. Excellent reasoning, you nailed it. Correctly identified this, and you also explained, and we got our points. Let's keep going. All right, everybody, let's move on to the next chapter, which is colors. It says, now that we've built our first bar, column, and line charts, it's time to make them more visually appealing. Colors aren't just for style. They actually help your viewers more quickly and accurately understand your data. You can use color to highlight important categories, differentiate between series, and use contrast to call attention to key values. Of course, sometimes color is just for style. It's great to use color for matching your company or client's branding and keeping your dashboards consistent and professional looking. Those are all true things. Back when I worked at AmerisourceBergen, which is a big Fortune 5 company, we had a very specific color scheme or template that we used. And oftentimes colors weren't necessarily used for drawing attention to things. It was more about branding, which, sometimes I had conflicts with, but that is a very real thing. Now, here's our assignment. Click on your clustered column chart with the pages visited by device to select it. So let's come over here and let's select our pages visited by device. So we're gonna select it and let's go back. It says in the visualizations pane, click the format your visual or the paint icon, expand the columns section. So we're gonna go to the format your visual. Let's come right here, format your visual, and let's go to the columns pane. So we have it right here. And as you can see, we have our colors right there. Let's see what we're supposed to do. It says, you'll see a dropdown with a selection for each category or a series in your chart. Set it to all if it wasn't already, and update the color to a pink red theme, color 8. So let's come in here and let's see. We're gonna come in here. We have categories for all, so it's not just gonna be one. Let's come down here and for color, we're gonna do this pink red, and this is a theme 8. Let's see, that's theme 5. Theme 5, 8, and it looks like it's one of these. I'm not sure the exact one. Let's try this one. This looks correct. This looks similar. Update the color to a pink red. Maybe it's the other one. Let's try the other one real quick. I want to see if that one looks more accurate. Yeah, I think it's that one. All right, so now we're gonna save it, and then we're going to, then we're going to submit our changes. So we just saved that. Let's come down here. Let's get this. And let's come in and let's go ahead and submit. And there we go. All right, let's move on to the next lesson, which is conditional colors. It says, changing the entire chart's color is fine, but it's often more useful to change colors based on the data itself using conditional formatting. 100% true. I don't really change it to just one color typically, but you can. For example, you might want to show higher numbers in darker shades to make them stand out, like this one. We have this gradient right here, which is yellow to red being the bigger one, whereas yellow being the smaller. I say down here, conditional colors are great for giving meaning to your data at a glance. No need to read every single label. Now, we have a long assignment right here. So what we're gonna do is I'm gonna pull this to this right-hand side a little bit so we can kind of follow along a little easier. Let's see if we can do this. I'm selecting this pages visited. If I need to, I'll just expand this as we go. If I can get rid of this filters, I can get rid of this data for now. So we have this pages visited by device. And so we need to select it. We have it selected. In a visualization pane, click the format your visual, select the columns, and select the FX. So all we're doing is in the same area, instead of just doing a solid color, now we're gonna create a calculation. So let's do our conditional formatting. And now we have this that pops up right here. So it says change the format style from rules to gradient. So you can do different types of conditional formatting. We're gonna use gradient. And then what we need to do is base the gradient on the sum of session pages visited. So what should we base this on? We're gonna come in here. We're gonna go to website pages and come down here to session pages visited. And we can change the summarization. We're gonna keep it sum, but you can change this to whatever you need it to be. And that's really important. And then we have very specific values that we want in here. So when I come in here, I'm gonna copy this and come back. And just in here, I'm gonna change this color to this one right here. And then I'm gonna go select the next one, oops. And we'll come back. And then we'll change this color to this one. So now we have this light pink to dark pink color instead of just the solid pink color that we were using before. Let's go ahead and click OK. And let's expand this. I think we're done. Yep, let's expand this. So now we see this right here. Let me actually zoom in a little. Now we have the sum of session pages, and it goes from our least to our greatest with a gradient. And so now we're using that conditional formatting like we were showing. Let's go ahead and save this. And let's come over here. Let's grab this and pull up our PowerShell and run our code. And there we go. We nailed it. All right, let's move on to the next lesson, which is color tips. When you first look at a dashboard, the color of the dashboard is probably the first thing that you notice. And it's not just about making it look fancy, it's about making it more easily readable and understandable. The first thing I want to talk about is consistency. Your colors should mean the same thing across your entire dashboard. You don't want to have something called sales and that's blue, and then over here sales is now yellow, because when somebody is first glancing at this or they're first seeing this dashboard, it's going to be very confusing. Another good example is if red means a negative thing or a bad thing, you should keep that consistent throughout all of your dashboards or all of your charts. Whoever's looking at that dashboard is going to have to pay really close attention to make sure that they're not misunderstanding your visualization, and that is not a good thing. The next thing I want to talk about is using a small color palette. Now, it is very easy to use just a ton of colors and make it a rainbow, and it looks beautiful and fun, but it can be very difficult to actually understand for the person who's trying to use that dashboard. Contrary to popular belief, having a ton of colors does not actually mean you have more insights into your data. So I recommend having one main color throughout your dashboard, maybe 2 or 3 supporting colors as well. When you are choosing these colors though, make sure they're not too similar. You don't want to have like a light gray next to a dark gray because it's really difficult to just visibly see the difference in those colors. Another really important thing to consider when choosing your colors is accessibility. And I've worked with people who are colorblind. And these people need certain colors or they need certain things within their dashboards to actually see them properly. For example, that person that I worked with, they were red-green colorblind. So if I created a dashboard where there was red and green right next to each other, it's gonna basically look like the exact same color, and they're not gonna be able to distinguish or really understand that visualization at all. A helpful tip would just be to look into colorblindness and kind of see what that looks like. Power BI already knows about this. So they have palettes that are specifically made for people who are colorblind. So you can go and you can just use these different themes so that it already takes that into consideration. Some other things I would do to make it more accessible, specifically to people with color blindness, is to make it more contrast between the graph and the background. And I also just wouldn't 100% rely on the color as well. You can add things like data labels, and you can add things like tooltips to write out information where they can see the numbers on the screen. They don't have to only see the colors. The last thing I want to talk about is branding. Branding is huge within companies, even within their dashboards and visualizations, especially if they're going to be giving these things to external clients. A lot of companies are going to have templates for the exact colors that you can choose when you're creating your dashboards. If your branding is difficult to read, people may associate your company with something that is difficult to read, and that is not what any company wants. For colors just in general, I think something that's really important is just to be specific with your color choices. They really shouldn't be random or just have a random color palette that you're using for almost any dashboard that you're creating. If your colors are consistent, limited, accessible, and intentional, your dashboard is going to be better than 90% of the ones that you see out there. Now, when it comes to color, KISS, keep it simple, stupid. I learned that from The Office, and it was life-changing. And so I live by that. I genuinely do when it comes to visualizations. It's just best to keep it simple. If you get all this fancy stuff, it may look great. People may pat you on the back, but if you can't actually use it, it is useless. So first thing to remember is consistency. Use the same color for each category across visuals. If red means, computers over here, but over here, red means, phone or something, and you're looking at this, you're gonna think they're the same thing, but it just doesn't mean the same thing and it messes people up. Use a small palette, so 3 to 5 colors is plenty for most dashboards. Avoid confusion. Don't use random colors for related data. Use gradients or shades. Accessibility. Avoid red-green combinations. This is for colorblind people, and I've worked with people who are colorblind, and so these types of colors are something to take into consideration. And lastly, branding. If there isn't a specific color that's best, use your company or client's brand colors for that sweet, sweet suck up points. And yes, it's just, every company has some theme that they like, whether they know it or not. And so doing that would not hurt. Your job is to bring data-driven insights to your company. You're a data analyst, not a graphic designer. And I know I am not. I am not a designer, but I can at least make a good dashboard. Now, here's our assignment. Answer the questions about the visualizations below. It says, which visualization colors are the least in violation of the KISS principle? So we have this one, and I made this one. I thought this was a beauty. That's our visualization 1. Then we have visualization 2. We have a nice gradient here. I think that's not bad. And then lastly, we have number 3 with a type of gradient, but we're also using green and red, and it's not great for colorblind people. I think this one is the least violation of the KISS principle. Let's go with visualization number 2. And there we go. That was the right one. All right, now we are getting into what I would consider the fun stuff. We are getting into something called Power Query, and Power Query is really powerful. So I'm super excited just about this chapter in general. Now, Power Query is where data cleaning and preparation happens in Power BI. It lets you connect to different data sources, transform messy data, and shape it before loading it into your dashboard. You'll often hear this part of the process called ETL, which is extract the data, transform it, and then load it. Power Query handles the first two steps, getting data and preparing it for analysis. So we have this assignment right here. So we're gonna go into Power BI, we're gonna go home, get data and text CSV, and we're gonna load in our sales.csv, and we'll have our brand new data set. So let's come over here, let's open this up. We'll go to our CSV, and let's get our sales, and let's open this up. Now we do have the option to go straight to our Power Query by just clicking transform data, but we can also just load the data. So we're gonna go ahead and load that in, and we'll make sure we have it right over here. So now we have our sales data, and let me get that one. So now we have our sales data. We should be also able to see it in the table view. So let's click on our sales, and there we go. So we have our data right here. Let's come back, and it says, right click on sales in the data pane and click edit query. This will open the Power Query editor in a new window. So what we can do is we're gonna right click and we're gonna come down here to edit query. And it's gonna open up this entire new window, which is gonna have so many things in it. There are like 100 different things that you can use this for. Most of it is for transforming your data. Now we're gonna get into a lot of this stuff, but I'm not gonna, jump into it right now, although I want to. But let's go back and we'll come here. It says, take a look at the top ribbon and the applied steps pane on the right-hand side. The top ribbon is where we'll make transformations to the data. And then right here, we have this applied steps. The applied steps is basically, here's what you've already done, and you can actually get rid of it, so you can take back transformations so you don't have to keep them, which is really, really nice. We're gonna leave that open for now. The applied steps section records each transformation and allows us to undo, reorder, or reuse them later. Notice that is first promoted headers, extracted the column names out of the first row, then it changed the data type in the rows. So it just auto detected what columns we were using. So if we come back in here, this is our ribbon right up here. We have a lot of different options. We have the transform, add a column, you can view it. There's different tools, which I almost never use, and I never use the help either. So it's usually these two right here that we're gonna be kind of living in the most. And then this is our applied steps. So once we dragged it in, our data in from the source, it made sure that those headers were up here instead of in our data. And it changed the data type or just auto detected the data types. And of course we can come in here and change the data types if we need to, but that is all we're gonna be doing. We can leave this open, but let's come back and let's come here just to home and we'll hit save. And now we can run our script right here in our PowerShell. So let's run this. There we go, and we are good to move on to the next lesson. All right, let's move on to the next lesson, which is Python scripts in Power Query. Now, Power Query isn't limited to point and click transformations. It can also run Python scripts. We won't be writing Python scripts in this course, but it's good to know that there's an option that exists if you already work with Python in your workflows. I personally have done quite a bit of Python within Power Query, but it does get quite complex. You have to know Python really well and how it interacts with Power BI and all the transformations and everything. So it is a really cool thing to know how to use if you know Python, but it isn't a necessity in order to use Power BI. So we can find this option by going to New Source, Other, and Python script in the Power Query editor. So let's just try that real quick, just so we can find it. So in here, if we go to Home, and we go to New Source, we can go to More, and we should be able to type in Python here, and we have a Python script. So if we open this up and try to connect it, you can then write your Python script in here so that you get access to using Python. But it says from there, Power BI will execute your Python code and load the results as a data set inside of your report. This is a super simple example I just put up there, but you can do a ton of different things, pulling in data sources from different places and put it in there. This is especially useful for data transformations that are easier in pandas, machine learning, or statistical analysis, or pulling data from APIs. So all really 100% true things. Now, what is one valid use case for running Python scripts in Power Query? So our answer could be writing DAX measures for calculations, performing data transformations that are easier in pandas, or creating interactive Power BI visuals. It's definitely not that one. We haven't gotten to DAX yet at all, which is kind of creating custom calculations within Power BI instead of just the default aggregations and things. So it's not that, but it is performing data visualizations that are easier in pandas instead of doing them natively within Power BI. Let's go ahead and try this one. And there we go. All right, let's move on to the next lesson, which is removing duplicates. It says duplicate rows can sneak into your dataset from joins, imports, or simple data entry errors. They can inflate totals or averages, create confusion in charts and tables, and slow down refresh performance. Cleaning them ensures that every record represents a unique piece of data, so it's best to clean them up early in Power Query. That's 100% true, and especially as you work with a lot of data, and I worked with a lot of hospital data. We worked with tons of different hospitals and doctors, and they're not the best when it comes to data or just technology. And so we'd get data from like EHRs, and it was just super messy. There were duplicate patients everywhere. Alex Freeberg was in there, but then it was Alexander Freeberg somewhere else, and it was Alex Freeberg here, and the same patient number, and it's a mess. And so the first step usually is just trying to remove those duplicates. Now, when do we want to remove duplicates? I like to remove duplicates after importing, but before merging or appending any data. This keeps your transformations clean and avoids spreading duplicate data further down the pipeline. We ourselves have duplicate data. If you look at the sales CSV, we have multiple rows with an ID of 6. Let's go take a look at that just to confirm, right? We have our sale ID, and would you look at that? We have a 6, 6, and 6. And I bet if we go down further, we would have more, but that's not the point of this, right? We don't want to have to manually find this. We want to have something that just does it for us. So what we're going to do for our assignment is in Power Query with the sales query selected and the sale ID column selected, we're going to click remove rows from the top ribbon of the home tab. So let's come in here. And we're going to select just the entire sale ID column. And then from the home tab, which we're already in, we're going to come down here and we're going to go to remove rows, but we're going to remove duplicates. So let's click on remove duplicates. As you can see in our applied steps, we now have remove duplicates. And if you look right here in our sale ID, we only have one number 6. So it absolutely worked, and that is perfect. Let's come back here. We selected the remove duplicates, and it says, when removing duplicates, make sure that the columns you select truly identify a unique record. Otherwise, you might accidentally remove useful data, or you could accidentally leave in useless data. And so you have to kind of fine tune your removal of duplicates as you're doing this to understand, which columns to select, which ones to leave, so you don't accidentally leave them in, or you don't accidentally get rid of some you don't want to. Now click close and apply in the ribbon to save your changes and close Power Query. So that's going to be right up here. We have this close and apply button. Now we also have the option to close and apply it, but keep this open, or just close and don't apply. But we're going to click close and apply. And if we, it's working. If we pull this back up now, if we look at our data and let's sort this ascending, we now just have that 6 in here. So now we can save this, and there we go. Let's come down here and everything looks good. Let's go ahead and copy this and let's run it. All right, we're making good progress. Let's move on to the next lesson, which is split a column. Sometimes data isn't neatly organized. For example, an address might be stored in one long string like this. 123 Main Street, Springfield, Ohio, 20324. It's just a giant text, but it's not really useful. So in Power Query, we can quickly split a column into separate fields using a delimiter. A delimiter is just something that separates something. It could be a pipe delimiter, which is like those bars. It could be a comma. It could be a forward slash. A delimiter could be basically anything, but comma is super common, like a CSV file, comma separated values, or a dash or a pipe. This helps you clean up messy data and makes it easier to use. You'll see this a lot in real data. Combining multiple values in one cell is unfortunately super common, but luckily easy to fix. In our website sessions data, we have a browser OS column that combines the browser and operating system with a pipe delimiter. It's going to look just like this. Let's split it into separate columns. So let's open Power Query on that website sessions first. So we're going to come over here. Let's just get rid of that. Website sessions. Let's right click and say edit query. We're going to pull up our Power Query editor window. And right here, we have our browser OS. So let's just select that column. I'm sure I'm going to have us do that anyways. It says open the transform tab and highlight the browser OS column. So let's just make sure we're doing that. Let's go over to the transform. There we go. And I can already tell we have the split column right here. So it says, click the split column, and by delimiter, we want to have a custom delimiter. It's this pipe right here. Then we click OK to apply the step. And so we should see that. So let's do this first, and then we'll go on to the next stage. So what we want to do is we want to split this column. We're going to do it by a delimiter. So let's select by delimiter. And by default, we have different options: a colon, a comma, an equal sign, semicolon, space, tab. But for custom, we're going to do, mine's right here, shift, and it's right above my enter. Whoops, I put two of them. But it looks like that. It's shift, and then it's above my enter key, on my keyboard at least. Now we can split it at the leftmost delimiter, the rightmost delimiter, or at each occurrence of the delimiter. It does depend. We can actually, since there will only be one delimiter in every single row, any of these will work, but I typically am gonna use something like this, where it's every single time that pipe is detected, it's going to separate it out. For example, when we had the comma, we had the address, we had the city, we had the state and zip code. We would separate it at each comma. And so just something to think about. Let's go ahead and click OK. And now we've split this into two separate columns. So let's come back, and that worked perfect. So now we have browser underscore OS.1, that's the browser, and browser underscore OS.2, that's our operating system. So we're gonna just rename these really quickly. We're gonna right click on each column and rename it to browser and OS. And then notice that those also count in steps as applied. And then we're gonna save it and save our project. So we can do all that. So browser and OS. So let's come right here. We're gonna come into this. We actually need to right click, and we need to go to rename. So this is gonna be our browser. I think it was lowercase. We'll see, I'll double check that. And then we'll right click, we'll do rename, and we'll do OS. And there we go. Let's make sure, yeah, all lowercase. So just to confirm, but we also have our rename columns. Now it only did one right here for both. So it said, okay, we're renaming columns in just one step. There we go. Now we can come back to home, close and apply. And it should apply those steps. There it goes. And now if we go to our website sessions data and we come over here, we have the browser and the OS. So that worked perfect. Let's go ahead and save this. And let's go back and run our code in our PowerShell. Perfect. We are just racking up the points here. All right, let's move on to the next lesson, which is merging columns. Before we were splitting the columns apart, but sometimes we need to merge columns back together, or we need to take two columns and put them together. And so let's see what this looks like. Sometimes you want to combine two columns into one. For example, merging a city column and a state column into a single field like Austin, Texas. Let's create a new column that represents nicely formatted OS/device string like Windows on desktop. So now we're creating this kind of custom column here for us. So here's our assignment. Again, open Power Query on the website sessions. Let's just go ahead and do that, just so we are good to go. So we'll do edit query. And while that's pulling up, it says hold control and select the columns we want to merge, which is OS and device type. The order you select them in does matter, because if you select one first, that'll be the first one when you merge them. So OS and device type. And then we're gonna say in the add column, not the transform, that would remove the originals, click merge columns. Okay, so let's get there. So let's do the OS and device type. Let's come up here and not transform. We're gonna go to add column. Then we're gonna go over here to merge columns. Now it's gonna pull up this separate window. Let's go see what we're supposed to do. And actually, I don't think we can minimize it. But once we get in there, we're gonna select custom, and our separator, which is like our delimiter, is gonna be an actual word. So we're gonna type on with spaces around it, and then use OS on device as the new column's name. So I'm gonna copy this real quick, because I'm gonna not spell this right. Whoops. Let's do OS on device. I'm just gonna copy it so it's in our clipboard. We're gonna come here, click the merge columns, and our separator is gonna be custom. We're gonna do space on space. And then our new column name is gonna be OS on device. Let's go ahead and click OK. And now if we scroll to the end, we now have Mac OS on mobile, Windows on desktop, iOS on mobile. So we created this kind of custom column that's gonna be really, really useful. Let's go ahead, and I'm just gonna make sure, but now that we have this done, should be good. Notice that your original OS and device type columns are still there. Merging simply creates a new column, so it doesn't destroy the old ones, which is really good. Let's close and apply this query, and then we'll save it. So actually, let's pull up this so that we can, when we save, you'll see what it looks like typically when you're in there. So we have this, everything works perfect. If we scroll over, we now have this OS on device. And now we can save this. Let's go ahead and minimize, and we should be able to run and submit this. All right, we're on a roll. Let's keep going. All right, let's move on to the next lesson, which is missing values. It says real world data is rarely perfect, almost never, and you'll often find missing or blank values. As a data analyst, it may fall to you to fill in these missing spots with something more meaningful. Some entries are missing from the website sessions data. Null values are strewn about the session quality score column. Let's replace null values with 0.5. Quality scores are from 0 to 1, so this will just assume the few missing values are average. How you should replace or handle missing data is very situation dependent. Here we have less than 1% of our data missing, so this seems like an acceptable strategy. Blanks in your data are like potholes, harmless at first, but they can trip you up later if you ignore them. And this is especially true with visualization because you're going to visualize this data. And let's say you have millions of rows, maybe it's only 1,000 or 2,000 or 10,000 rows that are missing, but eventually, depending on the percentage, it can change your analysis completely. And so it is important to handle those in some way. It doesn't always have to be replacing it with the mean value or the average value. It could be replacing it with, something to just acknowledge that it is blank instead of leaving it as a blank value. Now, let's look at our assignment. We're going to open our Power Query in the website sessions and select the session quality score. So let's come in here. We're going to go to website sessions, and we're going to edit our query. And then let's come in here and let's find this session quality score, and it should be right here. So if we start scrolling down a little bit, we do have some nulls in here. And so we want to take care of those nulls by just giving them something. Depending on how it's populated or not populated will depend on if it's included within the aggregations like a sum or average or not. So let's select that and let's come back. It says go to the transform tab and then click replace, and instead of null, we'll replace with 0.5. So let's come here. We're gonna go to the transform. Then we'll come over here to replace values. So let's replace our values. Now we need to literally type in null. It can't just be blank. It is being stored as a null. And we'll do 0.5. Let's go ahead and replace that. And if we come up here, we should now have no nulls. Yeah, so no blank values now. So that looks really good. Let's see if there's anything else that I or us want us to do. We're gonna put 0. We're gonna click OK, so that happens. Now we're gonna close and apply this, but I also say for text data, it often makes sense to use a placeholder string like unknown, missing, or NA, just to be consistent. It's trickier with numbers. Sometimes you can use a representative value like an average or median. Sometimes you can leave it null. Sometimes it's best to just remove erroneous nulls. And sometimes you can just remove those rows completely and just take it out of your data set entirely. Again, super dependent. Let's save this, or close and apply this and then save it. So we're gonna close and apply that. You're gonna see it in the screen. There we go. And let's come up here and save. And now let's come down here to get our script to run. And just like that, we're rocking and rolling. Now let's take a look at performance considerations. So as your dataset grows, Power Query transformations can start to slow down, but there are ways to make queries run faster and data refreshes smoother. A fast Power Query setup means less waiting and more analyzing, which is what we actually want to spend our time doing. An important thing to do is only keep what you need. Oftentimes, as just data people, we want all the data we possibly can get. And this is true within a database, it's true within Power BI, it's true within any system that stores data, is sometimes you can't just store it all. And it just takes a long time to run those processes. And so what's best to do is to really narrow it down to exactly what you need. So it says remove unnecessary columns early, filter out rows you don't need before applying other steps, and avoid loading large intermediate tables that aren't used in visuals. So basically get rid of the fluff. Is basically what that means. Next is minimize complex steps. Every transformation adds work for Power Query to process. Combine simple steps instead of stacking many small ones, and avoid transformations that recalculate the same data multiple times. Fewer steps equals faster queries. Watch out for data type changes. Changing data types repeatedly can slow things down. Set the correct data types once, ideally right after loading your data. Now this question says, which Power Query practice helps improve and refresh performance the most? Our options are removing unnecessary columns and filtering rows as early as possible, loading large intermediate tables even if they're not used, definitely not that one, and applying data type changes multiple times throughout the query. Definitely not that one. So we're gonna click on removing unnecessary columns and filtering rows as early as possible. And there we go. Let's move on to the next lesson. All right, let's take a look at data refreshes. So once your data is connected and transformed, you'll eventually need to refresh it to make sure your report shows the most up-to-date information. Power BI makes it easy to update your data automatically or manually, depending on your setup. Building the dashboard is fun, but keeping it updated with the latest data is what keeps it useful. You don't want stale data that's 6 months old, right? You need the most recent data. So if you're connecting to, a cloud platform, if you're connecting to a database or an HR system or whatever it is, you need to set up these refreshes or be able to refresh your data. Now you can do that right here. You can just click the refresh button at the tab and it's going to reconnect to your data source. It's then going to reapply all the transformations that you had in Power Query, and it's going to reload the data into your model. So a manual refresh is great when you're just developing or testing your report. Typically though, what we're gonna do once we have everything set up and clients are actually using this, we'll set up a schedule to refresh this data. But here's our assignment. We're gonna open up the table view for website sessions and click on session ID column and sort it in ascending order. So website sessions, click on the session ID and let's do that. So we have website sessions, click on the session ID and then we're sorting it in ascending order. So you have 1, 2, 3, 4, 5, all the way down. Open up the website sessions.csv in your text editor of choice. I'm using VS Code, but any will work, and edit the browser OS field in the first data row. So that's session 001 from its current value to Firefox Linux. And then we're gonna refresh. So let's open up our data and let me pull this up. So we're gonna get our website sessions and let's make this full screen real quick. Now what we need to do is we need to take this first one and we're making this Firefox and Linux. So we're gonna do Firefox, I think it's like this, maybe it's lowercase, and then space Linux. And you know what I should have done? I should have just copied and pasted this. I think I did it correct, but I'm going to just, I like to verify. I'm gonna paste this in and maybe I'll paste with certain formatting. There we go. I think it was the exact same, but I just wanna make sure. Now we're gonna save this. And this is in our source data. This is the one we're connected to. And now what we're gonna do is we're gonna come back here and we're gonna see this. So right now it's connected and we did some transformations. So that says Edge, macOS, and macOS on mobile. Let's go ahead and hit home and we're gonna refresh this data. It's connecting to that data, performing those transformations on it. And now we can see we have Firefox and Linux on mobile. So it did all those transformations. It did everything exactly as we talked about. And now what we're gonna do is we're gonna save this and then we're gonna submit our CLI test. So let's come right here. Let's save that. Let's come down and get our script and run this in our PowerShell. And there we go. We have mastered data refreshes. All right, now we're still on data refreshes because we just changed our data set, or at least our raw data. We're gonna change it back. So let's put the browser OS back the way it was. We don't wanna mess with our original data set. I just wanted to show you how cool it was that we can update from our source data and how that cascades through the transformations when we refresh. So we're doing the exact opposite of what we just did. We're gonna copy this and we're just gonna go back into our data and we're gonna change this. So I'm going to paste with the formatting and then we're going to save this. And so now that we've done that, we need to go and refresh the data. And once we've done that, then we can just save it. So we have Firefox Linux and now we've updated that. We have Edge and macOS on mobile. That was pretty easy. We just undid the mistake that we made or the change that we made. Now we can go ahead and save this and let's come on down. Let's grab our code and run this. And there we go. We fixed our issue that we made ourselves. All right, in this lesson, we are focused on formatting our visualizations. So it says we can make our charts even easier to read by formatting the visuals. Let's talk through some of the different formatting options. One we have data labels. This is one of my personal favorites. I use data labels all the time because it's literally just a number on your visual so people don't have to hover over it and see it. They can just see it. So data labels show the actual number directly on your visualization. In the case of a bar chart, it shows the value that represents the size of the bar. So right at the end, you can put a data label. You can also change the position of that to have it in the middle, on the right-hand side, on the left-hand side, but you can put that number somewhere in there. Next, we have axis titles. Now, this is like our x-axis and our y-axis, and we can change these to be more custom than just the default that it comes with. But it says your axes on the chart don't need to have the same, sometimes gross name as the column. It can be changed. A clean and readable chart with consistent fonts and spacing always looks more professional than one overloaded with decoration. So true. Let's open our pages and go to the pages visited by device. So let's come in here and let's go to our pages visited by device. That's right on this one. Now let me zoom out just a tiny bit. Let me get rid of this one just so we can fit everything. So we have our pages visited by device. We're going to turn on data labels. So format, visual, and data labels. We'll turn that on. Then next, we're going to update the y-axis to pages visited, and that's it. So let me copy this pages visited. We'll turn on labels and change our y-axis. So let's come in here. If we come over to data labels, which is right here, we can just click them on, and there we go. So now they're at the top. Again, we can change the position of these. And right here, we have the auto. We can do it inside end, inside center, inside base. We're just gonna keep it how it is. We're not changing anything like that. Now, if we come over here, we can also double click on this y-axis and just paste in pages visited. And if we do that, this pages visited gets changed right here. And that's exactly what we want. So let's go ahead and save this and let's get out of here. And now we need to run our CLI test. So let's come down here and run this. Now this failed, it happens. I think maybe I just didn't do it in the exact way that it wanted. Let's come in here. And what I'm gonna do is I'm gonna hit Control Z. I'm gonna get rid of that because it wants us to come in here into the y-axis. And so, you know what? I'm gonna do it the way that I said to do it. And we'll do, it's not pages visited. Maybe it is pages visited. Yeah, the y-axis title to pages visited. Let's do it this way just to see if that's what the issue was. Now let's save this and let's try running this one more time. And I need to copy this. Let's try running this one more time. And there we go. I just did it in a different way. You can technically do it in both ways, but follow the directions that I've set. I just got a little antsy because that's sometimes the way that I do it. All right, let's move on to the last lesson in this chapter. We're gonna be taking a look at filters. Now, formatting improves how your charts look, while filters control what data they actually display. So filters are super, super important. They're perfect for slicing the data at view time into specific regions, time periods, and categories without changing your data set or Power Query transformations. There are three main types of filters in Power BI, and they're shown in the filters pane to the left of the visualizations pane. These three filter types are visual level filters, page level filters, and report level filters. So you can add filters to different levels. This one's just gonna affect the selected chart. This is just at that visual. Then you have the page, which affects all the visuals on that page. And then report level is every page in the entire report, so it affects everything. I use filters depending on who is using the dashboard and visualization. Do they need all the data? Will they want to filter on something specific? I'll add whichever filter I need. Filters are typically one of the most requested things in visualizations once you actually create them. You create this great, dashboard or reports or whatever it is, you give it to the client and then they say, add a filter. Almost every time. It is uncanny and it will happen to you. So filters are really important. So your assignment is on the customers page, select your customers by payment type. Let's go back to the customers page. It's gonna be right down here. And this is our customers by payment type. Let's zoom out just a little. So we have our customers by payment type. This looks great. Let's come back. It says drag your customer region from the data pane into your filters on this visual. Be careful not to add a page level filter. It's easy to do when you're not paying attention. So we're adding this to our filters on this visual, customer region. All right, let's get our data. For our customers, we have our customer region. And let's expand this filters because you'll see we have filters on this visual Then we also have filters on this page, filters on all pages. So let's drag over this customer region. And now we have this customer region right here within our filters on this visual. Let's see what else we need to do. It says filter to show only customers in the Midwest. And then we're gonna save it. So let's filter. We're gonna filter only on the Midwest. And let's actually back up a little bit. So if I select all, we have a much larger count. And so we don't have data labels on this one, but for count of customer ID, we have 89 for Visa. Now let's just select Midwest. And for just the Midwest, we only have 15. It looks very similar, but our axes for, how many are actually in there completely have changed. So let's go ahead and save this and let's run our test. I think we're gonna get this one right. All right, so I'm talking about, we're doing really good. Test, 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 1, 2, 3. All right, this looks good. All right, everybody, let's get going on the 5th chapter, which is data modeling. Now, data modeling has a lot to it, and we'll get into a lot of that in this module. But the first thing that we're gonna cover is the star schema, which is kind of like your go-to model for just basic data modeling. So let's take a look at what this is. It says a star schema organizes your model into one central fact table surrounded by dimension tables. It's the simplest, most performant shape for analytical reporting in Power BI. For our fact, or many rows, we have sales. Then we have our dimensions, which are unique keys like dates, products, customers, and stores. And it's called a star schema because it looks like a star, right? We have boom, 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 boom. That's our star schema. And so that's just kind of a shape that people use, but it doesn't have to be in that shape by any means. It's very dependent on your data. This setup allows us to answer questions like, what were the total sales for each product in a given month? How many customers brought products in to a specific store? What was the average sale amount for each customer in a given year? Now, why can we answer these questions? Because we're able to take data and connect them from all these different tables or all these different data sources, and we connect them via joins or relationships. And so we'll be looking through that. Now, a fact table is just what happened, right? Here's all the different transactions. There could be millions of transactions. But dimension table is usually quite more simple. It's an about what table. So it's product, date, customer, or store. These are like our unique values that then we connect to our fact table. Now let's go ahead and watch this video. The star schema is the data model that's used in most of the data visualization world. And you will get this asked in a lot of interviews, especially if they're really heavy on data modeling. Not only that, but if you want to create really good kind of complex data models with more advanced data, the star schema is a great one to start with. The star schema model is just a way of organizing your tables so that's a more clean and relational way that Power BI can work with it to where you can do a lot more things. At a high level, a star schema is actually fairly simple. We have a fact table at the very center of our data model surrounded by dimensional tables, and it makes it look like a star. The fact table usually has numeric values that you want to analyze. So things like sales or quantity or revenue. And importantly, it also has keys that connect it to other tables. Dimension tables contain descriptive information, things like dates and customers and products and locations. These tables give context and information to the numeric data that's in your fact table. A great example of this would just be a fact table of transactional data. So things like a product ID, a customer ID, a date, and amount. Now on its own, this fact table is just a log of sales. It actually isn't super useful, but if we create dimensional tables that have both the product and the customers for those dimensional tables, we can now create a lot of really powerful visualizations. Something that's extremely important within your data model or your star schema is the relationships. A relationship is how you actually connect one table to another. And often this is done via a primary key and a foreign key. The primary key usually sits in the dimensional table while the foreign key is in the fact table because the fact table is going to have a lot of duplicates. Clean relationships make your dashboards faster and more accurate, and they allow you to access data that you just wouldn't if they weren't all connected via these relationships. When relationships are set up correctly, filters are going to flow the way you expect, totals are going to calculate correctly, and visuals are going to be more consistent. When relationships are messy or incorrect, you're going to see duplicated values, you're going to see incorrect totals, and it's going to cause a lot of issues with the consistency of your dashboard. In Power BI, your data model is really going to work best when you have the dimensional data flowing into your fact table using a one-to-many relationship. It keeps your data organized, relationships clear, and your dashboards more reliable. All right, so now that we know a lot more about fact table and a little bit about data modeling, let's come down to our assignment. The first thing that we need to do is import our dates, products, and stores CSV. So before we do anything, let's import these data sets. So we're gonna say get data, and we're gonna go down to text CSV. Now we have to do dates, stores, and I think it was products, but let's just start with our dates. And this is of course going to be one of our dimension tables. Let's load that in. And let's make sure we have our dates in now. So we have our dates, we need products and stores. So let's come back down. Let's get data, go to text CSV. We'll get our products next, and this looks good. Let's go ahead and load that in. And then lastly, we will get our stores. So text CSV and stores. And let's load in that data set. And there we go. So we have all of our data in here. Let's come back and see what we're supposed to do next. So check the data in the table view to ensure everything imported properly. Open the model view. It's below the report and table views on the left-hand side. And we're gonna drag these boxes to make sure we have this star with the sales table in the middle and the website sessions off to the side, connected to both stores and customers. So let's do this one step at a time. Let's go to our model view. And so our model view is right down here. And we have all of these different tables we have. Let's just separate them out a little bit. And we should have sales in the middle here. So let's get our customers going. All right, so we're close. Now, one thing that we need to do, and let's come down here, is it says that we need to drag the boxes so products, customers, stores, and dates, our dimension tables, are all around the sales fact table in the middle. So that is true. And then we have website sessions off to one side connected to both stores and customers. So let's take a look at this. We would have stores over here and customers over here as well. I just want to visually see this. So I'm going to bring products over on this side. Oops, there we go. Then we'll have our stores, and then we'll have our customers. Now this is kind of an inverted star, but you get the picture. And so let me zoom in just a little. I feel like this is okay. But we have our website sessions. Now, these are being tied together, and these are our relationships, but we're gonna talk about that later. But this is looking really good. I think this is all we need for this lesson. It says the sales and website sessions table should have lines connecting to the other tables automatically. Power BI is smart enough to recognize ID columns. If it doesn't, you can add the relationships manually. We don't have to do that. Everything is looking good. So let's come over here and let's save this. And then we're gonna come down. We need to run this code right here. So let's go into this and let's take a look. All right, we did everything correctly. All right, let's move on to our next lesson, which is calculated columns. These are just like custom formulas in Excel, are very similar. They use data from a different column and then sometimes even columns in other tables to create new columns with the results. Now, in our assignment, we'll look at that in just a second, but calculated columns are really important because they actually become a part of your data model. It's like a regular column, but now you have a different column based off of these other columns. And so you can do calculations and then you can put it in a column and you can actually store it in your data model. That's why calculated columns are so useful. So it says, funny enough, from just our sales data, we haven't been able to see how much money we made on each sale. Let's add a new calculated column that pulls in data from the products table to do that. So let's go and select the sales table and select new column in the top ribbon. So let's come over here and select our sales, and then we're gonna come up here to a new column. Now it opens up this bar right here, and this is where we basically write some Excel-like function or formula. Let's come back, and then the formula bar at the top should become selected, and we're gonna paste this in. So let's just copy this, and this basically is taking the sales quantity and multiplying it times the product price list. So how many have we sold versus how much we actually are listing it for? And so that should be really good. So let's click on that new column. Let's paste this in. So we have our price is equal to the sales quantity. And then we're also multiplying it times the product. So that's our table name, which is right over here. And then product list price. So let's go ahead and hit enter. And now you'll see this right here, which means this is a calculated column and it sits in our data model just like any other column. But we can always come back and we can change this though. So that is something unique about a calculated column. So click the green check mark to save it. We didn't click it, I just hit enter, but off to the side, you could have clicked the green check mark. And now we see our new calculated column. Head back to the table view and you should now see price column under those values. So let's go back to our table, and under sales, we now have this price column. So this is its own unique column now sitting in our table, and you can still see this symbol right here. This is a calculated column. Let's go ahead and save this, and let's go back and let's see if we did everything properly. All right, perfect. All right, now let's go on to our next lesson, which is handling discounts. So our new price calculated column has a slight problem. It represents the price before discounts are applied. Let's add a new discounted price column that accounts for those. So here's our assignment. We're gonna select the sales. We're gonna create a new column again. In here it says I'm not gonna give you the syntax to copy paste, but the formula should be. So they gave us the formula, we just had to put in the column names ourselves, all right? I like that we have to do that simply because it forces us to do it. I just didn't read ahead and I forgot that you had to put it in yourself. So we did everything correctly. Now, just like we had done before, when you start typing, it's gonna automatically detect it, just like any, autocomplete or context-aware UI that you're using within an IDE or a database or something like that. Now, next, we need to check the data in our table to ensure 0.1 discount applies 10%, 0.15 applies 15%, and 0 applies 0. Don't worry about rounding. We did check that just a second ago, but if we go back to our sale discount, we can see our sales. So 0%, boom. 0.2%, that's 20%. 20% would be about $3, so that looks correct. Then we have 10%. This one's easier to calculate. That's about $29, so about $30, and that does look accurate. So it looks like it applied those discounts properly. So let's go ahead and save this. And there we go. Let's then copy this and run it and see if we got this right. All right, we're on a roll. Let's keep it going. Now in the next lesson, we're gonna take a look at cards. Now cards display summary measures, usually a single value or optionally a few separate values on the same card. These are perfect for quick high-level metrics, and you'll see them in almost every dashboard. It's usually just one number in a square. That's typically what a card looks like. Cards are your dashboard's quick glance numbers, things like total sales, active users, average response times, or average response times are ideal for cards. Now, let's take a look at our assignment. We're gonna go to the report view and add a new page called cards. So let's go ahead and do that. Let's go to our report view and we'll rename this one. We're gonna say cards. All right, we are absolutely doing great. On that page, use the visualizations pane to create a new card and be sure to use card new with the lightning bolt right here, not the older card version without it. So let's go and click this. So we're gonna do our card with the lightning bolt. So we have card new. So it's right here. This looks good. I'm sure we're gonna need to snap it. Snap or extend the card to fill in the left half of the canvas. So let's go ahead and do that. So we're going to get it all the way here, all the way down, and then halfway, and there we go. Yeah, it just takes a while for it to snap in properly. Now, leave it without any data for now, and let's save the project and run our test. So let's come over here. We have our card. Let's save this. There we go. Let's run our test. Perfect. Let's go on to our next lesson. All right, let's go on to our measures lesson. Now, measures and calculated columns go hand in hand, and they often get very confused with one another. And so it is important to understand the difference because they do have totally different use cases. Now, calculated columns and measures both perform calculations, but they're quite different. A calculated column is stored in your model evaluated for each row in a table, whereas a measure is calculated dynamically. So this is on the fly as a total, updating dynamically as you interact with your report. So columns do it row by row, and measures are gonna be context by context, depending on filters and a lot of other things as we'll talk about. So here's our assignment. In the model view, click on sales and select new measure. And then in the formula bar, we're gonna write this exact one. Now this looks like a proper formula, so we should be good to go. So let's do that. And then we're gonna take a look at what our output looks like. So let's go to our model view. And then within our sales, we're gonna come right here. We're gonna go to a new measure. It's gonna look very similar, but now we're creating a measure, which is a little bit different, right? So we have this total revenue, sum of sales, discounted price. Let's go ahead and commit this. Now right down here, if we come and look for our total revenue, and let's scroll down, we're not gonna see it. These are for our columns. Now we should see it right down here within our measures. So we have our total revenue right here. So this all looks correct. Now let's come back down and we'll scroll down. It says, go back to the card visual that we created with the missing data. Go back to the card visual we just created that's missing data and drag the total revenue measure from the sales table into it. Yay, aggregated metrics. Let's go ahead and run this. So let's come in here. We're gonna go to our visual that we just had, but now under sales, we do have access to this calculated column. We're gonna drag this over into data, or we could drag it right there. But now we have the total revenue. So that's what we did in the actual column. We actually calculated that column. Now, if we ever need to, we can click on this total revenue and we can see what this measure looks like. So we're taking the sum of all that discounted price and just putting it into a card, a really simple visual for what we're doing. Now let's see if there's anything else we're gonna do. And it says, no, we're just gonna save this and run our test. So let's go ahead and save that. And let's go back down and copy this and run our test. And we should be good to go. Let's see. And there we go. We passed our test and we got our points. All right, let's move on to the next lesson, which is multi-value cards. Now, I can tell you're a smart person. You're gonna pick this up really quickly because it's basically a card with multiple values. That's mind-blowing, I know. But this new card visual in Power BI, the one with the lightning bolt on its icon, which we've already just used, can contain multiple values. It has a rich variety of formatting options. We've already made a card with a single measure, which we did right over here. Now let's create another one with multiple measures. So here's our assignment. In the model view, create a new total units sold, and that'll be a measure on the sales table. We're gonna figure out the formula ourselves, and we'll use a sum aggregation. Next, we're gonna create a customer average age measure on the customers table. This represents the average age of a customer. We'll use the average function, and then we're gonna put both of those in the report. So let's start out with this first one. We'll do the total units sold, and we have to figure out what we're doing here. So let's go back. Let's go over to our table view really quick, because I wanna go to our sales, because that's where we're gonna be putting it. Now, what we're basically doing is we're trying to sum the sales, right? Total sales. This is our sale quantity, whether it's 1, 2, 3, 4, 5, that's how many we actually sold, but we need to sum all of this. So we're gonna go to our model view, just like we talked about earlier. And in our model view, we'll click on new measure, and then we'll come right over here to our new measure, and we just need to write it out. And this is gonna be a pretty easy one. We're gonna do the sum, and let's pull up our sales. So I'm just gonna write out sales, it'll auto-populate, and we just need to figure out the sale quantity and close our parentheses. So this is our formula for summing or getting the total value of all of our units sold. Let's go ahead and hit enter or commit over here. And we should see it right over here in our measures under sales, which is total units sold, so we're doing great. Let's go back. And we need to get our customer average age, and we're putting that in the customers table. So let's come back, and now we're gonna go down to our customers, and this one should be pretty straightforward because we have a customer age right here. I think we're gonna be able to get this one really easily. Instead of sum though, we're doing a different aggregation. We're using average. So if I type out average, it's the full average function. And then we'll come to the customers table, and we'll take the customer age, and we'll close our parentheses. And this time we'll use this commit button right over here. And so we should have, right under this table of customers, we should have our customer average age. So we have everything that we need. Let's come back over here. And what we need to do is create a new card. So we're gonna put a card, and it's gonna take up this whole space, or almost. Let's expand it, there we go. And now we're gonna put those in there. So we'll do total units sold. We can drag it over, we can put it in values. We could also just click it and come up here to average age and click it. And there we go. So this is exactly what we need. Let's go ahead and save this. All right. And once we save it and we put it in there, now we just need to run our test. So let's copy this. Let's go right here. Let's paste this in there. And there we go. We nailed it. Now in our next lesson, we're gonna be taking a look at managing the relationships within our data model. We talked about this a little bit previously, but now we're gonna actually, really look at it, and we're gonna talk about that in the next several lessons as well. So relationships connect your tables so that filters flow through your model correctly. Basically what this means is if you don't have all your data connected and you use a global filter, it may only affect one visual, but it might not affect all the visualizations, and that's a problem. So you want these relationships to connect all of your data so that when you apply a filter to one, it affects all of your visualizations, not just one. In a star schema, each dimension connects to a fact using a one-to-many relationship. As you know, when we have imported our CSV files, Power BI automatically found and made relationships where it thought they should be added. These aren't always perfect, and you may need to make your own connections. Now let me expand on this just a little bit. The reason why I was able to pick it up is because in this sample data set, all of the column headers are very easy to understand, right? It's sales ID to sales ID. It's not super hard. But in real data, as I'm sure a lot of you guys know, sometimes the column headers are completely different, but they are, connected via a relationship or a join. And so sometimes it's not going to pick it up. And I would say maybe 50% of the time it gets it perfect, 50% of the time it doesn't. So it is good to go in here and just know how to manually connect these things. So here's our assignment. In the model view, right click on the line representing the relationship between sales and products and delete it. So let's go and do that. So let's go to our model view. We have our sales and we have our products, and we're gonna right click on this line and we're gonna hit delete. And now there's no relationship. There's nothing connecting this to the rest of our model. That's not a good thing, but let's see what happens next. Let's come down here, head back to the report view, and notice that by removing that relationship, we broke our total revenue card. It can't get the price data from the products table if it isn't aware of that relationship. So let's go back, let's go to our report. And now we can't get this information because we were using a join or a relationship from our data model to connect these to actually create that calculation that we had. So we don't have that anymore, and that's not a good thing. Let's go back in the model view, drag the product ID from sales onto the product ID in products. So we're basically recreating this relationship that we just deleted. So let's go back, and we have our product ID right here, and we have our product ID right here. All we have to do is drag it, and we're gonna put it right on the product ID. Now this page is gonna come up. Sometimes you're gonna have a preview of it, sometimes you aren't. But now we have our cardinality, and we want many to one. That's only because we dragged it from here to there, right? So let's go ahead and save this. It is from this table to this table, it's one to many. This one just stores the products. This one stores like transactions, the actual sales. Let's go back. Ensure that the cardinality is many to one from sales to products. One product can be sold many times. Now, if we come down, go back to the report view and ensure that the total revenue card is working again. So let's go back, and there we go. So everything is working really well. Now we're going to save this, and now we're gonna submit our test. So let's come right down here and let's submit this. And there we go. We are now masters of relationships. Now let's take a look at something we touched on in a previous lesson, which is cardinality and then also cross filters. So cardinality describes the types of relationship between two tables. It can be one-to-one, one-to-many, or many-to-many. When looking at the model view, we can actually see the cardinality represented visually right here. We have this star, which means many. We have this one that means one, and it shows the flow as well. Now, if we scroll down, it says the diagram shows standard one-to-many relationships, products one and sales many. If you right click on the relationship and click properties, you'll see a more detailed overview. So here's what the cardinality looks like. Here's all of our different options. Now, typically, I would say almost all the time, Power BI gets this right, because it can tell if there are many duplicated values or unique values within a column. It's pretty good at that. And so oftentimes you don't need to change this. But here's what I will say. Typically it's almost always one-to-many. If you have many-to-many, and that's a, kind of an interesting join, you're gonna get some weird outputs. And that's just comes from experience. One-to-many is kind of a standard thing, or many-to-one. But you don't often get many-to-many, but you can get one-to-one. That happens too sometimes, just depends on your data. Now, for most data models, you'll use many-to-one or one-to-many relationships. Many-to-many and especially one-to-one are more rare. You don't see it often. One-to-one is easy to work with though, right? Because you just have one-to-one and you can tie those tables super easily, but many-to-many gets complex. You just don't see those often. Now note on the cross filter direction. In the properties pane, there is a setting that controls how filters move between the two tables, and it's just single or both. So we have this directionality, and let's go back up. we have this direction of where it flows. You can also put it to where it flows both ways. And what that means is that helps control how the filters work, right? And so we have a single and we have a both filters. Now the single, which is recommended, means the filter flows from one side into the many side, which is you should do that. It isn't recommended to use the both because that allows filters to move in both directions. So here's a little example. Imagine a schools table 1 is related to a students table many, and that Lakeside High happens to not have any students before the year 2012. Here's how single and both direction filtering would work. So here we have our filter. If we filter on schools to Lakeside High, for the single direction, students are filtered to Lakeside High students, and for both directions, students are filtered to Lakeside High students. So not an issue, right? Not for that use case. But if you do students to before 2012, we're just filtering before 2012. For the single direction, it'll be schools table is unaffected, which is totally fine. But then the Lakeside High is filtered from schools table, and that's not a good thing. It feels strange that filtering students affects the schools table, and that rule of thumb applies to most scenarios. And so it's just a filtering thing. By default, 99% of the time, you're just gonna use a single, which is recommended. I can't remember, maybe there's been a handful of times in my career where I've used both. And I even say that right here. In my 5+ years of using Power BI, I've only used both a handful of times. I didn't even see that. I was just remembering that. I've barely ever used it. Which Power BI type is most commonly used in Power BI data models? One-to-one, one-to-many, or many-to-one, or many-to-many? We know it's not these two. We know the answer. Let's go ahead and click on this one. All right, and there we go. Now, lesson number 8 was part 1. Now we are on part 2 out of 2 for cardinality and cross filters. Everything in here is the exact same. If you want to go through that again, you can. But the reason we're here is because we have another question. So why is single usually better for cross filtering than both? So why is it better? 1, it prevents unexpected filtering of the one side, or it prevents unexpected filtering of the many side. Which one do you think it is? I think it prevents unexpected filtering of the one side. Let's go ahead and click on this one. And there we go. All right, so we are moving on to the next chapter, which is DAX. Now, DAX has a lot to it. It's probably one of the more complex or complicated things within Power BI. And so this is a very kind of in-depth chapter, I would say. And so we're going to start with just a little bit about DAX. And then I know we're going to be going quite a bit into a lot of DAX. So we're going to learn DAX really well because it is a really important part to kind of use within Power BI. So DAX stands for Data Analysis Expressions. It's the language that Power BI uses to perform calculations, build metrics, and create dynamic insights in your reports. While it looks a little bit like Excel, DAX is designed specifically for analytical models and large data sets. DAX allows you to create things like totals, averages, percentages, comparisons, KPIs, and time-based calculations that react instantly to slicers and filters in your report. Anytime you see a number in Power BI visual that updates when you click something, DAX is doing the work behind the scenes. It also says the formulas we wrote in the last chapter were simple DAX expressions. So when we even write things like, sum or average, we are writing DAX. That's like the simplest version of DAX you can write. It does get quite a bit more complex, but that is what DAX is. Next, it says there are 2 main places you can write DAX in Power BI. In the formula input, that's what we used to create calculated columns and measures, so we know that one. And then the next one is the DAX query view. Now, let's go ahead and watch this video. If you work in Power BI, at some point you're gonna run into something called DAX. And it might be a little bit scary and intimidating at first because it looks really technical, but I promise it is not that hard. DAX stands for Data Analysis Expressions. It's the language that Power BI uses to create dynamic metrics and create calculations within your reports. It's actually really similar to creating formulas in Excel, and hopefully that makes it a lot less scary. Without DAX, Power BI would just be a charting tool. It'd be very simple. But with DAX, it really transforms it into an analytical tool. It allows you to go beyond basic totals and build custom metrics that really reflect how the business thinks and what's going on. DAX is designed for analytical models and large data sets. And although it may look and feel like Excel formulas, it works very differently behind the scenes. Instead of calculating cell by cell, DAX is evaluating all of the data based off the filter, the relationship, and the context of the data. The context awareness is actually what makes DAX so powerful, but what also makes it a little bit confusing at first. Now, it's really important to note that DAX can get really complex, but you don't have to memorize everything within DAX. I myself don't have everything memorized, but what is important is that you do understand what DAX can do and what you can use it for, so that you can go and you can look up a lot of these functions and things within DAX to be able to use them for your business use case. So where do you actually go to write DAX? There are actually 3 places you can do this, and the first is creating a calculated column. These use a formula to create a new column in your actual data model and are evaluated row by row when you refresh your data. The second way to write DAX is in a measure, and this is by far the most popular and the preferred way to write DAX. Measures are dynamic calculations, and when you actually put them into your visualizations, they're going to respond to things like slicers and filters automatically. The last place to write DAX is within the DAX query view. Now, this is a more advanced area where you can write DAX queries, but you're going to use it for a lot of different things. You can use this area to inspect your data, to test different expressions, or to debug calculations before you actually go and create your visualizations. So there we go. That gives us a lot more information about DAX, and you get to see me on screen again. Now let's go back down to the DAX query view. So we're gonna actually test this out. We're gonna try writing something in the DAX query view, but in my experience, I don't use the DAX query view as much as I just use, that line at the top where I'm writing like measures and calculated columns. That's what I use most of the time. So the DAX query view is a more advanced area where you can write DAX queries to inspect data, test expressions, and debug calculations. Is especially helpful when you want to see exactly what the DAX expression is returning without building a full visual. Query view is the easiest way to peek behind the curtain of your model. And that is true. When you're writing a measure, just like how we've written in the past, all you're seeing is it gets built. You don't actually see what it's returning until you create the visual and then you put that measure inside of it. But with the DAX query view, you actually see that number before you actually use it, so it can be quite helpful. So it says you could open it from the left-hand pane right here to go to the DAX query view. Let's go do that. So we're gonna come right over here and we have our DAX query view. So this is what the DAX query view looks like. You can see right here, it's gonna be writing some type of expression in a way. And then down here, we'll see the results. So it's like a query. We can write queries and we can see the results like you would in maybe a SQL database. So let's come back. It says, let's select columns. This query uses the select columns function to create a new table with only the columns we specify. It lets us get a quick view into our data. It's a bit like running a one-off SQL select statement. Hey, I forget that I wrote this sometimes because I'm just talking and then I wrote it out. Now, we can run this. This would be a perfect thing to just try out really quick. So let's come over here. Let's see if it works. You can get rid of all this stuff, by the way. That's just extra. Let's just try running this. I'm going to see if this works properly. And so it does. So it's giving us just the select columns from the sales table. We're selecting the sale price as the sale price, but we're naming it right here. You can see we wrote sale price, and that's sale price, customer ID, customer ID. And then we get this output that we can actually look at the data. And so that is really useful. The only difference is it's a completely different syntax than something like SQL. So if you know SQL and you've never written DAX before, this can feel, a little bit awkward. But let's come in here. It says the evaluate statement simply tells DAX to run the query and return the results as a table. So we have this evaluate up here. It's just saying, okay, we're writing this. Let's go ahead and kind of give us an actual output. Now for our assignment, we're gonna open the DAX query view. It's right below the model view. Write a query that selects the customer name and customer age columns from the customers table, and then run your query using the run. Should give us an output with the results, and then we'll save that and then submit our tests. So I'm going to copy this whole thing. Just let's come right here, just so I can see it. And I think we go like this, or maybe I forget how to comment. There we go. So we write a query that says, selects the customer name and customer columns from the customer. So we have to first, we're gonna come in here and we're selecting the customers table. And now we need to specify what columns we want. And so this one is gonna be customer name. So I'm gonna come in here first and I'm gonna say customers. Then we have our customer name. And then next, we're gonna do our customers, and which one did we want? The customer age. So let's do customer age just like this. Now we will want to rename these because we can run this. Now we'll want to change this from sale price and customer ID, because we have the customer underscore name. So I'm literally just going to copy these and do customer age just like that. So now we have from the customers table, we're taking the customer name and the customer's age. We shouldn't need this anymore. Let's go ahead and run this. And so now we have just like an output in Excel or any type of relational database, we have columns and rows in our output. So now here's Gurney Halleck. We know they're 28 years old, and we can go and we see all of this data. So this looks really good to me. I think this answers our question. Let's go ahead, or our assignment at least. Let's go ahead and save this. And now let's come over here. Let's copy this and let's go ahead and check this out. Let's go ahead and run our script. And there we go. All right, let's move on to the next lesson in our DAX chapter. And this is going to be on logical functions. Now, there's different types of logical functions, and logical functions are kind of needed. They're that, what if this happens, or what if this happens, or what if this happens, and if not, then what happens? It's just this, really important piece of kind of any coding or any calculations out in, the real world. So let's take a look at logical functions. Logical functions let DAX formulas make decisions based on conditions, basically conditional criteria. With them, you can label rows, create flags, or change calculations depending on your data. In the sales data set, we might want to mark which orders are bulk orders, or whether a sale has a discount applied. Logical functions like if and switch are perfect for this. Logical functions turn your numbers into rules the business actually cares about. So you will typically use logical functions in calculated columns for row by row labels or measures for dynamic classification based on filters. Let's take a look at this if function. So the if function checks a condition and returns one value if true or another if false. Here's an example of an if function that labels homes as jumbo or normal based on whether their price is above 700,000. So house type, that's the name. It says if the home price is greater than 700,000, we'll label it jumbo. But if not, we'll just label it normal. So this is the syntax of an if statement. So there's three parameters. Parameters are just things that, if you're into coding, they're things that you pass into a function. And our function is this if. So we have a logical test. We're saying home price is greater than 700,000. That's part one. Then we have the value if true. So if this condition is true, then we return jumbo. But that value is false, then we return normal. So those are our three parameters or three pieces of that function. Next, we have an assignment. Back in the table view, use DAX to create a new calculated column in the sales table. So let's come back. We're going to call this bulk order. Let's come back to our sales table. We're going to create a new calculated column. So let's come back. We're going to go to our model view, sales, and we're going to do a new column. And we're going to label it bulk order. Now let's go see how we're going to write this. And it accidentally saved it. We'll fix that in a second. But bulk order. If the sale has a quantity greater than 3, the value should be true. Otherwise, it should be false. This is a Boolean true false column. So this is pretty easy. Quantity greater than 3. Not greater than or equal to 3, but greater than 3. Let's go down here. And we're going to come up here. We need to call the if function. And the first thing that we need to do is our logical test. So this is going to be on the quantity sold. So let's come down here. We have sale quantity. So we're going to say if the sale quantity is greater than 3, then we'll do a comma. If it's true, so this is the result. If this is true, we want to literally just say true and then comma, false, if false. That should be it. Let's go ahead and run this, and it's going to process it a little bit. And let's go look at our table view, and we'll look at our sales. And now we have this bulk order, and it's either false or let's look for some trues because these are all sale quantity. Let's go to where it's greater. So then there's true. And so then if we do 3 or less, these should all be false. Actually, let's just look at 3. So these should all be false. So this is perfect. One thing I think it said was that this needs to be, this is in text right now. Let's come back down here. It says this is a Boolean true false column. Look over some of the values in the new column to ensure the function is working as expected. Now, one thing I will say is it is possible that if we put it as true like this, maybe it'll auto create it as a Boolean. I'm just gonna test this out while we're here. And it's still text. So we're gonna go back and just keep it as is, and we'll do it just like this because I want to keep it exactly how we have it. But it is in a text format, so we are going to change this to true false, which is changing the data type. We're going to say yes, and now we have that Boolean data type. So that should be correct now. Let's go ahead and save this, and then we're going to come right down here, and we should be able to run our test. So let's come right down and paste this. And it looks like all tests passed, and we're good to go. All right, let's move on to the next lesson, which is the switch function. It is very similar to the if function, so if you understood that one really well, this one should be pretty easy to pick up as well. So the switch function is like a more powerful if function. It checks multiple conditions instead of just one, like the if function, and returns different values based on which condition is true. Here's an example that classifies homes into small, medium, or large based on the square feet column. So we have our name, and then we have our switch function. So right here, it says true. And basically that's what we're looking for when we evaluate these other conditions. That's what we're looking for. Now you can change this to other things, but for this one, we're looking for it to be true. So we're saying the home square feet is less than or equal to 2,000. That's small. So if that's true, that's what's going to be returned. Then we have home square feet is less than or equal to 3,000. That's medium. And then if it's larger than 3,000, then it's going to be a large home, or that's the large text that's going to be in our output. So it says right here, you might be wondering why the true at the beginning of the switch function. It's a bit odd, and it usually will just be true, but it's specified because you can change it. It's just the value that the following conditions need to match. In this case, home square feet is less than or equal to 2,000, and home square feet is less than or equal to 3,000, need to evaluate to true to return their respective small and medium values. This one is like an else. So you have if-else statements. So if it's this, or if it's this, or if it's this, or if it's this, it'll give those specified. If it's none of those, then the else will take into play or come into play, and then it'll just be the large. So here's our assignment. Create another calculated column in the sales table called order size and use the following conditions. If discounted price is less than $100, the sale is tiny. If the discounted price is less than $200, the sale is mid. Otherwise, it's massive. So let me see really quick. Let's come over. We're going to do this on which table? On the sales table. We've been working on the sales table a lot, so we should know where this is. Let's come over to the sales. Let's not create a new column yet. Let's actually see if I can just bring this over here while we're writing this out, because we don't need these properties and we don't really need the data. So let's come right here where we can see everything, which we can see everything right here. And I actually want to copy this. I lied. I'm going to copy this real quick, just so we have this as like our template for what we're about to do. And then we'll come right here. So let's come in and let's say, I think it said new column. Yeah, new calculated column. So we'll say new column, and we're going to paste this in, but we're not going to save it. So we're going to change all of this. Now we're going to call this order underscore size. I want to get the uppercase, lowercase correct, just in case that, our test looks for that. And now we're doing our test. We're not doing it on home square feet. Of course, that was just an example. We're doing it on the discounted price. So we'll do sales, and we should have our discounted price right here. And let me get rid of this. So let's copy this, and we'll replace it down here as well. Now, I can't remember. I believe this discounted price is just a or a decimal column. I don't think it actually has a dollar sign in there. I don't think it's being stored as text, nor would a greater than or less than make sense anyways. So let's just keep it like as a numeric like this. So we're gonna say if it's greater than if it's less than $100, it's tiny. And then if it's less than 200, so let's do less than 200. This is going to be mid. And then lastly, we're just doing massive. So if it's over or equal to $200, it's going to be massive. This looks correct to me. Let's go ahead and run this. And let's expand this as well. And let's go check our table view. So now if it's, let's see, here's our discounted price. So if it's under 100, it's tiny. If it is 100 to 200, basically, it's going to be, or 100 to 199.99, It's going to be mid. Then we have massive. This is 1,000. That's going to be massive. 479, that's massive. So it looks like this all performed perfectly. Let's go ahead and save this. And let's go and run our test. So let's come in here. And I'm in the wrong spot. Let's come in here and let's run our test. All right, there we go. We got it right. All right, let's move on to the next lesson, which is time intelligence function. It says, time functions in DAX help you analyze how values change over time by using your date table to understand the order of days, months, and years. Two of my favorites are, and these genuinely are my two favorites, total month to date. This is total MTD. This function calculates the total of a measure from the start of the current month up to the current date. Here's an example that calculates the number of new customers acquired in the current month up to today. So we have MTD new customers, that's just the name. Here's our function, and we're just looking at new customers, and we're looking at this date column. This one is really useful, and I actually use this in a lot of different visualizations, because if you're looking month over month, right, you don't want to look at the entire month necessarily, because if you're in a current month, let's say we're in January, and I want to compare to December, well, I'd have to wait till all of January was completely done in order to compare it to December. But what if it's the first week of January? I want to compare it to the first week of, the previous month. You can do that with this function. It's really useful. And then lastly, you have previous month. So the previous month function shifts the date context back one full month and calculates the measure for the previous month. Here's an example that calculates the number of new customers acquired in the previous month. So we're just using calculate. We're using this new customers, but now we're using this previous month function and looking at the previous month from the most current data. And so this type of function does rely on kind of current data. If your data is 6 months behind, then you're going to look basically at the 7th month back. You're looking at the most current date and looking 1 month back. So it does rely on, current data. I've used these functions for years, and you'll see them used a lot in dashboards. Now, because our data for this course is a snapshot from the past, we won't use these now, but when you have live data, they're very useful, and that's kind of exactly what I was just saying. I always get ahead of myself. But if you're looking at a snapshot of historical data, let's say you're looking at data from 2015, right? And you try to use the previous month function, you're gonna look at December, which is the most current month within that data set, and you're gonna go back to November. So you have to understand, how these work and how these operate. Now let's do our interview with Boots. It says you're building a sales dashboard with daily transaction data. So that means up to date. It's updated daily, and a proper date table. A stakeholder asks, how are we doing so far this month compared to last month? Explain which DAX time intelligence functions you would use and why. Now, as we talked about just a little bit ago when I was talking through this total month to date, this is the exact example. So I'm going to say we would use the total month to date function because we don't want to wait until the entire month's data is done to compare. We want to compare the current month's data to the previous month's data at the same time frame. Let's see if that is sufficient for Boots. I hope it is. Looks like we're off to a good start. You correctly identified the total month to date is useful here because it gives you a running total from the start of the current month up to the current date rather than waiting for the full month. You mentioned comparing against the previous month's data. That's exactly the right instinct, but which specific DAX function from the lesson would you use to retrieve the previous month's value? So if it's just previous months, then we're going to use, I'm going to say previous month function. I'm just going to keep it simple. Let's go ahead and run this. Excellent. And then he's going to give some explanation and we get it right. And so you can read through that, but I think we nailed it. I think we did a really good job. All right, let's move on to the next lesson, which is more time functions. Now, before we move on, it's worth noting that there are some particularly useful time functions. We have total year to date, which calculates year to date values, very similar to month to date, but it's just looking at the year. Useful for tracking annual performance and cumulative growth. We have date add, which shifts the date context by a number of days, months, quarters, or years. perfect for week over week or month over month comparisons. We have dates in period, which returns a rolling range of dates, essential for things like a rolling 7-day, 30-day, or 90-day performance. We also have date diff, which calculates the difference between two dates in a day, month, or year. Great for calculating age, tenure, or time to complete tasks. We have date, which just creates a date from year, month, and day values, useful for constructing specific dates in your data model. And lastly, we have today, which returns the current date, which is handy for dynamic reports and need to show today's data. If you learn all of these, you can build almost every core time-based metric, and that is true. These are probably the ones I use 95% of the time for almost all visualizations. And I will say that a lot of these are just really great for real life use cases. For example, and I think we look at this down below, I do a lot of stuff when it's like, hey, let's take a look at a monthly report or a quarterly report or a yearly report. And so you have to do time-based things a lot in reports. And so it's just great to know how these work. So here we have an example. And in this one, we're looking at the num sales in 2026. We're using calculate again. We're looking at the sum of the sales quantity, but only in a specific time period. So we have dates in period. So through here, we're passing through several different parameters. The first one is this date's date. This is just the column that we're looking at. Then we're specifying our date. Now, this is kind of a start date of where we're kind of rooting that date in for reference. And then this 1 and the year is the interval and the time period. So it could have been day, month, or year, but we used year in this instance, and we had the number 1, but we could have used 2, 3, 4. So for our assignment, we're gonna create a new discounted revenue measure in the sales table, but now we have this right here. Now the reason, and we haven't looked at SumX too much, but SumX is for measures specifically to calculate things row by row, just like calculated column does, but SumX allows you to do it in a measure, which typically it's not as easy to do. You have to use this specific calculation. So I'm gonna copy this equation. We're gonna call this discounted revenue. So let's come right over here and let's go into our sales. Let's click on new measure. We're gonna call this discounted, I need to spell this right, revenue, and we're gonna paste this in here. Like I said, we're working on a measure. So if we do the sum, because we're working with an equation where we're multiplying one thing by another, it's not gonna work properly because what it wants to do is sum the entire column, and then multiply it, which would give us an immensely wrong number. Like it just would be horrible. And so SumX allows it to perform more like calculated columns calculation. So we're gonna go ahead and create this and let's pull this over. And so now we have our discounted revenue right there. So let's go back and it says, now that we've done that, create a new measure called revenue in February. And we're gonna measure in the sales table that returns all the discounted revenue from 2025 to 1, so the beginning of the month, to 2025 to 8, which is inclusive, including that date. We're gonna use calculate with the discounted revenue as its first argument, and then measures are referenced directly, not wrapped in sum. Then we're gonna add in the revenue in February measure to our multi-value card. So we're just gonna add it to that card. So let's come back up and we're gonna see which one of these we would probably want to use. I think the one that we can use is this date right here because we're looking between two specific dates. So we can say greater than or equal to this date or greater than or equal to this date. I think that should be perfectly fine to do. There are other ways to do it, but let's look at revenue in February. Whoops, let's copy this. And while we're actually writing this out, I'm just going to bring this over here just so I can see what I'm doing. Now I'm gonna come into sales and we're creating a new measure. All right. And I just wanna make sure I'm getting the dates right. And here, I'll go like that. And I'll move this over just a little bit. There we go. Now let's create our new measure. And this one is going to be called revenue in February. So let's come over here. We're going to say calculate. And the first thing that we need to pass through is what we're actually going to be doing, which is just we're getting all the discounted revenue. So we want to do, so we're going to do sales. And we're going to pull in our discounted revenue, the measure that we just created. Then we're going to do comma. Now, I'm going to start formatting this a little better. I'm going to do, what I'm just doing is Control Enter, just so you can kind of see this a little easier. But what we now need to do is specify our date range. So I'm going to specify, I'm going to say date. For our year, we want to do the 2025. We're going to do a comma. The month is 02, and then the day is 01. and then we're gonna wrap that. So that is our date that we're starting with, but we need to say where the sales date is greater than or equal to that. So we're gonna say date, and we're taking the date. Remember, we have it, the relationship towards that date, and we're gonna say is greater than or equal to that date. And we can copy this, and we're gonna do another comma. And this is basically another filter that we're using. So we're saying where it's, now we need to change it to the 28th, where it's less than or equal to. So it's gonna be like this. So this should work. Let's go ahead and run this. There we go. Now let's expand this. All we're doing is we're adding this to the measure in our multi-year card. So let's come back here. Let's go down to our revenue in February, and we're just adding it to our multi-year card. And you click on this, and I'm just gonna click right here. And there we go, we have our revenue in February. Now that we have this, let's go ahead and save it. And let's come down here, let's get our test, and let's make sure we got this right. And there we go. And we got a ton of awards, so we are doing really good. All right, let's move on to our next lesson, which is add columns. Now we've used the select columns function in the DAX query view to return specific columns from our table. The add columns function returns the columns we specify as well as all the original columns. So this is really good. This returns the original sales column as well as the new column called discounted quantity. So we have our discounted quantity right here, which this is the calculation we're using. And we're taking all the columns in sales, but then we're adding on this last column. So it's basically just creating a calculation, but keeping all of it. It's like a select everything in SQL, right? And then you're adding on the extra column. We also have related data. When using a function like select columns or add columns, you can't reference a related table directly. So you have to use the related function. If we look down here, we have select columns, users, then we have username, user server, which is related to server's name. And we can do the same thing right here for users created at with the related dates of created at. So these are like joins, we're joining it and we're saying this is something from a different table, but we can still use it. Lastly, we have order by. So in your DAX expression within the DAX query view, you can use the order by keywords. So for selecting our columns, like we had in the previous query, we now have order by, and we can order it by ascending or descending. So ascending is just A to Z, whereas descending is Z to A. Now we have our assignment right here. We want to calculate the time since eShop upgrade for all sales. eShop's website went through a big migration and management wants all sales tagged with the number of days before or after the change. So open the DAX query view on the left-hand side of Power BI, and we are going to write an add columns query, and we're going to take all the stuff from sales, so all the underlying sales column. Then we want the sale price, the non-discontinued price of each sale, and then we want days before migration. This is the difference between the sale date and the date 2025-02-14. Days in the future should be negative. You'll want to use these functions, dateDiff and date. We'll order our results and then we will answer the questions. So this is something that we're going to need to get after we actually run the query and we get it. So let's pull this up and let's go over to our DAX. And we are going to, we can keep this for now because we'll probably use it a little bit, but let's pull this over just so we can write this out while we see what we're doing. So let's come right here. And instead of select columns, we're going to use add columns. And instead of that, we're going to use the sales table. So here's what we need. We need all the sales columns, and we've done that right here. Now, the next thing that we need to do is get this sale price. Now we can just write it like this, sale underscore price, and we now have named it, but we need to actually write this out. Now the sale price is the non-discounted price of each sale, which means if we come over here to our table view, if we look at our discounted price, this is the sale quantity times the price times the sale discount. That's our total discounted total price. But basically what we're doing is the simplified version of that, which is just taking the sale quantity times the price, because that doesn't include our discount. So let's come back here and we're gonna do a comma, and we're still within this one right here. So all we're gonna do is sales and we need the quantity, so sale quantity, and then we'll do times sales, and it should just be price, and there we go. So now we're gonna do a comma, and we'll come down here. So this is our sale price that we just calculated. The very last thing that we need to do is get the days before migration. Now this is its own column. We'll say days underscore, I could copy it, but before migration. Now we're going to write out basically an equation or an expression, just like we did up here, but now calculating the days before. Now it gives us this start date, so it's the difference between the sale date and this date. So what we're gonna use is a function called dateDiff, and that's right here. So we're gonna get this dateDiff, and then we'll use this date to create this date just like it has, just like it's written up here. So what we're gonna do is we're gonna say dateDiff, and then we have to start with our first date and our second date. It doesn't matter which order we do it in actually. One was gonna be positive, one's gonna be negative. It really doesn't matter. Let's just start with this one. I'll write it out just so we stay on my screen, but we have date 2025-02, comma 14, and then that's between the sale date. So then we're gonna do a comma. Now the next column that we need is the sale date. Now if you remember in our data, we do have this date ID, but that's being tied to another table, right? We have our dates. So we have this date ID, and then this date is the actual date column. So we need to use that related that we looked at before. So I'm gonna say related, and now we can say dates, date, just like this. So we can wrap that. And then lastly, we have our interval, and we wanna do that based off days, not months or years or anything like that. Now this looks good. Let's actually run this because I wanna make sure at the very end, we'll see if these are positive or negative. So we have a lot of negative numbers here, and some of these are positive. So we need to determine really quickly if we need to multiply it times -1 or keep it the exact way. Like I need to know, is this correct or is this backward, essentially? So let's go back to our sales date, and we can just see, we know that this is when we tie it to the other table, this will be 5/30, which is about 3 months ahead, right? So if we go over here, this is 105 days, but this is after migration. So we do need to multiply this times -1. So I'm just gonna come right here, and I'm just gonna say times -1. And let's go ahead and run this. And there we go. So now it's minus 105 days because this is before migration. If we did it after migration, 105 would be correct. I'm quite confident. Let's go ahead and add this order by, and we'll do it descending, and then we should be good to go. So now we're gonna come down here and we're gonna say order by, and then all we do is we take these days before migration. It should do it for us, days before migration, and then we'll do descending. Let's go ahead and run this. And now let's take a look at this. We have 409. Let's go see if 409 is an option, and it is. That is a very good sign. Now this was a bit difficult in terms of, figuring this out on our own, but I think we did a really good job. So we're not gonna save this or run anything. We need to answer this. So let's go ahead and select our 409, and we were correct. Good work. All right, let's move on to the next lesson, which is aggregations. Now, aggregations are something we've already covered a little bit when we've done things like sum or sumx, depending on a calculated column versus a measure. So aggregate functions in DAX aggregate a result from multiple rows in a column. These are super common DAX functions, and they form the foundation of almost every measure you'll write. Aggregations answer how much, how many, what's the average for a column. We've already used some of these, but let's cover some of the most common functions in more detail. Now these should look really familiar, and if not, that's okay, because these are the ones that you use most of the time. Here we have sum, and that's just going to add all the values in a column. We did that before with something like sum of the sale quantity. Next, we have average, which is going to take the mean. So it's going to add all of them up, do a count on it, and then divide by that count to get the average after it's summed and then taken the count and seen what that average is. It's going to look just like this. It's actually written out AVERAGE, whereas in a lot of other systems, it may just be AVG as a short and abbreviated version. Next, we have the count, and these count all values in a column, not just distinct ones or unique values. Next, we have min and max. Now, minimum returns the smallest value and max returns the largest value within a column. So we have our assignment right here. We're gonna create a new measure on the stores table. So let's go ahead and open this up. This is from our last lesson. We're gonna go to our stores real quick. So let's come over. We're gonna go to our stores. We're gonna create a new measure and we're gonna call it the oldest store open date. And it's gonna contain the date that the first store was opened. And then we're gonna add a measure to our existing multi-card on the cards page on the report and we'll save it. So I'm going to copy that. Let's expand this and we're gonna create a new measure in the stores and we'll come right here. Now within this stores, we have the store open date. So we need to find the oldest one, which should be the minimum value. So we're gonna say minimum value and then we'll do stores and we'll get the store open date and that should be good to go. Let's go ahead and run this and make sure it's in here. Where's our stores? Oops, what am I doing here? There's our measures. So we have our oldest store open date. That looks like it should be available. Let's go to a report and click right here. And now we're going to, not our sales, we're going to our stores. So now we have our store open date. Let's go ahead and add this. And this was added to our categories. Let's actually add it to right here in our value. So now if we wanted to, let's just expand this for a little bit. It'll give us the date. It's not formatted properly. We would need to fix that, but I just want to save this and submit it to make sure we get the test right. But there is the full date. It's just formatted like, let's go into stores real quick. It's just formatted like this. And it should be this one right here, or actually this one right here. It's Sunday, April 22nd, 2018. And so this Sunday looks right, but I don't want to mess anything up. Let's go ahead and save this. There we go. And let's run our test and see if we get this one right. It wants it as a string. Okay, that's okay. I can fix that. Let me see. Or maybe I just wrote it wrong. It is possible I just wrote it wrong. Oldest store open date. Oh my goodness. It says it doesn't have the oldest store open date. Let's go back. I actually think I just clicked on the wrong one. I just clicked on the store open date. I need the oldest store open date, which is April, let's see, 4/20 of 2018. Okay, that looks correct. All right, I got ahead of myself. That does look correct. All right, so now let's save this and that should be good. And let's run this again. I'll just copy it from here. Let's run this one more time and see if we get this one right. All right, and there we go. Listen, I make mistakes too, but we figured it out and we are gonna keep going. All right, let's move on to the next lesson in our DAX chapter, which is aggregations as measures. So it says a common mistake in DAX is using aggregators like sum in calculated columns instead of measures. Don't do that. It will return the same number on every row because calculated columns are row by row, not a single value for the whole table. So let's come down here. This means it doesn't respond to filters. It takes up storage in your model and it behaves incorrectly in visuals. A sum in a calculated column is almost never what you want, and that is true. Instead, use a measure for aggregations. A measure is a single value that recalculates dynamically based on the current filter context. This means it changes when you slice it by date, customer, or product, returns different values depending on the visual, uses no extra storage, and reflects how much was sold in the filtered context. Measures think in totals, columns think row by row. An aggregator like sum belongs in a measure. So all it's doing for these is it is summing all of them and then it's putting it in here. So every single row is gonna be the same thing, which typically isn't what we want. If you're gonna do row by row, which is great for calculated columns, you're gonna wanna do something like, a multiplication. You're multiplying this times this, which would be 15 over here, this times this, 15 over here, right? That's what a calculated column is great for. But for something where you're looking at all of them, where you're using aggregations, you're typically gonna use a measure. Now, you're reviewing a Power BI model and notice a calculated column that uses sum of sales amount. The column shows the same value on every row. Explain why this happens and what should be done instead. So what we're going to say is it's summing the entire column and putting that value on every row. This most likely, I need to spell right, is incorrect. Using a measure is better because it'll calculate the aggregation dynamically on the fly as needed. And let's make sure I spelled this right. All right, let's go ahead and see what Boots thinks of this. Excellent answer. You correctly identified the sum. Well done, concise answer. Wow, I'm killing it. All right, let's move on to the next lesson, which is iterators. Now, these are gonna look very familiar because we actually covered one earlier on. I talked about it a little bit. Something like sum x, and there's other aggregations you can use as well, but let's look at this. Iterator functions in DAX evaluate an expression row by row and then aggregate the results. They allow you to define what should happen in each row before summing, averaging, or comparing. Aggregators look at a column, while iterators look at each row first, which is basically what a calculated column does. And so within a measure, you're kind of treating it like a calculated column, which is really nice. So let's look at sum x. The sum x function iterates over a table, evaluating an expression for each row, and then sums the result at the end. That's the important piece. So here we're doing the sales quantity times the product list price, but it's summing it after it performs row by row calculations. So that's really important. Related lets us access one from another table. This works because the sales and products table have a relationship, and we've covered this in the past. Now let's look at average x. The average x function works similarly, but averages the results instead of summing them. So average, min, max, all of these are gonna perform the row calculation and then the aggregation afterwards in a measure. Min x is just gonna find the minimum value, while max x is gonna find the maximum value. So the iterator function names always end with x, makes them easy to spot and kind of remember. Our assignment is to create a new session quality score average scaled measure on the website sessions table. Let's just pull this up real quick just so we can look at what we're working with here. Let's go back to let's go to the table and let's go to our website sessions. So it wants us to average the quality scores of all sessions, but only after multiplying each score times 100 to get a range from 0 to 100. So let's come over here and let's find the score. We have our session quality score, but it's a decimal, right? So we want to multiply this times 100 and then do the average, so average x. So this should be all right. Then convert the result to an integer after the average is calculated. You can use the int function to convert a decimal value into integer. So let's come right over here. We're gonna go to our model view. Let's go to our website sessions. Let's create a new measure after I copy this because this is way too long for me to remember. I just know myself. I'm gonna mess it up. Let's create this new measure. And this is gonna be not a huge one, but it's gonna be a little bit more complicated. So let's come down. If we come up here, we actually can see what this is gonna kind of look like, right? In fact, this one where we're creating this sum x, or actually the average x, this is really what it's gonna look like. Let's just copy this to save us some time writing all the syntax out. And we're gonna put this right here, but instead of average x, instead of sales, we need the website sessions. Now, how do we calculate this? What we need to do is we need to get the average after multiplying the scores times 100. So we're gonna take the website sessions and we need to find those scores. So here's our session quality score. Let's get rid of this. And we're multiplying it times 100. Now, when we do this, it's going to still give us a .00 at the end. In fact, if we wanted to, we can go and look at this in the DAX query. But what we're gonna do is wrap this entire thing in the integer. So we're gonna convert it to an integer next. We're gonna add this to our multi-existing card, which we have so many there, but we're still gonna do it. So now we have it. We have website sessions, and then we're taking the website sessions quality score, multiplying it times 100, as they told us to do, and then we're converting it to an integer, which we did right here. So let's go ahead and run this. We didn't get any errors. That's a very good thing. Let's add this score to the multi-value card, and then we'll save it. So let's come right over here. We have this. We need to go to our website sessions, and we need this long one right here, which is our session quality score average. So let's find our average real quick. Let's just see what it looks like. 32.63, and that looks really good. So let's come up here, let's save this, and let's run this as well. So we're gonna come right here, and let's run it. And there we go. Let's move on to the next lesson. Now let's take a look at calculated columns versus measures. We've discussed this a lot, but let's take a look at this a little bit more in depth. Iterators are a type of aggregator, so you almost always want to use them in a measure rather than in a calculated column. It's tempting to use an iterator in a calculated column because the math is done row by row initially, but it still needs to be properly aggregated at the end, so it should still be done in a measure. Here's a table showing the difference between a calculated column and a measure using SUMX. So right here in total revenue column, this looks correct, right? All these numbers make sense, but then with a calculated column, just you're summing all of this together and you're getting one number. Just doesn't look good. So measures respond to slicers, filters, and drill downs, and the column never changes, and calculated columns will not. So just like aggregators, iterators belong on measures. So let's answer our question. Why should iterators usually be used in measures instead of a calculated column? So we have measures aggregate dynamically and respond to filters, slicers, and drill downs, which is true. Calculated columns perform less work during aggregation. And then calculated columns automatically respond to slicers and visuals. Seems like this is our only answer here. Let's go ahead and click on it. And there we go. All right, let's move on to the very last lesson in our DAX chapter. I know that you want to keep learning about DAX, but this is the last one in the lesson, or the last one in the chapter. So this is context in DAX. Context is one of the most important concepts in DAX, and it determines how a DAX expression is evaluated and which rows are included in the calculation. There are two types of context you need to understand: row context and filter context. Row context tells DAX evaluate this row, whereas filter context tells DAX evaluate these filtered rows. Row context in DAX exists when DAX evaluates a formula for each row of a table, and you get row context in DAX when you create a calculated column, which we've done, use iterators like SUMX, AverageX, MinX, MaxX, or use add columns. So this is just an example of a calculated column for us. DAX evaluates this expression for each individual row. No slicers or visuals can change this value because row context is created at model processing time. So row context equals DAX evaluating expressions row by row. But now we have the filter context in DAX. And this exists when DAX evaluates a measure using only the rows allowed by filters. Filter context is created by visual filters, slicers, page report visual level filters, relationship filtering between tables, and the calculate function, which can modify filter context. And here's a very simple example of a measure. So when DAX runs this measure, it applies all the filters and then calculates it after. So we are visualizing slicers, filters, calculates, and then it sums the quantity column only after the rows in the filtered set. So it's doing all of these different things to it first before we've narrowed down exactly what we want to calculate. So we have filter context equals DAX evaluating expressions using the currently filtered rows. So here's our assignment. Navigate to our cards page in the report view. All right, let's go and do that. Oh, and we are there. All right, we're good to go. Drag the dates table date column to the filters on this page section. So let's go to dates, and we have date, and we should filters on this page. Which one we were doing? Yeah, filters on this page. I just want to make sure. So let's bring this date to filters on this whole page. And there we go. Now what we're going to do is check the Tuesday, January 2nd of 2024. But here's what we need to kind of notice. The total revenue measure changes. Total units sold measure changes. The customer average age does not change because customers does not relate directly to dates. Revenue in the February date constrained aggregate measure does not change, and the session quality score iterator measure does not change. So let's click on Tuesday, January 2nd of 2024. Tuesday, January 2nd of 2024. And I'm noticing this right away. There's only a few that are changing, and that's just for all the reasons that we've talked about in terms of how relationships move together, how measures are calculated, and all of these different things. So it looks like all of our stuff is working properly. Let's go ahead and save this. And we're going to come right here and let's run our very last test in the DAX chapter. And there we go. Awesome work on DAX. I know that's really hard, but DAX is absolutely something that you need to know. All right, we are moving on to the next chapter, which is more charts. Now in Power BI, in just visualization in general, there's lots of different charts that you can use. So I want to at least expose you to some of these different types so that you can, really learn the best ones and the ones that I personally like. Now, radial gauges are a great one to start with because they're really simple, but they're really effective in showing different forms of visualizations. It says a gauge visual are great for showing progress towards a target. They're perfect when you want to track performance against a goal like session quality, conversion rates, or average order value. Now, this is what it looks like. And so what we can do is we're going to be able to set targets, and we'll talk about that in a little bit, but we're able to set some milestones and some of the values that we're looking at and what we're trying to target and hit. And so let's come down here. Gauges are one of my favorite visuals for executive dashboards that instantly show, are we hitting our target or not? And that's literally all it is. Let's say we're halfway to our target. We show halfway. It's pretty easy for anybody to be able to understand this type of visualization. Gauges need a target to be meaningful. In recent versions of Power BI, you can't just type in a target number directly. You need to use a measure. If Microsoft is out there listening, I don't know why they did this. It was so good before. You could just go in and set your target as a number, but now you have to create a separate measure. It's a thing. You have to do it. I think it's ridiculous, but that is how they do it. This is actually a good thing because it keeps your targets consistent and maintainable. There is truth to that, but again, I don't like that you have to set its own measure. You used to just be able to put this in there and it would stay there, but it didn't have to be a separate measure. So yes, it is true that it makes it easy to kind of set and be done with it. I just miss the old way, if I'm being honest. So that's it. A measure just returns a constant value, simple but effective. Now, we're gonna create a new page and call it KPIs. So let's come right here. We're gonna go down and we're gonna say, let's rename this. We're gonna say KPIs, just like this. Now, we need to create a measure on the website sessions and called target quality score and set it to 50. That's it. There's no aggregations, no anything. We're literally just setting it as a number. And that's what we were talking about just a second ago with having to create a measure instead of just typing it in like it is. So we're gonna go to the website sessions. We'll have target quality score is 50. So let's go do that one. And we can do it anywhere, but it's just we've been doing it here before. So let's go to new measure. Let's set our target quality score is equal to 50. And that's perfect. And now let's do our next one. Create a new measure called max quality score, and we're gonna set it to 100. So let's come right here, go to website sessions, new measure, and there we go, is equal to 100. So this is the top score that someone can get. Let's come back. Now we're gonna insert a gauge visual in the top left quarter of the page. So let's come back and let's go to our report. And so we have our gauge right over here. And we're gonna put in the top corner. So we need to go halfway this way, halfway down, and there we go. So let's see what we're putting in here. We're gonna drag the session quality score average scaled to the value field. And then for our target, go to target, max, go to max. Okay, but session quality score average scaled to the value. So let's come over here. Let's come down here to this one, and we have it clicked on it. Let's drag this over to value. And so this is our value that we're putting in here, but now we're gonna add two separate things. We have our target quality scored, so we're gonna add that to our target value. So now we have our 50, which is right here. Now this is based off of this 65.25, but that's not our actual maximum. Our actual maximum right here is our max, and we'll put that in as the minimum. So you can see right here, here's our target. Here's how close we are to getting to it. And there's the maximum. We can also set a minimum field. If we wanted to do 0, we could also put it as 10, 20, 30. This would just move back if we raise that number. So this looks good. Let's see if there's anything else we need to do. Nope, we just need to save it and submit our test. So let's come up here. Let's hit save. And let's go ahead and run our test. There we go. And we are starting off our next chapter very well. In our next lesson, we're gonna be taking a look at pie charts. Now, I know what you're thinking. Alex, I've seen memes online making fun of pie charts. Aren't they ridiculous? Aren't they silly? No. They're not silly. They're not ridiculous. I myself have made fun of them. That's because I know them, right? You can make fun of your best friend, but you can't make fun of like some kid you don't know. All right, I know pie charts, so I can make fun of them. You haven't earned that right yet. But pie charts are great, and I promise you, you're gonna see why they're useful. So let's get into it. A pie chart represents data as slices of a circle, showing proportions of a whole. Each slice represents a category's share of the total. Pie charts work best when you have a small number of categories, and that is 100% true. If you have like 20 categories on here, it looks horrible. You can't understand anything. So it's good to have like under 6 or 7, honestly. But it's good under ideally 5 or fewer, and want to show each part that contributes to the whole. 5 or fewer is ideal. You can go up to like 6 or 7 though, if I'm being honest. Pie charts get a bad rap in the data viz community, but they're perfectly fine for simple proportions. Just don't use them for comparing similar sliced pies. That's where they fall apart. So when to use pie charts? Showing market share or revenue split, displaying category breakdowns like sales by store type, visualizing budget allocations. Here's when not to use it. When you have more than 5 to 6 categories, when slices are nearly the same size because it's really just hard to compare, that's when you use something like a bar chart. Or when you need precise comparisons, use a bar chart instead. All right, I'm getting ahead of myself. Here's our assignment. On the KPIs page, insert a pie chart into the top right quarter. So let's go ahead and do that. So let's come right here. Let's get our pie chart. So there's a donut chart and there's a pie chart. We want the pie chart. I need to click on this. Whoops, I don't want to do that. Let's click out and then click on the pie chart. We'll drag this one to the top and that should be perfect. I think that's situated exactly right. Yeah. So now that we've done this, drag store type from the stores to the legend field. So store type from stores onto the legend. So we'll go to stores, we'll go to store type, and we'll drag this down into the legend. So these are gonna be the only 2 colors that we see in our visualization. Next, we'll drag the sale quantity from sales to the values. So we're doing sale quantity. Let's go ahead and look at store sale quantity, which is right here. Go to sale quantity. We'll drag this over to values. So you can see right here, and I'll zoom in for just a little, oh my goodness gracious. Let's go over sale quantity. You can see we have 40%, which is this right here. We also have 59.79%. So it's very easy to visualize on this example. You can see that retail is a lot more, just super easy to tell because that's what, pie charts are really good for. Now let's go back a little bit, just so we can see everything again. And let's get rid of this filters just so we can see it all. So that it looks really good. Next thing we need to do is format the title. General title text, and we're gonna do sales by store type, and there we go. So not anything else, no sizing difference, but we're just gonna change it. So general title text. Let's come back here. We're going to general title, and within the text, we're renaming it. And there we go. So let's go ahead and save this, and we should be good to go. Let's go ahead and run our test. And let's see how we do. All right, we have got pie charts on lock. All right, now we are looking at donut charts, and donut charts are basically the same thing as pie charts, if I'm being honest. They are almost essentially the same thing, and I say it right here. It's essentially the same thing with the hole in the middle. It looks like a donut. It really is that simple. The hole in the middle isn't just for looks. It can be used to display a total or key metric, making the chart more informative. It is true, but I will say I personally, in just the world of data viz and having used Power BI for a long time, I use them pretty interchangeably. There isn't any major difference other than saying, hey, I didn't use a pie chart. I used a donut chart. It's like the more elevated type of chart. I don't know. The choice between pie and donut is mostly aesthetic. Some people find donuts easier to read because the focus shifts to the arc lengths rather than the angles. Others just think they look more modern, which is true. Some people just like the visual of it. Whichever fits your dashboard style better, just be consistent across your reports. Now, here's the best practice again. Use 5 or fewer categories for readability. Make sure the measure represents parts of a whole. Use consistent colors in comparing multiple charts. And consider putting a key metric in the center hole if you want. Let's look at our assignment. We're gonna stay on the KPI. We're gonna use a donut, and it's gonna be on the bottom half. So let's just get that first. Let's get our donut chart. We're gonna click out of this, get our donut chart, and we're gonna get the entire bottom half. So what we're gonna do is we're gonna update the chart to show total revenue by product category. It says it's totally valid to use an aggregate measure as a value in a donut/pie chart. The legend field can split the aggregation across the groups. So update it to show the revenue by product category. And we're doing total revenue. So total revenue is right here. That's gonna be our values. By product category, so let's go to product, and we'll go to product category. That'll be our legend. So we have our legend over here, and here are our values, and this looks great. So we have appliances is about 60%, right? Then we have 32.55% for electronics. Those are our big two. Those represent most of them. Next, let's rename this as revenue by category. And we'll just start with that. There was one more thing it looks like we need to do, and we'll do our text. That looks great. Oops, let's click back in. Set the detail labels to inside. So we'll go to visual format, detail labels, options, position inside. That's gonna be okay for this one. It is getting small, right? If we made it full, 100% put it inside. But let's come right here. We'll go to detail labels, position, we'll do inside. And again, I do this a lot when, it's like this. I may not do it when it's this size right here. You can tell the difference, right? You can see the difference. That's what we're gonna do. Let's go ahead and save this, and let's run our test. So let's come right here. Let's run this. And we have pie and donut charts. We just know them. Like, they are our best friend now. All right, let's move on to the next type of chart, which is an area chart. Area charts are just like line charts, but with the spaces below the line filled in. The shading emphasizes the volume or the magnitude of values over time. It's gonna look a little bit like this, but you can also have multiple colors if you add in a legend to break it out by different categories. Area charts answer the question, how is this metric trending over time and how much of it is there? So a line chart, you can basically replace this with a line chart, but this is kind of a more visual way to show things, like volume of sales or volume of something. So when to use an area chart? Showing cumulative totals over time, emphasizing the magnitude of change, not just the direction, and then comparing multiple series that stack on top of each other. Another thing that you can do is add a secondary axis. And so we'll look at this when we get in there and I'll explain it more in depth. But sometimes you want to compare two metrics that have different scales. So for example, you have something that's 1 to 1,000, you can have an axis for that. And then on the other axes, you can have one that's like 0 to 50. But then you can compare them better in one visual. And so we'll show how to do that. For example, session duration in minutes, and we can't really see this because it's really small, and page visited count don't share the same range. A secondary y-axis lets you plot both of them in the same chart without one metric squashing the other. So that's what this one is right here. So use a secondary axis sparingly if two metrics aren't closely related, considering using two separate charts. And that is true. They need to kind of correlate to one another, or at least make sense to put on the same chart. If they're two totally random things, it doesn't make sense to, put them in the same place. Let's create a new page and we're gonna name it Trends. So let's come right down here. We're gonna call this one, let's get rid of this. We'll call this Trends. And let me zoom in 1. There we go. That looks good. Insert an area chart spanning the top half of the page. Let's come in here. An area chart should be right here. And we're gonna make this go all the way over and all the way to halfway, and make sure this side is all the way over too. There we go. So now we are good. We've got it set where we want to have it set. Configure the chart to show how the session duration minutes changes over the session date. So session duration minutes over the session date. So let's come in here and we have website session duration minutes. We'll put that on the, I think that should be the y-axis, because then we want the date on the bottom, which is going to be our date up here, which will be date for the x-axis. Now let's come back. Let's see if there's any more specified things. It says ensure the x-axis is not set to date hierarchy, which it is right now, but to session date. You can change this by clicking the down arrow on the session date field in the x-axis. So let's come back here and we're gonna come here and instead of the date, and now we'll come over here and we'll get the session date. and we can pull this over to the x-axis. And so this looks really good. You want to make sure, by the way, that it can be in date hierarchy, but you can also set it to session date. For this exact example, the date hierarchy may work fine, but just set it to session date to make sure that it's working properly. Now this looks really good, right? This looks like a line chart, but just with the area bottom shaded in to give some depth to it. Now it even says here, ensure the x-axis is not set to the date hierarchy, but to session date. You can change this by clicking the down arrow on the session date field in the x-axis as well. Now add session pages visited to the secondary y-axis. So session pages visited. So here we have session pages visited and we have our secondary y-axis. Let's drop that in. And so on this side, you can see this is the sum of session duration minutes, sum of session pages visited. We have two separate axes and they have 0 to 200 for this side, but 0 to 600 for this side. But you can see these are very closely correlated, just how they're kind of moving. Then we're going to format this to session duration and pages over time. We're just going to rename this and save it. Now we'll come here, go to general. You should be able to do this by now. I am positive of this. And there we go. So this one looks good. Let's go ahead and save this. And let's go run our test to make sure that we did this properly. All right, and there we go. All right, let's go on to our next lesson, which is scatter plots. Now, scatter plots help you explore the relationship between two numeric values. They have to be numeric. That's just the rules. Each point represents a single record plotted by its x and y values. They're perfect for spotting correlations, clusters, and outliers in your data. For example, in this one, just when we're looking at it, you can see this one way down here and this one way out here. I would be really, interested in those data points. I'd be like, let me go look up those values. And you can do that pretty easily. I use scatter plots constantly for two things: finding trends between variables and catching outliers that might indicate bad data. That is 100% true. You can even see we have a trend line right here. This shows a positive correlation. And so you can extrapolate a lot of information from scatter plots. They're really great. And even here we have correlations. When points trend upward from left to right, which we just saw, that's a positive correlation. As one value increases, so does the other. In our website sessions data, we'd expect longer sessions to have more pages visited. If they spent more time on the platform, they're going to visit more pages. When points trend downward, you have a negative correlation. As one goes up, the other goes down. That's a negative correlation. So let's look at trend lines. Adding a trend line makes correlations easier to see. Power BI can calculate and display this line automatically through the analytics pane. Look for points that fall far from the trend line. These outliers might be data entry errors or genuinely unusual records worth investigating. 100% true. I used to do this a lot with medical data. We would track a lot of patients, and if some patient just was really outside of the norm, I would go and look at that person because, that's really useful data for, the doctors I was working with. Now we're going to create a new page and name it Analysis. And I'm pretty sure we'll come back to this one at some point. So let's come in here. I'm going to say Analysis. Yeah, I spelled that right. I mean, my name is Alex the Analyst. I should be able to spell this right, but you never know. You just never know. Insert a scatter plot in the left half of the page. So scatter plot in the left half. And this is our scatter chart is what it's called. In here at least. There we go. All right. And let me go all the way to the left with this. All right, so we have our scatter chart. I'm gonna call it a scatter plot because I've never called it a scatter chart. It says configure the chart to compare session duration minutes on the x-axis against session pages visited on the y. So minutes on the x, visited on the y. And let's go to minutes on the x and session duration, pages visited right here on the y. Now, it's going to say right here, by default, Power BI will aggregate or sum both axes. Right-click on each field and select Don't Summarize. We want the raw values to see the raw data points instead of aggregated totals. Sometimes I just need to stop. I just need to keep reading. I get ahead of myself. So we're going to come up here. Instead of the sum, we're going to say Don't Summarize. And we're going to do the same thing here. Now, there are times where you want to sum. Just so you know, there are times where you want to do that, but not here. So now we have our X and Y. That's just the raw data, the raw values in our table. Let's come back down. Add a trend line by clicking the Analytics tab, trend line on. So we're gonna come right over here, and this is our further analysis for your visual. We're gonna turn that trend line on. So this looks really good, although I like to change the color and the size of it. That's hard to see. In my opinion, it's just a bit tough to see the black. But here we're going to change the trend line color to theme color 2, the blue one, and make it solid so it stands out. So let's go in here and let's go back. So in the color, this is theme color 1, theme color 2. I'm gonna say it's this one. And instead of dash, we're gonna make it solid. So now this really stands out. I think you can choose any one. I mean, they're all theme color 2s, right? I can't tell which one's the best one. You can make it whichever one you'd like. I'll keep it this one just for the sake of doing it. But this looks good to me. And then we're gonna change the title right here. And we know how to change the title. This isn't our first rodeo. So we'll go back, we'll go to general, title, and paste that in there. So this looks really good. Let's go ahead and save this. And yeah, I mean, that's all it is. Scatter plots are pretty great, if I'm being honest. Let's go ahead and run this test. Make sure we got this right. All right, there we go. All right, let's move on to the next one. And this one, in my opinion, is the one that you're gonna see and you're gonna think, wow, that's really impressive. It's not that complicated, but it looks really good. And you'll see this on a lot of financial reports, these waterfall charts. And so I think these ones just look impressive, but you can use different types of charts for this. But again, I like waterfall charts. I will use them. These show how a total is built up or broken down across categories. Each bar represents an increase down or up, with the final bar showing the total right here. They're perfect for explaining where did this total come from or what contributed to this change. You will see this. Again, you'll see this with a lot of, financial reports. That's what I've used the most in. Waterfall charts are fantastic for financial reporting. I'm always getting ahead of myself. They make it easy to see which categories are driving growth or dragging down performance. I just need to stop talking and just keep reading. Reading a waterfall chart. Green bars represent increases or positive contributions, where red bars represent decreases or negative contributions. The blue bar at the end shows the running total. So this is basically, you're trying to show a story in this. It shows a start at 0, it adds or subtracts each category contribution, at the end has the final total. Here's when you use these. Breaking down revenue by product category, showing profit and loss by department, explaining budget variances, or visualizing how different factors contribute to a final result. Now, this is what we're about to build. So we have our assignment. On the analysis page of the report, insert a waterfall chart into the right-hand side. So let's come in here, and our waterfall chart is right here. Let's make sure we're not clicked into our other one. There we go, it filled in the entire side. Now we're gonna configure the chart to show our total revenue on our y-axis by product category. So category, in our category, and then the y-axis is total revenue. So let's go get our total revenue first. And it should be right up here. That's gonna be our Y. Then we're gonna come up here, and then we're gonna come up here and get product category for our category. And there we go. So this looks really good. So we have appliances, boom, that's 0 to 100,000. And then for electronics took us up another about 60,000, 55,000. And then we have health, but we can see really quick that appliances was the biggest contributor to our positive revenue for our company. Let's rename this, and then we'll save it and run our test. We'll come in here, we'll go to our general title, and let's make sure we change that correctly. And this looks great. Let's go ahead and save this, and we'll go and run our test. All right, and there we go. All right, let's move on to the next lesson, which is ribbon charts. Now, ribbon charts show how categories change rank over time. The ribbons connect each category across time periods, making it easy to see which ones rise or fall in position. And it's gonna look exactly like this. So if you see this purple one right here, it's starting in kind of this third position, then it goes down, and then it goes all the way down to the bottom. And so you can follow this over time. You can very easily see it. That's what ribbon charts are good for. Ribbon charts are awesome for competitive analysis. Which product category is winning this month? Which one is losing ground? The ribbons make it instantly obvious. When to use ribbon charts? Tracking market share rankings over time, showing which product or regions move up or down, visualizing competitive positioning changes, any scenario where relative rank matters more than absolute values. And now let's go on to reading a ribbon chart. Categories are stacked by their value highest on top. Ribbons show how each category moves between time periods. Crossing ribbons indicate a change in that ranking, and the width of each ribbon represents that value or how big that value is. Now let's create a new one, and we're gonna call it rankings. So we need to create a new page, and we're gonna name this rankings. All right. Now we need to insert a ribbon chart spanning the entire page. We're gonna see this whole thing. Now the ribbon chart is this one right here. Let's come in here and drag it for the entire size. There we go. So now it's covering the entire thing. So configure the chart to show total revenue by product category for each day of the week. And it says the legend field determines which categories get their own ribbon. The x-axis should be your time dimension, use day of week or the date weekday, and y-axis as the metric you are ranking by. So if we come back in here, let's come up to, we have this date weekday, that's gonna be our x-axis. Then we have our total revenue, and that's gonna be our y. But then we want to split it out by the product category, which is our legend. And so this looks exactly right. Let's go down. And we are going to change the title really quick. And we'll do it just like that. And there we go. So this looks good to me. We can always go in and we could change some things like the order of these days, you know, or if we wanted to break it out by different categories or whatever. So anything we want to change is customizable here, but we're just going to keep it like this just to make sure we get it right for our test. So let's go ahead and save that. Let's go down and let's just make sure we got everything. Let's go and let's run our test. All right, and there we go. Now let's look at the next type of chart, which is a combo chart. Combo charts combine two chart types, usually a bar and a line, in a single visual, and you can see that right here. So we have a bar chart, and then we also have a line chart. They're useful when you want to compare two related metrics that have different scales or units. Let's go down here. It says combo charts are perfect when one measure helps explain the other. For example, did sales go up because we offered bigger discounts? So again, these are related things, not completely unrelated things. When to use a combo chart: comparing volume, the bars, against a rate or percentage, the line. Showing sales quantity alongside average discount. Displaying revenue with profit margin trend, or anytime two metrics tell a better story together. Here's effective tips. Use bars for the main metric and lines for the supporting metric. It is possible to do it the other way. It's just harder to kind of understand it visually because the bars stand out so much. Make sure two metrics are actually related. Don't overload it. Two measures is usually the sweet spot. If you start adding 3, 4, it gets crazy. Consider using different colors to clearly distinguish the bar from the line. Now, combo charts can get confusing if the two metrics aren't related. If viewers have to think hard about the connection, consider using two separate charts instead. Remember, simplicity, 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 KISS. Just keep it simple. If it's too difficult for you to understand right away, you're making it too difficult. Now let's go back to our trends page and insert a line and clustered column chart in the bottom half. So we're gonna come right down here to trends in the bottom half. We're gonna do this one right here. Actually, that's a stacked. We want the clustered column chart. Let's make sure this is all the way up, and there we go. All right, let's go back here. And we're gonna configure the chart to show the sum of sale quantity as the column's y-axis. Let's just do that first. The sum of sale quantity as the y-axis. So let's come down to sales. The sum of sale quantity as the y-axis, and there's our sum of sale quantity. Now the average sale discount as the line's y-axis. So we just did the columns, but now we're doing the line's y-axis. So now we're doing sale discount, and that's gonna be the line y-axis. Let's go back. Now we need to look at it over time. So this is the date week, i.e. the week of the year, 1 through 50, as the x-axis. So let's come back, and we want to come back up and get the date week as the x-axis. So now we can see over time, so this is through the full year, we could have done it by month, quarter, whatever, but over time, we can see that the sum of the sale quantity, our sales, are really closely related to the sum of the sale discount, right? So as people are using more discounts, we're making more sales. So that's a good thing. Let's change our title here, and just an interesting note, but then after that, we'll save this and we'll be good to go. So let's go back to title. Let's save that. And that looks great. Let's save this and run our test. And it's right in, whoops, it's right in here. All right, what failed? Now it looks like we failed. If we come up here, it looks like our aggregations are incorrect. Let's come back up, and that's the issue right here. So this is supposed to be the average sale discount, so the sum. Let's come back, and for the sale discount, we just need to change this to average, and there we go. Now, based off of the average sale discount, there's some crossover here, there's some correlation, but it's not as heavily as the sum. Now let's save this because we want to get this right, and let's run this one more time. We should get this correct now. Gotta always check the fine print, and there we go. All right, in our next lesson, we're gonna be taking a look at my top 3 most useful charts. Now, Power BI offers dozens of types of charts, but in practice, most dashboards rely on just a handful of visuals that consistently communicate information clearly. Simple charts get used, complicated charts get ignored. And that is true. I often will try to make things a little too complex because I think that's what makes it looks best. And then I hand this off to a manager of like the IT department and they say, hey, I don't understand this. Can you make this simpler? And then I go and do that. It is best to start off as simple as possible. It really is. So here are the ones that I see most often. We have bar charts. They're the most versatile and widely used chart type. They're great for comparing values across categories like sales by region, revenue by product, customers by segment. Bar charts make it easy to see differences at a glance and are intuitive to basically everybody. Everyone knows how to use them. Then we have line charts. These are the second most useful and popular. Line charts are the best choice for time-based data. They show trends, growth, and changes over time, commonly used for monthly revenue trends, daily website traffic, or year-over-year performance. You can use other ones, like even the area charts that we looked at previously. Just depends on the use case, area charts, or you can even use the ribbon charts. They're all really good. Just depends on what you're using it for. And lastly, we have cards and KPIs. Cards and KPI visuals highlight important numbers. They're best for totals, averages, percentages, and key performance indicators or KPIs. They're commonly used for total revenue, customer count, conversion rates, year-to-date sales, and these visuals are usually placed in the top of a dashboard to immediately communicate the most important metrics. I have KPIs or cards in basically every single dashboard that I make, just because it's super easy to look at it and everybody can read it, right? It doesn't take anything fancy. Let's come down here and watch this video. Many people think that being a great data analyst and being great at creating dashboards and creating visualizations is using the most advanced ones that you can use for every situation. In reality, this usually is not a good practice and I don't recommend it at all. The best dashboards often rely on a few key visualizations that are very common because businesses don't care about complexity most of the time. They really just care about getting the insights that they need out of the data. Let's take a look at the 3 most useful charts that I have used as a data analyst. And the first one is going to be your classic bar chart. Bar charts should be your go-to choice for comparisons. If you want to compare different data across categories, this is probably the one that you should be using. Think about visualizing something like the sales by the age demographic, or maybe you're looking at different products and you want to know how many of these things you have sold. These would be fantastic things to visualize with a bar chart, and bar charts are really easy to read and really simple for stakeholders to understand. The next most popular visualization in Power BI is definitely the line chart, especially if you have anything involving times or dates. Maybe you're looking at something like the stock price over time, or you want to see how much you're making year over year, comparing last year to this year. These are things that a line chart would just be perfect for. You can see the trends and the patterns and the changes over time, which makes it really great for a lot of different use cases. The last one that we have is a card, and it's super simple. It literally is just a KPI or a metric that you put up in your visualization. But usually that is something that is really important to track and that somebody really wants to know. And so maybe it's something like your churn rate for that month, or maybe it's the total customers that you have. Whatever that one number is that you're looking for, you can just put it in your dashboard. It makes it really easy to read and understand. This is just a side note. This is usually something that I put at the very top of the dashboard, just as something that somebody can quickly look at and see immediately when they open up the dashboard. I have built several dashboards where these are the only 3 types of visualizations that we use. I've also had other ones where we use really complex visualizations, but it doesn't happen as often. If you know these 3 types of visualizations, you're gonna be able to create really good, really usable dashboards in the real world. All right, I hope you enjoyed my face just a little more than usual. Let's come down here to why these charts matter. These charts cover most types of real world dashboard needs. Bar charts for comparing categories, line charts for tracking performance over time, and cards for highlighting key metrics. If you master these charts, you genuinely can build clear and effective dashboards without relying on overly complex visuals. The fancier chart types we covered in this chapter are useful in specific situations, but these three are your bread and butter. When in doubt, use a bar chart. Seriously. And that is true. Bar charts are just like universal. Everyone kind of understands them and knows how to use them. So which set of chart types does Alex recommend using most in real world Power BI dashboards? Tree maps, gauges, and decomposition trees? No. Scatter plots, radar charts, and waterfall charts? No. Bar charts, line charts, and cards/KPIs? That is the one. And there we go. All right, in the very last lesson of the More Charts chapter, we are taking a look at hierarchies and drill down. Now, I could talk on and on about this, but I'm just gonna start reading because I've been, saying and repeating things a lot. But these are super useful and really important to know. So hierarchies let you organize data into natural levels like country, state, and city. Drill down lets you navigate between these levels inside of a visualization, making reports interactive and explorable. Hierarchies make your visuals feel live. Click, explore, drill into the data, and your stakeholders will think you are a wizard. And I'm not joking. I've had people be like, whoa, I was able to click down into that to the next level. That's a game changer. And so these things get people excited who like data. Creating a hierarchy. A hierarchy is simply a grouping of related fields in a specific order, from broadest to most specific. Power BI lets you create hierarchies by nesting fields together in a data pane. Once created, you can use the hierarchy in any visual that supports drill down like bar charts, column charts, or tables. So here's what that drill down looks like. Once you create your hierarchy, you can right click on it and enable this drill down. So drill down means you're going down further into more specific. So one level down. Drill up, you're going back up to kind of a broader level. And expand all shows multiple levels all at once. You can access these by right-clicking on the data point or use the drill down icons in the visual header, which are like right up here, right up there. Or you can right-click and drill down. Drill downs are one of the easiest ways to impress stakeholders. They love clicking around, exploring the data themselves. So here's our assignment. We have a new CSV file to import. It's geographies. Let's just start by doing that. We're gonna get data. We're gonna go down to text CSV. Let's come up here to geographies and click open. Now, while we're here, we have the country, the state, and the city. We have our broadest to our most specific. So when we make our hierarchy, that's what we're gonna do. Geography, then state, and then city. Let's go ahead and load this. And while that's loading, let's go ahead and come down here. It says in the data pane on the right, create a hierarchy on the geography fields. Right click geography country and create hierarchy. Then add country, then add geography state, geography city in that order. So let me show you how to do that. Let's come over here and let's go to our geographies. And we're gonna go to geography country first. We're gonna right click, come up here and say create hierarchy. You will notice it is its own thing now, but under it, it's only geography country, but now we wanna add the state. So I'm gonna right click on this and say add to hierarchy, and we're gonna add it to that one. And then I'm gonna click on city, add to hierarchy, that one. So now we have country, state, and city in that order. The order does really matter. So let's come back. The order matters. Make sure country is at the top, then state, then city. If you add them in the wrong order, you can drag them to rearrange them within the hierarchy. Now let's go to a new page and name it Geo. So we're gonna say right here, we're gonna go to Geo. I think it's with a capital. So Geo. Insert a clustered column chart spanning the full page. Clustered column chart, I think that's this one right here, and we'll make it go all the way over and all the way over here. Now set your geography population as the y-axis. So geography population, which is right here, as the y-axis. Next, we're gonna set our geography country hierarchy as the x-axis. So now we take that hierarchy that we created and we're gonna add it to the x-axis. Now you can already see we have Mexico, then the states within it, and then we have the city. So let's come down here. At the top of the chart, check the down arrow symbol to turn on drill down ability. So if we come up here, we have these right here. Click on to turn down drill down, which we will. Then if we go up and we go up again, now we're starting at the highest level. So if I click into USA, now I have California, New York, and Texas. If I click into Texas, I now have Austin, Dallas, and Houston. And then I can go back and drill back up. And so that's what this visualization does. It's really useful. You can start seeing the lowest drill down view, a bunch of bars, each for one city. Click the up arrow at the top to drill up, on an individual category to drill down. Play with it until you understand the mechanics, which we just did. And let's rename this and then we'll save it. So now we'll come over here to general and let's rename this. And there we go. So now we're able to drill down. We can also go to the next level in the hierarchy and next level in the hierarchy. And so it just depends. There's a lot of ways to kind of view this and use this, but it's really, really useful. Let's go ahead and save that. And let's go ahead and run our test for the last one in this chapter. All right, there we go. All right, let's move on to chapter 8, which is building dashboards. Everything we've done up till now is leading us to this moment. We've learned a ton about creating the visualizations, but now we need to put all of it together into a dashboard. And that's what we're gonna be doing in this chapter. Now let's start out with dashboard design principles. And here we have a video. Let's go ahead and watch this. If you're building dashboards in Power BI, your design matters just as much as the data, because you can have the best data in the world. It can be perfectly clean. But if your dashboard and your design doesn't actually answer any questions, it's pretty much useless. Dashboards are usually the first thing that people are going to see. They're not going to dig into the data as much as you are as a data analyst. They open the dashboard, they scan it quickly, and then they decide what they're going to do next. So your job is not to show them everything, it's to show them what really matters. And for this, I have 4 main principles. The first principle is that your dashboard should answer one clear question. Before you actually start building out anything, even any visualizations, you should be asking yourself, what am I actually trying to answer? Maybe one of the questions that you're trying to answer is, what do our sales look like this month compared to last month? Or maybe you want to know which product is actually making us the most revenue. These are clear questions that you can answer in a dashboard. But depending on what that question is, it's going to change the layout, it's going to change the design of your dashboard. The second principle is to build a visual hierarchy. And basically what that means is you kind of want to put the more important or the bigger things at the top, because that's where people are going to look first. And then there are going to be visualizations that aren't as important, but they do provide good information. Those ones can typically go at the bottom or towards the right, because we usually scan left to right and we scan from top to bottom. So something like a key metric or a card, that's going to go right at the top. Then you're going to have other key visualizations that are going to answer that most important question. You're going to have that in the center. And then maybe at the bottom, you'll have supporting visualizations as well that are important, but maybe not as important. You'll have those at the bottom. Again, a good visualization is going to kind of naturally guide the person who's viewing it, whether it's a manager or a stakeholder. It's going to guide them to see what is most important to the least important. The third principle is to keep it simple. And I have seen a ton of dashboards that are just insane. And I literally have to go and I have to ask them, what does this mean? What is this conveying? And that makes it not a great dashboard when somebody has to ask and to explain it to you. Maybe it's too many visualizations, too many colors, too many filters, too much text, whatever it is. Sometimes you just need to simplify it so that whoever is looking at it can easily understand it at a quick glance. We're not here to win design awards. I myself am not good at choosing colors sometimes, but I am really good at communicating things effectively in a dashboard, and that's what you should be striving for. The fourth and the final principle is to keep it really consistent. I've worked at a lot of different organizations where they keep things very consistent by giving you templates, and that is fantastic. But you won't always have clients or stakeholders that ask you to do that, but you should do it anyways. You want to keep the colors consistent. If red means bad in one visualization, it should mean bad in another visualization. You should keep everything similar and consistent throughout all of your dashboards so they know what they're going to get when they look at one. Now, I know when you're first starting, this can seem really complex. There's a lot going on and you've never really done it before. So take things slow. Try building out your first visualization and coming back to these principles and maybe simplifying things, making them a little bit more consistent. Try building out your first dashboard and then coming back and improving on those things and keep these principles in mind. All right, so now that we watched that, let's go on and just kind of read a little bit more. So it says dashboards are usually the first thing that people see. Managers rarely dig into reports or tables like an analyst would. They open a dashboard, glance at it for a minute or two, and decide what to do next. That means your job is not to show everything. Your job is to make the important stuff obvious. And that is 100% true. Most managers never dig into the raw data. That's why they have a team of analysts or a team of people to actually go and do this work and to build these things out so that they don't have to go and do it themselves. They may ask follow-up questions like, hey, I see this number is going down. Can you dig into the data and figure out why? But they themselves typically are not going to do that. When dashboards fail, it's usually not because the data is wrong, but because the message is unclear. Before touching charts or formatting, you should think about the goal of the dashboard. Who is this for? What decision should it help make? Now, here's some core design principles. The first one is start with one clear question. How are sales performing this month? Where are we losing customers? Which regions need attention. If the visual doesn't help answer the main question, it probably doesn't belong on the dashboard. And this is something that a lot of people mess up, and you'll see a lot online. It looks pretty, but it answers like 20 different questions, and they're all different things that you're tracking or all different things, and they try to cram it into one small dashboard. It just doesn't work. And so if your dashboard has 20 different things on it, it can be hard to understand or really follow the chain of thought and see what question it's answering. Use visual hierarchy. Not all information is equally important. Good hierarchy usually looks like this. KPIs at the top, primary charts in the center, supporting details below or to the side. Your eye should naturally move from the most important insight to the least important one. And so like we've been looking at, I almost always put cards or KPIs at the top. And then, you have your main ones and your bottom ones. That is almost in every dashboard you ever create. I can't remember the last time I built a dashboard that didn't have some type of card at the top. Next is keep it simple. I will hammer this home for this entire course. If you have too many colors, too many charts, or too much text, it can just be problematic. White space is helpful. It separates ideas and makes insights easier to spot. If you need to explain how to read your dashboard, it's probably too complicated. I myself have done this 100 times, and I'll bring this to someone and they're like, hey, Alex, can you schedule some time so you can explain this dashboard to me? And I'm like, okay, there's a problem already. And so I'll get in there, they'll ask their questions and I'll say, okay, I see what you're saying. Let me simplify this. Let me make this a little more obvious, or let me just redesign it so you, as the manager, can understand it. I'm not making it for me, who knows the more complex stuff. Next, we have be consistent. Consistency builds trust and makes dashboards easier to use. Try to keep the same colors representing the same metrics, the same font sizes for similar visuals, and the same chart types for the same kinds of data. And let's go to our interview. It says, let's say you have a dashboard of 4 charts. Online sales over time, which is a line graph. Total online sales, a gauge with a target. Online sales by country, a pie chart. And online sales correlated to customer age, a scatter plot. Which chart would you place at the top as a KPI and why? Well, there's only one that would even remotely be considered a KPI, and that is a gauge. So cards and gauges are typically ones that you'd have at the top of a dashboard. A line graph, a pie chart, a scatter plot, those are kind of things you need to dig into a little bit more, or that you won't know at a glance. And so those I would not choose. So I'm going to say a gauge. This is because, and I need to spell right. This is because you can easily see at a glance your metrics that you're tracking. And let's try this and see what Boots thinks. Well done, we've correctly identified it. And there we go. Let's move on to the next lesson, which is choosing the right chart. Picking a chart is one of the easiest ways to make or break a dashboard. You can have clean data and a nice layout, but if the chart type is wrong, the insights get lost, or at least misunderstood. The goal is not to use fancy visuals. The goal is to make the data easy to understand at a glance. So common chart use cases. Different questions require different chart types. Here are the most common ones you'll use in Power BI. We have ones for comparing values. So when you want to compare numbers across categories, simple charts work best, like bar charts or column charts. Examples of this would be sales by region, customers by plan type, or revenue by product. Bar charts are super easy to understand, and you can have long category names. Showing trends over time, we're typically going to use things like line charts and area charts. Again, we've talked about this before, but we're about to make a bunch of these, so this is kind of a reminder. Some examples of these would be monthly sales, daily website traffic, and year-over-year growth. I've seen people use bar charts for time series, but it can get very congested with larger date ranges. I personally don't use them for time series at all, and that is true, I don't. But I have seen lots of people do it, and sometimes it works and sometimes it doesn't. It's just best to use line or area charts. Showing parts of a whole. You can use a stacked bar chart or a stacked column chart. You can also use pie or donut, but it depends on the situation, right? If you're using percentages, if there's too many categories, there are caveats to that as well. If your pie chart needs a legend, it probably should not be a pie chart. And what I mean by that is, you can put extra information there and get rid of the legend. You always need to separate it by something, right? You have your values, then you have your legend, which separates them out into categories, but you can get rid of that legend and just keep a pie chart, and you'd still be able to understand what that means. That's kind of what I'm trying to say. Next, we have showing relationships. When you want to see how numbers move together, use charts designed for comparison, like scatter plots and bubble charts. We didn't look at bubble charts. I don't use them a lot. I mostly use scatter plots, but they are pretty interesting. And then we have some examples, which are price versus sales volume, 2 numeric columns, and marketing spend versus conversions. These are great for spotting patterns and outliers. Now, our assignment is a big one. I'm going to actually go to the bottom. We're going to basically be setting this up right here. We're going to start building our final dashboard piece by piece by piece. And to start with this, it's the biggest piece, which is setting up our visualizations. And so we're going to take this slowly. We're going to get all these visualizations onto our dashboard, but we're not going to start making it perfect yet, right? But we're going to get started. And so this one will take a little bit of time, but let's go through it. It says, let's create a CEO dashboard that applies some of these dashboard best practices for now. Let's just pick a theme and get the right charts and components on there. Doesn't have to be perfect. We are just kind of putting it all in there. So let's create a new page and name it CEO dashboard. So let's come in here. Let's add this and let's rename this. Whoops, there we go. We have CEO dashboard. Now we're gonna go to view themes and select the frontier theme. It'll apply to all pages and that's okay. Now, I actually love this theme. If we come over here and drop this down, it should be, I think it's this one. Yeah, Frontier. It's just a nice coloring. I don't know. I just personally like it. This is my personal choice. So that's that Frontier theme. That's where you go for it. Add the following charts or components to the page. Don't worry about position or formatting yet. So we're going to add a CEO dashboard text box in the top left corner. So we're going to go insert text box and then call it CEO dashboard. So if we come over here to insert, there should be a text box right here. And let's actually just back this up just a little bit just so I can see it a little better. So we have our text box and I'm going to put in here CEO dashboard, or I could type it out so it doesn't have the shading from before. I took the formatting. And we're just going to position this up top. Now we're not going to change this too much. Let's bring this all the way up, put it like this. We don't have to change the formatting basically at all yet. We're going to keep it just like this. And I think I accidentally did this one. Let's delete this one. So we just have the CEO dashboard. That's all we have so far. And we don't need to format it. We don't need to make it look like that just yet. Next, we're going to create a card. Now we're going to use this new kind of card and display total revenue after discounts. So let's get our next one. And that's going to be this card with the lightning bolt. So we'll put this right under this, keeping it, at the top, put it right here. And this is going to be our discounted revenue. So it should be discounted revenue. And we can always compare just to make sure it says discounted revenue. This may not be the exact numbers, and that's okay because there could be filters on this or something that I took a screenshot of later. But we have our correct column that we're looking for. Next, we're doing another card that displays the total units sold. So let's add in another card, put this one right under this, and we're gonna do total units sold. There we go, we have 2,000 total units sold. Now let's come back. Next, we're gonna do a stacked area chart, not 100% stacked area chart, that shows discounted revenue over time by month by product category. And it'll say right here, x-axis, use the date hierarchy, keep year, quarter, month, but remove day. So let's go ahead and build that out. In fact, because there's so much to that one, I'm just gonna drag this like this, just so I can see what we're doing at the same time for this one. So we need a stacked area chart. It should be like this, not the 100%, but the stacked area chart. So let's add this one in. We'll expand it in a little bit, but I'm just gonna keep it super small for now so we can get into things and then we'll make it bigger. So it says, we're gonna show discounted revenue over time by month. So let's get our discounted revenue, and the x-axis should be our date. So let's go back up here. Let's get our date on the x-axis, and we're breaking it out by product categories. Go to products and product category. There we go, and that should be in the legend. So this looks good. Let's expand this, and let's just make sure this makes sense. Discounted revenue by year, quarter, day, but in the hierarchy, we're gonna get rid of day. There we go. So that looks really good to me. Let's just kind of collapse this so we can make room for new stuff. Now let's go on to the next one. So we have, and that looks very similar. So I think we got that one right. A clustered column chart that shows sum of session durations by store name. So a clustered column chart. So we'll add in a new one, and that's the 100% stacked. I think it should be this clustered column chart. So let's add this in, and let's see what we're breaking it out by. So we want to say it shows the sum of session durations. So we'll just take session durations. It should automatically apply that aggregation by the store name. So let's come in here. Let's make sure we have sum of session durations. I think that's in the website sessions. So session durations in minutes. So let's take this session duration in minutes, and we're breaking it out by the store name, which should be up here in stores, unless I'm in the wrong spot. There we go, stores. So let's go by store name. And so let's just expand this real quick, and let's just make sure that it looks like this one. And that looks good to me, and it was the session duration in minutes. Next, we need another clustered column chart that shows the quantity of sale, or the count of sale IDs, by the product brand. So same thing, clustered column chart by quantity of sales, and that's the count of sale ID. I gotta remember that, count of sale ID. So if we go to sales, we're gonna do where's the sale ID? We have our sale ID, but we're not going to do the sum, we're going to do the count of sale ID. And then we're going to be breaking this out by product brand. So let's come back. Let's go to products and product brand. And so now we have this one as well. Let's just make sure this looks right. Count of sale ID by product brand and count of sale ID by product brand. So everything looks good so far. We just need one more. So this is a donut chart that shows population by country at the highest level and can drill down. So let's come back in here. Let's add in a donut chart, and we're doing population by country. So we'll do this one, which is our hierarchy. So we have our hierarchy in there. We need the population. Okay, so we're gonna do sum of the geography population. It should be just like that. So this looks good. I think we have all the visualizations we need. They don't have to be formatted at all just yet. We'll do all of that in subsequent lessons. But I think we have all the ones that we are looking for. So I think that's it. Let's make sure. Let's go ahead and save it and run our test. So let's save this, and let's come over here. Let's take this and run our test and see if we got it right. All right, there we go. Let's move on to the next lesson. Let's move on to our next lesson, which is organizing charts. Remember, a good chart hierarchy looks like this. KPIs at the top, primary charts in the center, supporting details below or to the side. Every dashboard. So here's our assignment. Rearrange the components to our dashboard to match the following layout. It says the CEO dashboard title text should have 32-point font. Let's come over here. Let's look at our dashboard. So I'm gonna change this to 32-point font. I don't know why I do these things to us. I'm gonna make this a little bigger. It's okay if it's overlapping. I'm also gonna center it because I think that's how it had it before. But let's go back and let's see. We have our these two right here. Now we have a white space, and that's okay. I even say it right here. We're intentionally leaving the top right blank. We're gonna add slicers there in a future lesson. So don't worry, we're gonna fill that up later. So let's come over here and let's start organizing this. So I'm just gonna put these at the bottom. I'm gonna put these right next to each other. I'm trying to get these to snap together. Let me see, okay, there it is. Snap together. I'm actually gonna lower this a little bit. Then we have these ones. I'm just gonna, whoops, I clicked on something. Let me just make these small for now, just so I can get them out of the way. And I think this one was directly under this. And I'm gonna make it small again, just to fit it in there. Okay, so now we have somewhat what we're looking for. So this is gonna range from all the way to the half point, and this is gonna take up the other half. Then we have sale ID by product brand. And let's come back here, sale ID by product brand, and then this will be down at this half. Okay, so we got an idea. This needs to take up about half of the top. So I'm gonna drag this to the halfway point. There we go. Then this is gonna come and we're gonna get that to halfway and take this about halfway there. This will come halfway there. And last, we're gonna kind of make this halfway as well. But it just gotta format, it takes a little bit of time. And let's get this right here. And we'll match it. There we go. Now let's make this one bigger and all the way to half. And then we'll make this one bigger and all the way to half. All right. This looks a lot more like what we're doing. A lot closer. Is it exactly the same? No, actually this one looks like it's pushing down a little further. But I'm gonna keep it how it is right now. If we need to make changes later on, for example, if we want to drag this down further like that later, we can. but I'm gonna keep it like this for now. I think this looks good. Let's go ahead and save this and let's run our test. And let me make sure real quick. Make sure the edges snap, intentionally blank. Notice how we're following the visual hierarchy, and we've gone through that many times. But let's save it. Let's run our script real quick. Make sure we got this going. All right, and there we go. Let's move on to the next lesson. Let's move on to our next lesson, which is telling stories with data. Dashboards are not just collections of charts, they're stories. Each visual should help guide someone from a question to an insight and then to an action. If charts are placed randomly, the dashboard will feel confusing. When they're rearranged intentionally, the story becomes clear. So I say right here, a good dashboard isn't just a data dump. If I need to communicate a story, I'll often use added notes along with my visuals to help people see the whole picture if visuals alone aren't enough. And that's what I was saying in a previous lesson, is I'll add narration to this if needed. It isn't always needed. Like a KPI is a KPI. It may just be super simple to understand, but if there's a dramatic change in something, sometimes adding context to it is very helpful. So here's what a data story looks like. Start with a big picture. Begin with the most important takeaway, usually a KPI, a summary number, or a high level trend. What is happening right now? Then we're gonna add context. Once the main takeaway is clear, add visuals that explain why. This might show breakdowns of categories, comparisons across regions, or changes over time. A good dashboard feels like a conversation, not a dry report. Next, we highlight the impact. So we're gonna call out problem areas, show where performance is strong or weak, or focus attention on outliers. Adding a text box next to a visual to provide additional context can be helpful when the visualization alone doesn't tell the whole story. Now next, this is going to lead to action. The best dashboards help someone decide what to do next. This might include filters to explore problem areas, supporting charts for deeper investigation, or clear indicators of success or failure. How does this relate to us? So we have our big picture, context, and breakdown. The big picture are the cards. The big picture are the cards at the top showing total revenue and units sold, the key metrics. Then we have our context. In our dashboard, this is the area chart to show how revenue has been trending over time. Lastly, we have a breakdown, which are our column charts at the very bottom. These column charts show which stores and products drive the most engagement and revenue. So it says which sequence best represents an effective way to tell a story with a dashboard. And we can see this right here, but it starts with a big picture, then you add context, and then this leads to action. We also have show all charts at once, then explain them with text, or begin with detailed tables, then summarize at the end. I think it's going to be this first one. Let's go ahead and click on this. All right, let's move on to the next lesson. All right, now we're going to start working on our dashboard again, but we're going to be formatting everything properly, and that's going to take some time, but we're going to make it look a lot better. Formatting is what turns a dashboard from usable into professional. The data and charts might already be correct, or formatting can make everything harder to read and harder to trust. Good formatting usually isn't very noticeable, but when it's bad, people will notice. If someone notices the formatting is off before anything else, there is a problem. I've seen it. People have called it out in like meetings. They're like, hey, why does it say that? And people pick up on the issues very quickly. First, we're gonna do our titles and labels. Then we have alignment and spacing, and then we're gonna actually get to our stuff. But for titles and labels, we wanna describe the insight, not just the metric. So we wanna make sure they're short and clear, and they match across similar visuals. Bad titles usually look like raw field names or technical terms, which is exactly what we have right now in our dashboard. Next, we want alignment and spacing. We want to align the visuals to each other, keep spacing consistent, and avoid overlapping or crowded visuals. White space can help separate ideas and improve readability. So we have a lot of things we're gonna do. I am going to pull this up, but I'm gonna pull it over here and just get rid of our visuals and data for just a second, just so I can see this at the same time. And we might open these up so we can change some of these, but we have a stacked area chart. So we want to change this. We're gonna change this to revenue trend by product category. So I could copy that, but I'm just gonna come in. But we're gonna click on this and we're gonna come in here and we're gonna say the title is revenue trend by product category. I'm a phonetic speller. I need to hear it while I say it. We're also gonna increase that size to 16 and set it to center alignment. It's gonna be like that. This looks a lot better. This is a very quick change that dramatically improves the readability and understanding of this visual. So it's something small, but it is really important. Next, let's go to our session durations by store. This is our column chart. So this is the session durations minute by store name. So let's click on this. We're gonna call this, gonna come right in here. We're gonna say session duration by store. And again, we're gonna increase this to 16 and then center align. Next, we're gonna go to the sale ID by brand product. This is our next column chart. We're gonna call this sales by brand. So we'll do sales by brand, increase it to 16, and you guessed it, center alignment. And then last one, we have our donut chart. And within our donut chart, we're gonna name this one population drill down. I think by now you know what's gonna happen next, 16 and center alignment. So this all looks really good. Let's just expand this for a second. This looks much better than it did before. It was very messy with the titles, and now they're all centered. They all look really nice, and that's what we want to see. We don't want it to be too messy. I think we left too much space up here, if I'm being honest. I'm gonna bring those to where you can just read it, and we'll match that. And then I'm gonna bring this up. This is gonna drive me nuts if I don't. I'm gonna bring this up to match. We can click out of there. And then I'm gonna bring this up to match. I just think there's too much white space up there for what we're gonna need later on. All right, anyways, now we're gonna update our data labels. To update these, in the Add Data to Your Visual tab of the Visualizations pane, double click on the name of the data column to change it. It's the place where you dragged it to add it to the chart in the first place. So what that means is like right here, it says year, but if it says something else, these X labels and Y labels can just be really verbose. And so we wanna simplify these. Again, I'm gonna do the same thing where I kind of minimize this right here. All we have to do is, we're gonna start with our revenue card, but we're gonna come right here. All you have to do is double click on this and you can just change it right here. Makes it super easy. We're gonna call this total, I need to spell that right, revenue, and just cleans it up. You notice it doesn't have the underscore, it's not all lowercase, things like that. Now we have our total units sold. Let's click on this and let's call this one total units sold, just formatted better. That just looks so much better. It's a small thing, but it is really useful. Now let's go to our area chart, and you'll see right here on our Y and our X, year looks fine, but discounted revenue doesn't look good. We're gonna change that Y axis to revenue. So we'll come down here and we'll call this revenue, just like that. Again, cleaning this up. Let's go to, we're also gonna change this product category, and we can do that right here in our legend by saying product category, and that looks better. Next, let's go to our session duration column, which is right over here. And instead of store name, which is what we have now, we're gonna say nearest store. And in that same one, instead of total sum of session duration minutes, we're gonna call this total session duration. And that looks a lot better right there. Next, we're coming over here to this one, which is our sales by brand. So instead of product brand underscore, we're gonna do product brand in uppercase. So product brand, notice everything's in similar format. We're using proper case for everything. Next, we're doing quantity of sales for these instead of the count of sale ID. So we're gonna do quantity of sales, and that looks a lot better. Last, if we come over here, if we look at this population drill down, we have it, the title well. We also have geography underscore country. We're just going to leave that. Geography country, geography state, etc. We're leaving that as is. So we're not touching it. This is already cleaned up immensely. Like the formatting is 10 times better now. You can read everything. It's not super messy with a lot of underscores everywhere in lowercase. This looks really good. It's really standardized. If we come in here, all we have to do now is submit or save and submit. So let's copy this. Let's come in here and let's save this. There we go. And let's run our test. Uh-oh. What did I do wrong? It looks like I got something wrong. Let's come up here. It looks like in our clustered column chart, I did something wrong. All right, let's go back and let's double check this. So it looks like I maybe got the title wrong or something like that. Let's just go check, because it's very possible I did that wrong. Session duration by store, sales by brand. Let's see, sales by brand, session durations by store. Maybe I did spell that wrong. Maybe I had session duration. Let's do session durations, and let's see if that's the issue. There we go. Let's go ahead and save this. Let me just check and see if that is the issue. Yeah, durations and sales by brand. Okay, let's see if that was the issue. Maybe it's just a spelling error. And it wasn't. Looks like there's a bigger issue. Looks like our total session durations and quantity of sales. I think I'm spelling things wrong is my guess. Total session durations. I'm guessing that's what's wrong here. Let's add the S and let's save this. Hey, listen, I need to learn how to follow directions if I'm being, if I'm being completely honest. Let's try running this again. All right, let's go back. Let's see what else. Did I spell quantity? Sales. Total session duration. Okay, let me try this. And let's go ahead and run that. And there we go. And let's move on to the next lesson. All right, let's move on to our next lesson, which is legibility. Text should be easy to read from a distance. Try to use one font family. I have seen it where people use just the weirdest fonts. And people like to get creative. I understand that. But when you're giving this to like a CEO, it's probably best to keep it pretty simple. Keep similar visuals using the same text sizes. Make key numbers slightly larger than supporting text. Small, inconsistent text are one of the most common dashboard issues. So let's look at our assignment. So it says, we have a big problem with our current dashboard. The names of the stores and brands are hard to read, and the KPI numbers are rounded to nearest thousands. Yuck. Update the cards to show the whole number values. Do this for each. So we're gonna go to the card, format your visual, call out, apply settings to pick your measure value. That's a lot. All right, let's just do this. Let's just pull this over so we can follow it one step at a time, and we can do this together. We have this 0.28 thousand. So we're gonna click on our card. Let's go to format your visual. We're gonna go down to general, data format, and then we'll come down. We're gonna go to format options. And here we're gonna go to the whole number. Now we also have toggle thousands separators is on. So we're gonna come here, I'm gonna say on just like that. So we're gonna come over here to the visual and we'll go down to the call out. So under the call out, we're gonna apply settings and then we have our card, which is the total revenue. Then we're gonna go down to value, and for the display units, instead of auto, it says we're gonna use none. So let's click on none here. So now we have our number, but we don't have a comma, right? And we're gonna do the same thing for both. So we're actually gonna come here, and for the call out, total units sold, we're gonna come down here and say none. So these numbers look good, but the next thing we need to do is we want to add this separator. So we're just going to go to general, go to data format, and then for the format, we want the whole number, but if it isn't whole number, make sure it's whole number. And then for this, we're going to do 1,000 separators on, and we'll do the same thing right here. So let's come down to general. We have our format. We're going to make sure it is a whole number and then 1,000 separators on, just to make it look really nice, right? Keep it simple, keep it the same. Let's expand this and let's go down. It says shrink the card sizes vertically and grow the bottom 4 charts to take up some of that extra space. We kind of already did that, if I'm being honest. We also could shrink this a little bit if we want to make more room, which we absolutely can. So we can always bring these up and then make these taller. And that does give us more room. Let's just make sure they all snap together. I'll bring this up a little bit. I think this looks good. We'll keep it how it is. Click on each visual and add a border. So we're gonna go to general, effects, visual, and border. Now here's what I'll say about borders in general. It really is dependent on your company. I've worked at companies where they do not like borders at all. And I've worked at companies or consulted for companies where they have a border for every visual. And it is very much just a stylistic thing. That's it. And so we will add a border because that's what we're supposed to do. Let's come in here. Let's just try this on our first one. So we're gonna go to general, we're gonna go to effects, and we have our visual border. We're gonna say on. That's all we're gonna do. And so we're gonna do that for each one. And effects and visual border. And then effects, visual border, effects, visual border, visual border. It's pretty easy now because it's just saving it. There we go. So now we can see kind of how it's broken out. We have the lines kind of separating everything. I don't know why this thing is on this right-hand side, if I'm being completely honest, but it looks really good. Let's go ahead and save this. So we'll save, and then we'll come down and let's run our test. All right, and there we go. Let's move on to the next lesson. Test. All right, everything looks good. All right, let's move on to the next lesson, which is interactivity. Now, this is what separates static reports from real dashboards. Instead of just looking at data, users can click, filter, and explore on their own. The goal is not to add as much interactivity as possible, but to just make it more useful. A good interactive dashboard lets someone answer follow-up questions without leaving the dashboard. Basically, they can click into data, they can filter the data, they can actually use it instead of just looking at it and having to then come to you and ask more follow-up questions. They can kind of dig into it themselves. So here we have slicers. We haven't looked at slicers yet, but slicers let the user filter data without touching the underlying model. You can use date ranges, regions, or product categories. Those are just examples, but these are ways that you can use slicers, and they're really useful. We can also use cross-filtering and highlighting. So Power BI visuals interact with each other by default. When a user clicks on one visual, other visuals filter or highlight automatically. Patterns and relationships become easier to spot. This is one of the most powerful features of Power BI and often requires no extra setup. We've accidentally done this as we've been going on, where I accidentally click on a certain part of the visual and it filters out other pieces, which is really nice. Drill down and drill through. The drill down feature allows us to move between levels of detail. Drill down is useful for moving from year to month to day, category to subcategory. And we've added one thing within our donut chart that has a drill down. So it's great, but only if people know it exists. Lastly, we have something called a tooltip. Now this again is, can be very useful. A tooltip shows extra information when they hover over a visual. They're used for adding context without cluttering the dashboard, showing supporting metrics, providing definitions or explanations. And I'll show you how to do a tooltip. It's pretty easy, but you can add other information that isn't in your visual, but when you hover over it, it has it in there if they want to see it. Let's start with a slicer. We're gonna add 2 slicers in the upper right. So let's go ahead and do that. Let's just come in here. We'll add in our slicer. Where's our slicer? Which should be right here. And let's take it up the top half of the section, kind of like this. And then we'll add in one more slicer. And we want it right in here. There we go. We may need to resize these or reformat these, but that should be a good start. We're going to drag the date into the top slicer. So let's go and select our date, which is right here, into this top slicer. And that looks fine. It's going to automatically display this as a date range slicer, but it should actually look like this. So let's come in. And it doesn't tell it. It should have auto-detected, if I'm being honest, it should have. But we have everything that we want. We just need to change the slicer settings. So what we want is, we don't want tile before, after. Let's try relative date. This may actually be the right one. It is the right one. I apologize. It's the right one, it's just too small. We need it to be larger. So let's do it like this. So it did choose the right one. If you want to change it, you can come in here under the slicer settings and choose like this one. This is before, or this is the after, and it kind of blocks out other options. So it's just different options, but we have this between. It was the right one. We just had to resize it. Now let's go down. And now for our other slicer, we're going to drag the customer region. And so let's come in here and let's get our customers. I think that's actually in our customers table up here. Customers region, we're gonna drag that right in there. Now we don't want this vertical list, I'm almost certain. We're gonna go to Format, Slicer Settings, Option Style, Tile. That's the one we want. We want the tile. So let's come in here. Instead of vertical list, we'll choose a tile. And that looks much better. So when we actually click on this, it's going to select this different region. And so it can be just really great for anybody using this. Just click on it and say, oh, I want to look at, our customers for the South. And then they can come over here and look at our revenue just for this region. And since we have all of our data connected via our data model, it all is just really fluid and easy. So as the tile makes it easy to select, it feels more like buttons, which is easier for users to use at a glance. Test this out by clicking on a region. For consistency, add a visual border to these slicers as well. Well, we just tested it. They all look good. Let's go to our general effects, visual border, and we'll add a visual board to this as well. And that should be good. So this also, you can select and kind of drag this for your date ranges, and then it'll change this as well. So just super useful, right? Let's go ahead and save this, and that looks good. And let's run our test. make sure we did this right. And there we go. All right, let's move on to the last lesson in this chapter on dashboards. And we're gonna take a look at filtering. Now, filtering controls what data people see when they open and interact with a dashboard. Good filtering makes dashboards feel focused. Bad filtering can make them feel confusing or broken, especially to people who haven't used filters before. The idea is to show the right data by default while still allowing flexibility. If users constantly have to fix filters, the dashboard is doing too much. And we've looked at filters in the past. Filters are 100% requested all the time for different stuff, right? They like your visual, but they want to filter on this, so they want to filter on that. So we're going to add some filters. We have our report level filters, which apply to every page in the report. They're useful for when the dashboard is meant for a specific audience, or certain data should never be shown, or you want a consistent default view. Examples include filtering to a single year or excluding test data. Then we have page level filters. They're going to apply to the current page, the entire page. These work well when different pages answer different questions. Each page focuses on a specific topic, or you want control without affecting the entire report. And lastly, we have visual level filters. They only affect one visualization at a time. These are helpful when a chart needs a specific subset of data. You want to highlight top or bottom values, or one visual should behave differently from others. Visual level filters are powerful but easy to forget. Always document or label them clearly. I don't use a lot of visual level filters, if I'm being honest, because of that exact reason. Most people don't know dashboards well. They don't know behind the scenes and how you created them and all these things. And so typically the only time I'm using that is when it's specifically requested by, whoever's using this dashboard. I won't add those typically myself. Default filter states. Filters are not just for interaction, they also define first impressions. A dashboard should open in a clean, intentional state, no confusing filter combinations, clear default selections, and predictable behavior when filters change. So here's our assignment. We're gonna add a bunch of filters, is essentially what we're gonna do. Let's open this up. Let's bring this over. Well, we may need the data, but let's bring this over to where we can basically see everything, because I want to be able to see this while I'm working. So we have our filters right here, filters on this page, filters on this visual, and filters on all pages. So on the CEO dashboard, ensure you can see the filters pane. This is the filters right here. Drag sales and sales discount. So we're gonna take the sales and sales discount right here. We're gonna add that to a filter on this page and set the filter to greater than 1. So we're gonna say is greater than 1. And you put it right here. Is greater than 1. We can apply this filter. And not greater than 1, whoops. Greater than 0, because it won't show any. So there we go. So it's greater than 0. Next, we're gonna select the sales by brand bar chart. So sales by brand is right down here. We've selected just this visual. Now in the filters pane, find the filters on this visual, which is right here. We're gonna change the filter type to top N. So under the product brand, let's come in here. We're gonna use top N. So now we can show, let's say the top or bottom 50 or the top or the bottom 100 brands, and it'll do that calculation for us. So we're gonna do the top 3, and we're gonna do that on the sale quantity. So let's actually get that first because I wanna have that. So on the sale quantity, we wanna do that on the top 3. Let's go ahead and apply this. So now we're just showing the top 3 brands instead of maybe 4, 5, 6, 7, 8 brands. We're just filtering on the top. And that is very common with categorical stuff, especially when you have 20 different brands. You only want to show maybe the top 6 performing or top 5 performing ones. So this is great for focusing attention on what matters most without cluttering the visual or the dashboard. Next, click somewhere on the canvas to not select that anymore. And we can verify that the page filter is still active. And now we can save this report. So let me just come right here. It says, notice how the page level filter or the discontinued sales only affect all visuals, while the visual level filter, the top 3 categories, only affects the bar chart. Understanding this hierarchy is key to building effective dashboards. So if we come in here and we just look at filters on this whole page, if we start filtering and doing other things, it's gonna affect all of them. While as this one, which is filters on this visual, only affects this visualization. So this looks good to me. Let's go ahead and save this, put that over, and let's come and run our test, make sure we did everything right. And there we go. Awesome work on the dashboard. All right, we are moving on to the very last chapter in this entire course. We have done a lot of work up until now, and now we're just looking at collaboration, how you can actually share this with other people and how people can use the dashboards that you have created. So this first part is sharing and publishing dashboards. Once a dashboard is built, the next step is getting it in front of the right people. Dashboards are meant to be viewed, explored, and used to make decisions. If no one can access them, they don't provide much value. Now, there's a lot to Power BI. We're just on Power BI Desktop, but there's Power BI Desktop versus the Power BI Service. Power BI Desktop is where you build dashboards. It's what we've been using. Power BI Service is an online app where people can view and interact with your dashboards. A typical workflow looks like this. You build the report in Power BI Desktop, you publish it to the Power BI Service, and you can share it with others, or you can share it within your team or that workspace. Just depends on how your company is set up. Most collaboration happens in the Power BI Service, not in the desktop. That's just where you're building it. So publishing a dashboard. To share a dashboard, it must be published. In this course, we're using the free Power BI Desktop version, which is great for building and learning, but unfortunately, publishing reports to the Power BI Service requires a paid Power BI account. Now, if you work at a company where they have that paid account, you're gonna do that. You're gonna come up here and you're gonna be able to share it and publish these things. And you can publish it here and you can share it as well. But we don't have a paid account, and I don't want you to go and get a paid account just to try this. It's pretty straightforward if you've ever published anything else or shared any code or anything like that. So all you have to do is open a report in your Power BI Desktop, click publish, and choose a workspace. And once it is published, the report becomes available in the Power BI Service and can be shared with others. Workspaces and access. Workspaces are where reports and dashboards live in Power BI Service. Common access roles include, you can be a viewer, a member, or a contributor. The viewer can just look at it and interact with it. Then you have a member who can edit and publish it, or the contributor who can actually update the content, but with limited permissions. Choosing the right role helps to protect your work, and that is not a joke. There have been times where we've given people the wrong permissions, they've accidentally deleted something. And I'm like, okay, let me go fix it. No worries, let's change that person's permission. Most people should just be viewers. Editing access should be limited. Personally, I don't want anyone to change my dashboard that I've worked hard on. Let's go ahead and watch this video. It's a longer one, but let's go ahead and watch this. Building a dashboard is important, but people need to actually use it and share it and be able to collaborate on it to make it really useful. And luckily, Power BI has all this already built in. So what we're gonna do is talk about not only the technical side, but also the people side of collaborating with dashboards. First, it's really important to understand the difference between Power BI Desktop and the Power BI Service. The Power BI Desktop is what we've been working with. This is where we model our data and we clean our data, and then we actually visualize and create the dashboards. But when we actually want to publish, share, and get feedback on it, that's where we're gonna push it up into the Power BI Service, which is basically Power BI's app to be able to share your projects. Now, publishing to the Power BI Service does require a paid account, and we're doing everything with the free desktop version, so you don't have to do this. If you want to, go ahead and get a paid account, and you can actually practice publishing it and putting everything up there, but it's not super complex, so you don't have to do that. But if you want to, you absolutely can. With that being said, it is important to understand things like workspaces and access within the Power BI service. Workspaces are where your dashboards are going to live. So you're gonna publish them in your dashboard, you're gonna put them into a workspace, and that's where people are going to view them. Workspaces also control who has permission to see these dashboards, because maybe it's only a specific team. Maybe there's really proprietary data or HIPAA compliant data or whatever kind of data that you can't share with a lot of people. So you can only have specific people who can access this. That leads directly into access, where you can give them the type of permission that they have to view it. Some people are just gonna be viewers, where they can just see the dashboard. I would say that's gonna be the majority of people. Now, if you're actually collaborating with another BI developer or another data analyst, then they may have something called a contributor access. This is where they're gonna be able to edit and publish the content just like you. So be sure to only give that to people who you actually trust, and they aren't gonna go and ruin your dashboard that you've spent a lot of time creating. Again, that part is really important, because I've given incorrect access to people before, and they've gone in and they've made changes themselves that I never would have made. And so be sure you give the right access to the right people. Usually, not always, but usually you're gonna have some type of sysadmin who's gonna give out permissions anyways that may not be you, but it is a good concept to understand. Now, once you publish this dashboard and people actually start looking at it, they may comment on it, they may actually want changes to this. And that is a very good thing, because that means that your dashboard is useful. Now, they're gonna ask for a lot of changes, and I'm just gonna be completely upfront with you. They're gonna ask for a lot of changes. But not every change is something that you should do, because I've had people who come in and they're like, hey, I want to filter for this, I want to filter for this, I want this type of visualization. I used to just do everything they asked because I didn't know any better. I just used to say, okay, if that's what you want, then that's what I'll give you. But depending on what that request is, it could ruin your dashboard. Maybe there doesn't need to be that filter or that slicer or that extra visualization. So oftentimes what you have to do is you have to really understand what they're trying to do with that addition. What are you trying to get from it? Why do you need that? What changes can we make to maybe make the change smaller instead of redoing 3 different visualizations? So understanding the root of the request is really a skill that you need to learn as you start getting these requests. The next thing to remember when you're collaborating with people is to set expectations. I used to have a lot of people send me lots of messages wanting things. They would need it immediately. They're like, I need this change today. And I would go and do it today, and then they wouldn't look at it for like a month because it wasn't even a really important dashboard or a really important change. Or this is like a monthly or a quarterly dashboard that they would check once a quarter. And so I didn't need to get it done that day, but the expectation was that I was just gonna do it because they asked. What I do now is I get the request, I see, okay, this request doesn't need to be done for 3 weeks. Hey, I'll get it done by X date. That's just me setting expectations so I don't have to hurry and get something out right away that really doesn't need to be done for a long time. These types of requests can come in a lot of different ways. They could be outside of the Power BI service, so they're gonna send you an email. They may also just message you on Discord or Slack or something like that. But they also can comment directly on the dashboard within the Power BI service. And so if they comment on it, you can usually go and you can respond to it and kind of have this paper trail. But there's a lot of different ways that people are gonna message you. Even if you tell them, always comment it on the Power BI service, they're gonna shoot you a message anyways, because that's just what people do. The last thing to remember is that your dashboard is not just some static charts. It's living data. It's real data that needs to be refreshed and things need to happen to get there. And you aren't just showing charts, right? You're communicating data. So being part of meetings and being part of this process, even before you start building visualizations and after, is a really big part of what a data analyst does. There may even be times where you're going to present and give a presentation on these dashboards. I've done that myself many times where I create it and then they want me to explain it and they have questions on it and they have feedback on it live in a meeting, not just online in the comments or through Slack or Discord. So just remember that these dashboards are not static. They may be something that you set up, but oftentimes if they're important, you're gonna get a lot of feedback on these things. And so be sure to keep up to date with these dashboards. Make sure you're checking on them. Make sure you have monitoring systems in place to where if one breaks down or maybe the data pipeline to get the data fails, that you know about it, because people rely on these dashboards for a lot of decisions that they're gonna make. As you can see, collaboration takes both the technical side as well as the people side. You kind of have to have both. You need to know how to publish it and where to put it and how to get people access, but you also need to be able to hear their feedback and make those changes. All right, what a beautiful face to end that one on. Let's go to our interview with Boots. It says a teammate asked why they can't just share a Power BI desktop.pbix file with executives instead of using the Power BI service. Explain the purpose of Power BI Desktop versus the Power BI service and when each one is used. So for me, I would say that sharing a .pbix file doesn't allow for data refreshes or people to access new things added to the dashboard. The Power BI service allows you to make updates and for them to see it. All right, let's try that and see what Boots thinks of that. I think I made a spelling error somewhere. I did my best. You're touching on the real advantages. However, I'd like you to dig deeper into the distinct purposes. Let's keep going. The lesson draws a clear line between what each tool is designed for and the typical workflow. Think about it this way. If Power BI Desktop and Power BI Service each have a specific role in the process of getting a dashboard from creation to hands of executives, what is each one responsible for, and where do most people actually view and interact with that dashboard? So let me be more specific. The desktop is more for building and creating the dashboards. The Power BI service is more for sharing and letting people use and access the reports to make decisions. Let's see if Boots likes this one. So maybe I was a little too vague earlier. Excellent, that is exactly right. And there we go. Great work. Now let's take a look at scheduling refreshes. As you know, you can click the refresh button in the home ribbon to refresh your data in Power BI Desktop. We tried that earlier when we were looking at our data model. But when you publish your report to the Power BI service, you can also set up an automatic refresh schedule. This keeps your reports current without the need to manually open Power BI Desktop and click refresh. Why scheduled refreshes matter? Dashboards are only useful if the data is current. Imagine a sales dashboard that shows last month's numbers when stakeholders expect to see yesterday's results. They'll lose trust in that dashboard quickly, and that actually happens often where people are checking these dashboards a lot, but a pipeline breaks or something, the data isn't refreshed or the data isn't there to be refreshed. And that's where, a lot of the work is also involved afterwards. So scheduled refreshes solve this automatically by pulling in fresh data in regular intervals. Just a reminder, your data source must be accessible from the cloud for scheduled refreshes to work. If your data lives in a local file or behind a paywall, you need a data gateway. And this is more about like the data engineering side of things, right? Getting access, having connectors. We just use CSV files, but you can connect to databases and all these other data sources. Again, you don't need to do this now, but just so you know the process, you go to the dataset, click on the schedule refresh icon, settings in the schedule refresh, choose how often and at what times to refresh, which is daily, weekly, monthly, configure the data source credentials if needed, and here's some, common refresh frequencies is what we call it, but oftentimes you don't need it this often. Like real-time metrics are rare. Daily sales data is fairly common. I would say weekly reports are the most common, and then historical analysis is, it happens, but typically you're working with either daily or weekly updates, or sometimes even monthly. Just depends. Now, why are scheduled refreshes important for Power BI dashboards? Number one, they keep dashboard data up to date automatically without manual refreshes. They improve chart formatting and visual design. Definitely not. Or they allow users to edit dashboards in Power BI Desktop. Definitely not. It's gotta be this one. And there we go. In our very last lesson of this entire course, it is collaborating with stakeholders. Now, building a dashboard is usually not the end of the process, although you may think or wish it was. But once people start using it, questions come up, feedback is shared, and changes are requested. This is where real collaboration begins. So you have to gather feedback. You're gonna build this dashboard based off what they initially said. And then once you build it, they're gonna want 20 different things, or they're like, oh, I actually don't need that, I need this. So common types of feedback include requests for new metrics, questions about how numbers are calculated, or suggestions to change layout or visuals. Try to understand the questions behind each request. Often the real need is clarity, not another chart. When someone asks for a new chart, I always ask, what decision will this help you make? Sometimes the answer reveals they just need a filter on an existing chart. 9 times out of 10, and this has been my experience, is when somebody starts complaining about something and they want this and they want this and they want this, if you start asking it because you know it kind of better than they do, how everything's working and connecting, once you really know what they want, sometimes it's just a really easy fix. And so, you don't always have to change or do everything that they say. Iterating without breaking things. Dashboards should evolve, but changes should be intentional. Good practices. Make small changes one at a time. Test updates before sharing again, very important, and avoid consistently changing definitions or key metrics. Frequent small improvements are better than constant full redesigns. I recommend maintaining a stable version while working on updates, just like any coding that you would do, right? You aren't gonna push it to main if you guys are about like Git and stuff. You're not gonna push it to main right away. You're gonna branch out, you're gonna test and branch, and then you're gonna merge it back. Setting expectations and boundaries, very important. Not every request should turn into a dashboard change. It's usually a matter of clarification for the user so they can understand how the dashboard works or what it shows. It is okay to ask why a change is needed, push back on unnecessary complexity, or explain trade-offs clearly. Clear communication helps prevent dashboards from becoming bloated and confusing. Remember, you're the expert and you need to decide whether something gets added or not. And I will tell you that has caused issues in the past where someone has come to me and they're like, I want this change. I'm like, you really don't need it. Like, if I add it, here's what's gonna happen. This is gonna have to change, this is gonna have to change, this is gonna have to change. If we add that other data set, it's not connected to our other data because there's no way to join it. There is more complexity than just adding something. And so you're the expert, you need to know what's gonna break or what the benefits are, and you need to kind of demonstrate that clearly. Communicating insights, not just charts. When reviewing dashboards with stakeholders, Walk through the main takeaways, explain what has changed since the last version, and highlight areas that need attention. This helps to ensure the dashboard leads to action, not just observation. Now, let's do our last interview with Boots. A stakeholder reviews your dashboard and asks for several new charts and metrics. You're not sure all of them are necessary. How would you handle their feedback while keeping the dashboard clear and effective? The first thing I'm going to do is I'm going to ask follow-up questions. Why are these changes needed? I'll look at how they fit in the current data model and if they're possible. If the request looks good, I can make a change, but if it doesn't make sense or would break the dashboard, I would walk them through it. Let's see what Boots thinks of this. I could have written paragraphs on this, but let's see. So it says, a solid start and appreciate the practical mindset. You rightly identified the asking why as an important first step. Digging into the intent behind each request is critical. You also touched on pushing back when something doesn't make sense. However, there's another dimension worth considering. Sometimes a stakeholder request might be valid in its intent, but the specific solution they're proposing, say a brand new chart, might not be the best way to address their underlying need. Think about it this way. If you understand what they're really trying to accomplish, what might you propose instead of simply accepting or rejecting their request outright? I might propose or just see, is a filter available that we could use? Could I just retrofit an existing chart? So that's what I'm gonna say. I'm gonna say, I would see if an existing chart works better or can be changed slightly, or if we can use a filter instead of adding more charts. Excellent. This completes the picture nicely. And there we go. Awesome work. So that is the end of our Power BI course on Boot.dev. I hope you enjoyed it. We put a lot of love into this course. I had a lot of fun walking through this, and I hope you did too. If you've just been following along on this YouTube video, I highly recommend going on to Boot.dev to actually check out the course because it is a lot of fun going through it. If you like this video, be sure to like and subscribe, and I'm sure they're gonna have some awesome other tutorials and courses in the future.